Okay. Okay, it is working. Good morning, everybody. We'll give some more people a few more minutes to come in and let Chris get off the phone. So do we have any Marines in here? Anybody from Marine Corps? If you are, today's a Marine birthday, so Semper Fi, happy birthday. And tomorrow's Remembrance Day for World War I, so just thought I would bring that up. Anybody's veteran, thanks for your service. All right, we'll go ahead and get started. My name's William Lewis. I'm chief engineer for SABIC. Badar Alam also is, another co-chair. He's with Chemours, which was a spinoff of DuPont. Badar is actually, he got ill. He come down with something, so he's not going to be able to be here today. So wherever you see Badar, there's his picture. That's what he looks like. He's not here today, and so we have people filling in for all his places. So today there's no fire drill scheduled. So if there is an alarm, it's probably a real thing. And our evacuation route would be out this door. You turn right around past the restrooms, and there's a stairwell there. Go down. Don't use the elevator. The muster location, if you remember, right in front of the main lobby, there's a fountain there. So we would meet out in that area there, that circle area. That's where we would muster. Bio facilities, you go out the door immediately right, and men's and ladies facilities are there. The COVID protocol, I think Marriott used to, I think it's easing up a little bit, but if you're fully vaccinated, it's up to you whether you wear a mask. And they say if you're not vaccinated that you probably should be wearing a mask. So that's the protocol for Marriott facilities. I want to talk about, I hear a lot of people say, well, you can't modularize this. And, this is an ammonia urea plant. You can't modularize it. And I think about it, I think, well, it's steel, it's equipment. And why can you not modularize it? And the answer I get back is, well, no one's ever done it. Well, there's a lot of things that where we haven't been, we've not done it before, but we stepped outside the box, we innovate and we do things. But I want to bring this a little history up, and this is during World War II. When the United States was drawn into World War II, I mean, we were going up against two worthy adversaries that had years to build up their military. I mean, Japan and Germany had been building up their military for years, and we got pulled right in, and we had to step up to the plate really fast. And so Franklin Roosevelt, who was the president at that time, I lost him. Let me go back here. There you go. Sorry. He was the president at the time. He appointed Bill Knudsen, and I don't know if any are familiar with Morrison Knudsen, which I think they've been bought up or absorbed. They used to be out of Cleveland, Ohio, but anyway, to drive the process to bring America up to the war effort needs, which was building aircraft, ammunition. They needed these Liberty ships to supply the forces in Europe and also so Bill Knudsen went to Henry Kaiser, who was well known in the shipping industry, and said, we need 500 Liberty ships. Well, when they first started, looking at them and coming up with a strategy, there was no way that they could keep up. So he went to Henry Ford and studied the assembly line process, the lean process, and incorporated a lot of that into his offsite construction and building, these Liberty ships. And it was, obviously it was schedule driven. So they adopted a modularization strategy. He got that from Henry Ford. They started building all the sections of ships and then bringing them all together. And, applying offsite fabrication, modularization, and innovation, 18 shipyards were able to build 3 ships every 2 days, exceeding all the government expectation. And they did that through offsite, understanding, better planning, modularizing things and bringing them all together. But on November of 1942, the Robert E. Perry Liberty ship was assembled in 4 days and 15.5 hours. So when we think about modularization, this is really nothing new. We have a lot better tools now, with our electronics and our modeling, our scanning, all our computerized software and equipment that we use in our module yards. So, it's the same philosophy. We just have a lot better techniques and tools to do it with. And, I always say, position yourself for success. So right now we need to look at what we're doing, how we're building it, and position ourselves for success. The offsite construction and modularization charter and the value we think we bring at CURT and with our CII partners is to resource, organize, and leverage resources within the construction industry, partners and consortium in order to provide CURT members with the tools and resources to support, improve, and accelerate efforts related to successful implementation and delivery of offsite fabrication modularized construction. So, we're working together to try to give everybody what they need. A lot of the things we do is feedback from the owners and our members. Is what do you guys need to see? So we'll solicit you, throughout this whole whole day of the workshop and get information from you, what you need to see, what would make you better. And so we did a survey in 2017 with all the owners and contractors and vendors, and we redid that in 2020, and we worked with FMI, CURT, and CII, and I'll go to the next slide here, and here's what we some of the feedback is changes happen, and most people say that they're still getting increased pressure on controlling costs. Obviously, that's a big thing, and increased pressure on schedules. People want to know schedule predictability. That always bothered me when you start talking to a project team and they say we're slipping, and you say, well, how are you slipping? Why are you slipping? Well, we really don't know. How long? We really don't know. We're still evaluating. And you go back the next week and they're still evaluating. And the next week they're still evaluating. It's like, this is frustrating because you obviously don't know when you're going to finish, right? And then shortage of skilled labor on sites. And this is still an issue. And I think COVID has probably, exacerbated that. I mean, it's everybody I talk to, they're still concerned about getting the right competent people to work their jobs. I've heard from some of our members here recently that even module yards and the fab shops that they may have to buy space because they're getting really busy now. So that was the top three, and then quality issues. But this was our survey that we did. And here's the agenda for today. I'm just going to go through this real quick. Of course, we have our welcome and hotel safety logistics. We'll have a roundtable discussion here that'll start here shortly. We'll go through the success factors. We have a lot of great presentations, and hopefully it'll feed some of the things that you guys need. And we're always open to questions. We have a few good panels, and that's where we want to get you engaged, and we want to understand what you guys need to know. So with that, any questions or comments before we get started with our first panel? So either I did real good or you're all still sleepy. One of the two. Okay. So all right, Wesley, go ahead and bring your panel up and introduce them.
Thanks, Bill. Good morning. Morning. Thank you all for being here today. For this session, as mentioned by Bill, we'll start discussing about owner's modularization objectives and strategy. I would like to help me please welcome our panelists. We have Catherine Copeland, Director of Target Volume Delivery, today, and we have Dave Gordon here, Director of Global Capital Sourcing from Owen Scoring. Thank you. I got your email. And supposed to have Badar Alam. We have Chris Tomermos, Engineering Director for MORC. Okay, so we have prepared the questions for today's sessions, and feel free after the sessions, feel free to ask questions. If you'd like to have more discussion with our panelists, okay? Okay, so we have here. Okay, so the first question is, what type of return should owners expect from a well-executed modularization project? Okay, Chris.
Good morning.
Yep.
Okay, thank you. The returns, I think, and we'll talk about things other than cost too, but on schedule, you should expect schedule certainty when it goes ahead and comes to the modular effort. Basically, in the end, that is really what the modularization is all about, is going ahead and making sure you get the resources off the site, but you get a lot more schedule certainty. And that is something you should expect when you go ahead and get to building it, to go ahead and put it together. On the cost side, you get certainty. Is it going to be lower than stick built? That depends on what the modular build is and what you're trying to do. But for the most part, you're going to see the cost first, not later. So you get more cost certainty when you're going to go ahead and go down this road. What I've seen with the modular vendors that we've used is basically, in the end, you have to know what you want to build. And when you make changes, they will give you the cost impact right when you go ahead and make the change. It's not a mystery on what it's going to go ahead and be. So you do get cost certainty. Are you going to get low cost? That's something that you have to go ahead and look at. And I'll give you a very good, for instance, where it was good for us on a project. It was in Carlow, Ireland. And we had a permitting process there, a building permitting process that was 6 months long. And it was very involved. When you're in Ireland, you have to go ahead and have town hall meetings with the local residents, and you talk it all out. You have cake and coffee, and you go through everything with it. So during that 6 months, we were able to build the modules in Estonia. And we were well on our way. By the time we were pouring concrete and everything else, they were getting ready to go ahead and ship modules. So for us on the schedule side, it was so much better to go ahead and have the plant being built while we were going through the permitting process. So there's different pluses and minuses when you go ahead and look at the modularization effort. But for what should you expect? You should expect quality. You should expect schedule. And with cost, you're going to get cost certainty. Okay.
Yeah, I would add to that, everything he said, I would not want to repeat. And from an Owens Corning standpoint, we've probably been on the taking modularization seriously for about a decade now. And so, building upon success on various projects is the key. You get better as you go. When we started the journey, factory acceptance tests, vertical startups, we're a producer, we're a manufacturer. So when we build new plants or do projects, that coming up quickly is extremely important to us. But after we got pretty well versed at that, then we did start focusing on schedule, cost, and safety, and just trying to take man hours off of the job site. So we have a real life project going on right now. It's a heavy industrial. It's a new facility in a pretty high cost area of the world. We're in our studies. We're building off of another project a few years ago that didn't bring any cost savings, but it did save us about 4 to 6 months in a country where productivity was a challenge. And so, again, built the stepping stones of, factory acceptance tests to productivity issues. And now on this project, we, from the get-go, made a decision, we're going to do this modular and in a very big way. So that pre-planning and engineering phase is the next part of our journey of stepping up the game and commitment to modularization. And on this project, I can't go into all the details, but the initial studies right now is that we'll take about 80% of our on-site construction off-site. We believe that we're going to gain somewhere between 15 and 20% productivity from the offsite or efficiencies from the way that it will be constructed. We think we'll save about 3 to 5 months on the schedule. We'll be doing the, building and process equipment in a parallel path. Those are some of the numbers that I remember off the top of my head, but we're pretty excited about, and we do, because we're planning this ahead and because we're using our global team, a couple other stats that I remember as we're able to, because of the upfront work, we're able to explore best cost country opportunities. So about 25% of this process could come from other parts of the world that would help us drive costs down. We believe that would improve our total installed cost of around 15%. But if we didn't do the upfront planning and make that commitment early, then some of those things wouldn't happen. But that's the journey. So for anyone that's new to this or just getting into it, it's okay. Take small steps and build upon them, and better things will come along the way.
Thank you very much, Chris and Dave. And I would like to add to that, Bill and I just completed the mechanical completion of the, I think, largest olefins facility in Corpus Christi. That's a joint venture between SABIC and ExxonMobil. So we completed the mechanical completion of olefins 1 month ahead of schedule. We did the modularization in China. We had 3 modularization modular yard in China and 1 in Mexico. So we're about to start on schedule to do complete the startup by end of the year. Based on the study, that's 9 months ahead of schedule. So I think that's the schedule certainty, and that's what Chris and Dave mentioned. We're able to secure the schedule because we did the modularization at the very beginning of our study. That was 7 years ago. And when we also start doing the study, the peak man hours, our resource is going to be 15,000, 20,000 people. And we were going to build it in Portland, Texas. That's kind of difficult to resource this kind of resource in that area. So that's the reason why one of our execution strategies is to do the modularization. So I think that's so what Chris and Dave mentioned, the schedule certainty and the scarcity of the skilled and superintendent supervision in that area. So thank you very much, Chris and Dave. Next question. Okay, Catherine.
Good morning, everyone. Thank you for having me.
Okay.
I would reflect on what the other panelists said. We expect the schedule certainty. And also just moving the manpower off-site. A lot of our facilities are operational facilities. So we need to make sure that we minimize the disruptions and moving the using the modularization moves that work off-site and makes it a lot easier to execute projects with minimal impact on our operational facilities. So that's one of the big benefits that we see. And we really want to drive down the manpower on site and think about moving that manpower into a manufacturing facility where it's safer for the people to work because they're working at ground level with their tools where they need them. So there are huge improvements from a safety standpoint.
Thank you very much, Catherine. Moving on to our next question. Where are the untapped markets for modularization? Would you like to start? Okay, Chris, or?
So I'll add what I know
Okay.
in these untapped markets. So I'll put on my Owens Corning sales hat for a second. So just internally announced a couple of weeks ago that we are actually forming a new department focusing on modularization or prefabrication. Something was the group's title. But that's on Owens Corning product, our insulation, our wall products. So we're trying to, we know, in addition to what we're doing on the capital delivery side of Owens Corning, our growth, but we're also seeing sales opportunity with some of the products that we make. And I think there's a later question that I'll talk a little bit more about commitment of staff and resources. But so that's something that Owens Corning sees. Next time we get together, I'll know more because it was just really recently announced. But the other one I hear us talking internally about is the construction of infrastructure, bridges and things of that nature. We think that there's, I mean, it's not necessarily untapped, but we think that it's got a lot of potential yet to go.
I think on yesterday's discussion, they mentioned about bridges, right? So that's, at the yesterday's discussion, they mentioned about the modularization of bridges. That's kind of exciting. It's very, very new to me when I heard
Was
about
it-
that yesterday.
And one of the opportunities that we have too is we go ahead and we look at basically building a box, a big structure that's dry, but then modular pieces that fit inside of that box. And that's a lot of our planning for different jobs. One of the things that I think is a big opportunity that we've really pushed is medium voltage plants, MCCs, different things like that. And having it come all assembled with the tray, the cables hanging down, you can go ahead and do some of the terminations once you get it there, but you want all the equipment in it and you just set a box. And especially for the medium voltage, it's really, really good. On the project in Dublin, we built a frame underneath it where all the cables were going to hang down through. But when the medium voltage showed up, we set it on it, finished all the different pieces, and within 3 weeks, we were ready to go ahead and start thinking about doing checkouts and power up. So in the end, that's a big part of it is on the electrical side. You can do a lot of different things with modularization on the electrical side. Sprinkler houses. We go ahead and we do pumps and everything else like that comes in a box. You set it on a foundation and you're ready to go. You hook up the pipe. You don't have to go ahead and do all the stick build in the site. So there's a number of different pieces that you can do outside of your main building. But also in your main building, you can go ahead and look at and say, well, this part of the building makes sense for us to go ahead and do a modular effort, but we'll build a box that it'll go ahead and sit in. There's a lot of different strategies that you can do, but there is a lot of opportunities on how you can go ahead and do more off-site rather than going ahead and just stick building it on-site. Absolutely.
Thanks, Chris, Kat. So
Yeah,
I'd
yeah,
like to add, Catherine, you like to add something?
Oh, sorry,
Yep.
yes.
We'll, we can't hear you, Catherine. Catherine?
Is she on mute?
No, she's. Okay.
Oh, sorry. Can you guys hear me now?
Yeah, no, we can hear you now, Catherine. Sorry.
Okay, sorry.
We lost you
I
there.
apologize. Well, let me step back then.
Okay.
So I was going to build on what Chris was saying is that we are actually able to do offsite central plants. And down here in Durham, we recently did a central plant, which we built entirely offsite. And then we were able to bring on-site and set all the modules and get it up and operational in a much quicker time than we normally would and reduce the congestion on site. But I think the other area, the other untapped market that's important is the modular clean room, because it's going to give us a lot more agility and ability to respond to new drugs much quicker. So that as they're approved, we can bring in new clean rooms that can operate for that product quicker, and we can actually create clean room ballrooms that actually have modular pieces that click on and click off. And so you can remove one and bring a new one in and switch over and be very agile with the way that you respond to your business because of the full modular clean room.
Okay. Thank you very much, Catherine. I mean, Chris mentioned about the MCC. For our project that we just executed, we built or modularized the MCC on the module. By doing that, we were able to do the commissioning, almost 100% of commissioning at the yard. So when we received the modules at the site in Corpus Christi, it's just plug and play because we already completed the commissioning at site. I mean, thanks, Chris, for bringing that MCC.
Sure. And I would add to your last comment there, another untapped area maybe for for us. Again, can't go into it in great detail, but if you have innovation projects where you're developing pilot lines, so small scale, something of what you're doing on a bigger scale because of its innovation. So bits and pieces will work, some will work, some won't work, and you may need to roll some components out and put in new ones. So that's maybe another untapped market that at least we're starting to explore. And I was surprised in some of the research we've done here in the last few months that there's actually companies out there that specialize in exactly that.
Thank you very much, Dave. Okay, moving along to our next question. What are the biggest obstacles facing owners in developing an execution strategy that includes more modularization?
I'll go ahead and I'll start with that. One of the things with modularization you got to remember is you have to know what you want to build. In the pharma business, we struggle with that. And one of the things that you have to know is you have to have that early decision making. You don't make decisions later. You have to make decisions now to go ahead and keep the schedule and keep everything moving. So for us as an owner, we have to go ahead and really, really force ourselves to go ahead and get that early making. Figure out what you want to build, because in the end, changes come hard in the modular world. And if you do go back and change, you will go ahead and you will feel those cost pressures when you go ahead and look at it. So it forces you to go ahead and really be good at knowing what you want to build and then keep the changes to a minimum. Because in the end, that's where you get the real cost benefit, is if you can go ahead and keep those changes to a minimum.
Yeah, I agree with all those, and no different than probably what many of you are experiencing. Culture is one of the obstacles. Getting the mindset early is important. Time. A lot of times are at the beginning, modularization, especially if you're doing it for the first time. The engineering side of it, the upfront engineering side, takes longer. But if you and you lose people because they see maybe higher upfront engineering costs or higher or longer initial schedule, but then they don't look at the total picture and understand that you can make up for cost, up for schedule at later points in the project. And then there's that building blocks that I've referenced a couple of times. But the culture's the number one. And for my last statement, it's commitment. It's commitment of a company. That's the biggest change that's happened in Owens Corning. The gentleman I'm filling in for today, his job, I mean, it was a newly created job, I think about 2 years ago, if I remember. I don't remember his exact title, but it's modularization project engineer or leader or something of that nature. But it's his focus. I mean, so he's looking for opportunities. And then he's part of the digital engineering team that then is tying in the digital engineering into the thought process of modularization. So it's that commitment. And as I mentioned in that last thing, we, as a company, even on the sales side, we are now dedicating, I think an announcement I saw was 4 or 5 people to go explore selling our products to the market in a prefabricated manner. So it's just that commitment, that focus. It helps you overcome the cultural challenges that may be embedded. But that's been the single biggest difference for Owens Corning is getting people to look for opportunity, and we all report to the same person. So if we do have disagreements, at the end of the day, there's someone that gets to make a decision on all of our behalves.
Thanks. Catherine, do you like to add to that?
Yes, absolutely. I think one of the biggest obstacles that we face is that to do modularization effectively, we have to change the way we design facilities. The early decisions that we make in design can impact our ability to do the modularization in a cost-effective manner. So we can't begin the design process and progress it and then expect the delivery teams to change and to modularize. So as we start the project, we have to decide immediately what we plan to modularize and use those modularization elements as building blocks in our design. So it really requires a cultural shift in the way we design projects and how early we start to develop our modularization plan for the project. Too many projects go through early design and then they try and go back and add modularization in, and that's where you end up in situations where the cost of modularization becomes more expensive. But if we start very early with the plan and we use the plan modules as those building blocks, then we can ensure that it's cost effective and that it's executed well, and that we're bringing those vendors in to pull their knowledge into the design for the project, so that it's a very effective execution. So I think that designers are going to have to rethink the design process so that we can execute more modularization and do it very cost effectively for the projects.
Yeah, Catherine, I absolutely agree with that, you know, and it just takes that focus to go ahead and make sure that you are thinking about it very, very early, and then letting your design, go ahead and flow from that. One of the things that's tough for us too is lots of times the business goes ahead and sets the end date for the project. We need the product by this time period. So everybody works back from that date, and then you're trying to go ahead and fit it all in to go ahead and meet that business deliverable. And sometimes, with the modular end of it, you have to go ahead and make sure you're really looking at it and giving you the time, because to go fast, you've got to go ahead and make that early decision making. You're not going to go fast if you go ahead and you're going to keep changing. So, you got to really, really force the business to tell you what is really, really necessary, but then go ahead and make your decisions to go ahead and like Catherine was saying, get that early commitment to modularization, and then let your design flow from that decision.
Thank you very much, Dave and Catherine. I would like to add into that. So that engineering. So on that project that we did, we had a problem, a huge problem, design problem. So we built the largest, biggest, heaviest, tallest furnace module just recently, and we had a design problem, structural problem. So it was kind of difficult at the time. So moving fast on the design and engineering stage with that in mind, the schedule will cause you a problem down the road if you don't plan accordingly. So I think that's planning and making the design is well aligned with the modularization. It's very, very important, because it took us 9 months to fix that design problem on the structure, because that model has to withstand the transportation or sailing from China to Corpus Christi as in average 45 days. And I learned about marine design, naval design because of that problem. I'm a chemical engineer by education. I became a civil structural design expert because of that problem. It took us 9 months because of that structural design issues. I felt at the time that the world is tumbling, the world is against me, because I was the lead project engineer for that project. And the EPC contractor came to my office and told me, we have a huge problem. And I was talking to my mom at the time, and I told my mom, can you talk later? And she said, okay, what do you want? Just pray for me. That's what I told my mom. Okay, just pray for me, because EPC contractor is from Japan. Japanese culturally, they keep those issues or problems from themselves. It took courage from that Japanese guy to come to my office and told me, we have a big problem. That's a big problem. That's the sign. I think it's the key takeaway for me is just make sure when you do the design, just that have in mind that it's going to be a modularization design. It's totally different from stick built. Totally different. I built a stick built project or plants before, but the modularization is the biggest project I have ever executed. It's just different. So that's the design. Just make sure that the design is going to be aligned with the modularization in mind and with the transportation. So it's a 45 days sailing in the Pacific Ocean. You just have to make sure that's going to be aligned with that design. Okay. Thank
Can I build on that for 1 second before we move on to the next question?
Okay.
I think everything you said was fantastic. And I think that people that deliver these modularization projects, the delivery people have to change their approach. And we do have to have experts in logistics and move in for large modules. And we have to plan for them. I think that the digital world is going to be a huge resource. But as we do these huge modules, we have to think about how we bring them onto sites, how we set equipment, how we move them into buildings. And unfortunately, I've had situations where we've done a really great module, and then we got it to site and you couldn't move it within the facility the way you needed to. And so we actually, while they're working on the design, the delivery team needs to really focus on the logistics of what parts of the building get left open, how do you move modules within a facility, how do you move them on a site. So there's a lot of different skill sets that really have to be developed by the team so that we deliver this effectively.
Yeah. Yeah. Thank you very much, Catherine. You mentioned about the logistic. Mammoth, I think we have represented from Mammoth here. Mammoth help us on the transportation of those modules, 70 modules from the marine offloading facility in Corpus Christi to the site. During the early stage of the project, we had several detailed discussions on the land transportation of the modules. We're not able to do the same due diligence on the sea transportation of those modules. So that's going to be the one takeaways of that project. So make sure that you do the due diligence of the sea transportation of those modules. Okay,
Yeah.
Thank you.
And just say one more thing on the design, like when you're doing a full modular building, if you're going to use like a key plant, or, we've used Pharmadule that is now over in China, but key plants is going to go ahead and have a modular that's a certain size, 14 foot by 14 foot by 70 foot long. That's where your columns are going to be. So like Catherine was saying, early in the design, you have to know that if you want to change where those column locations are going to be, it's a big deal for that modular fabricator to go ahead and redesign his structural steel and everything else on how that building is going to work. So you have to go ahead and have those types of figures in your mind as you're doing the design, because for them to go ahead and change that design of that modular and the structural steel with it, that's a big deal.
Yes, it is.
Catherine, do you have anything more you want to say to that?
No, that is so true. I mean, we have to start with those modules in place. And the minute you start going to a custom module, you have to understand what makes your module builder cost effective. And the more you customize the modules, the more expensive they're going to get. So if you can understand what makes them cost effective and you can incorporate that into your design, that's when the cost of modularization will start to be less expensive than stick built.
Absolutely.
Thanks, Catherine. Thanks, Chris. Okay, moving along to the next question. What have owners experienced with crises like COVID-19, supply chain disruptions, vendor and bulk material supply, customs clearances, ship loading, immigration, instrumentation, project schedule delays, engineering support, and people movement, quarantines, fatigue, etc.?
I don't know if I have anything specific as it relates to modularization, but it's the same thing that everyone else is facing here. We are, the labor workforce is skinny, and we get as many no bids as we do bids on any particular thing. Inflation, logistics challenges. I mean, it's all real. I wouldn't necessarily tie it into modularization, but it's we're facing the same thing that pretty much you hear on the nightly news every night.
I don't know how many of you attended the session yesterday.
Yeah.
And I mean, when you talk about the wind farms, when you talk about all the different things and the shipping, what's going to be available and different things like that, that's a big part of this. There's a lot of decisions that have to go in much, much earlier, just because of the fact that the business is going to be very busy over the next 5, 6, 7 years. So in the end, your shipping, how you're going to go ahead and pack it, when it's going to be available, those dates are having to be a lot more firm than they have been in the past. And that's something that you got to really, really make sure when you commit to a date, you're committing to that date. And that's something that you have to go ahead and really, really, really be a lot more rigid with your thinking on how you're doing, especially with the shipping and especially with going ahead and receiving at the docks and the different things like that. Everybody's seen the pictures at Los Angeles. If you were having something that's going to come through Los Angeles right now, you're not going to be seeing it for a while. That's just the way it goes.
Thanks, Chris. Catherine, you would like to add into that?
Yeah, I mean, I think we all recognize the delays in shipping associated with COVID, but I think that modularization gives us a way to buffer ourselves and to protect ourselves from the impacts of COVID. As we start to move work into manufacturing facilities, we can spread out the work over a longer period of time and still achieve schedule certainty. So similar to the example Chris gave earlier, we had a project in Pennsylvania where we had a long permitting period, and we were able to use the time during permitting to move the work into a factory, spread out the work, and do all of the work with fewer people. Now, we still had to buffer for the longer shipping, but allowing, moving that work into the factory allowed us to continue to move forward with the project and do it with fewer people. So that minimized our impact to all the supply chain disruptions. We were able to respond better when materials were delayed because all of the work was in the factory. We did have to buffer for the shipping, and we had to put stuff in storage because we had to ship it early just to make sure it was in place. But I think that sometimes we can leverage modularization to help us respond to things like COVID and also things like labor shortages. When work is done in the factory, you don't have to worry as much about the number and the quality of people that you can get at the site where you're going to do the work, because you have people that have been doing the work in the factory that will continue to do the work, and then the number of people that you need on the site becomes substantially lower. So I think that we should also think about modularization as a means of being able to not be impacted by supply chain disruptions as much as we would be if we didn't have a strong modularization plan.
And one other thing that you really need to think about during your erection, and I appreciate Catherine talking about making sure you can get the modular to it, but then to set it, you're going to have a crane. And lots of times when you get to it, you're going to have a 900, maybe 1,000-ton crane to go ahead and lift some of these heavy modules when you go ahead and put it in place. They're not just available around the corner. And you got to do a lot of planning with your rigging, lifting very, 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 very early, so you can go ahead and start thinking about how do I go ahead and make sure that I've got the equipment available to go ahead and erect it. I'll be brief, but in Carlo, we were going to have a 900-ton crane delivered from continental Europe to Ireland to go ahead and set the modulars for the building that we were going to produce. Instead of doing that, we ended up going ahead and beefing up the concrete, the slab for it, and we were able to drive the crane in on the slab, and we set the interior models, and we worked our way from the center out. And that only took a 250-ton crane. So sometimes with your design, you can do things to go ahead and help yourself with your equipment that you're going to have to do to go ahead and erect it. But that's all part of that early process. And once we got it in our minds that we were going to drive that crane on that slab, we were able to go ahead and make the slab big enough or thick enough to go ahead and drive the crane on. And we lifted all the modules with a 250-ton crane versus 900. Big difference as far as what you're going to have for availability.
Yeah, and maybe feed off a little bit what Catherine was saying as well, going back to the original question, specifically to COVID. One thing that in now thinking about this a little bit further is, as you can do more in an offsite facility that is set up for building what you need, they have their own rules and policies and procedures as it relates to mask or social distancing compared to when you're going to a various owners. Each one of us owners may have a different policy that those contractors would have to follow. So that is something that we saw has helped on our more recent projects. And then deviating a little bit from the question, and it's not just COVID, it's the workforce is changing. I mean, we're all used to working from home a little bit more, or not traveling as much more, and younger generation isn't wanting to do this or that, or older people are getting old and don't don't want to do all those things. And so I mean that the dynamics of the workforce itself, modularization because of or offsite construction because of the way it's set up. It's not perfect. They're facing the same labor shortages, but from what we see, it's better than traveling road crews or things of that nature, because people are just tired of the road. I know it's hard to get talent, and the talent we do get do not want to be road warriors.
Yeah.
And I mean, for us, there's a stake in the ground with operations. We cannot affect operations. As important as our project is, our business deliverables, when we're talking about vaccines, when you're talking about different things like that, the project work can never go ahead and affect operations. That's just a stake in the ground for us. So in the end, the modular end of it, like Catherine was saying before, takes a lot of work offsite, takes a lot of that. COVID is much better because now you're not mandating and checking people for vaccines and different things like that, like for COVID. But our stake in the ground is we cannot affect operations. Operations has to meet their deliverables. They've got to go ahead and have it on time. And in the end, the project has to work around that. So anything we can do to go ahead and minimize those impacts and those touch points, that's what the project really has to do.
Thank you very much, Chris, Dave, and Catherine. I think that's all for the questions for the panelists. Do you have any questions from the audience that you'd like for our panelists to tackle on? Okay, Judge Dick. Thank you, sir.
So thanks. So I was just curious, what's the largest size module that you've been able to successfully ship overseas, right? We've done some of that ourselves, but we're usually limited to a C container or whatever we may be able to find. What's reality? What's the biggest piece you've been able to say, here's a modular section that made it across seas?
Okay.
I think you had the biggest number.
Yeah. For us, it's 140 feet by 350, 300 feet. And we use the Panama Canal. So Panama, I think their threshold is only 190 feet tall. It's 300 feet because of we constructed a heavy haul road from Corpus Christi, the jetty, up to the site. It's a 5-mile heavy haul road. So that's the restriction. That's the 300 feet. It's 140 by 300 by 190 feet. I don't know about Suez Canal, the restriction of the height in Suez, but for Panama, it's around 190 feet. That's the reason why we're not able to ship the stack on the furnace module, because it's going to be 230 feet if we include the stack. So we have to ship loose the stack and install it on site.
That's impressive. And they being next to the coast helps with that, right? You only had a short distance to travel.
Yeah.
If you're in the Midwest somewhere trying to get something delivered, that can be getting across the road can be a challenge.
I mean,
Yeah.
that's key, Jacob, is where does it start? Where does it end? And that's going to dictate what you can and can't do. Our biggest is an oversized shipping container. So I mean, it's bigger than what would normally go on the road. The bridges, I mean, if you have to go inland, I'm just stating the obvious. I mean, bridges and, challenges like that on one big project we had to, we could only do it. We could only ship it from the port to inland, 100 miles, whatever it may be. But we had to do it at night.
Yeah.
It was one of our restrictions.
Yeah, we're pretty much the same way. All of our stuff, we don't have things on the coast. So, I mean, in the end, you do have to go ahead and keep it in a container, and they are oversized loads, but they're still going down the road. You still have overhead requirements and everything else. So you just have to work with your logistics manager to go ahead and get your routes picked and everything like that. There are obviously better routes than other ones, but that planning has to go on very early too.
And if you do it early, like he's mentioning, sometimes it works backwards. It tells you what your maximum size is.
Right.
So there, I mean, if you're working with modularization companies or engineering companies, or if you have the internal staff, and you know that final destination, and if they're sound at it, they'll actually, in a lot of cases, look backwards.
I think Bill was part of the discussion on that.
So let Catherine.
Okay, sorry, Catherine, you would like to add to that?
Yeah, everything they said was exactly right. We really do have to understand that logistics path, and we just finished putting a modular lab in. We were setting it in the Netherlands, and we really had to be very thoughtful about the logistics plan because the roads were very narrow, and we had to make sure that we had a path where we could get all of those modules to the site. So early in design, having that logistics manager that understands the path that you're going to use to get there, that's going to drive your biggest modules. So that would be the best advice, is right at the early design, make sure that you have a logistics manager that understands how you're going to get those pieces where they need to go.
Okay, thank you.
And the answer, our heaviest one was right at 10,000 short tons, not metric tons, short tons. So we had probably 14 modules over 5,000 tons.
Not to put a damper on all the good stuff, which is excellent to hear, but has anybody really kind of looked at the operations and maintenance impact of modularization? I mean, I think if you're, what we found, Pathfinder, by the way, is if you don't get them engaged early enough and they don't realize what modularization means. You talked about, where your beams are going to be and so on and so forth. And they come from a stick built type environment, and then you go to modular, they're absolutely shocked when they see a modular result. So okay. I guess just if any input on how you engaged operations and maintenance in the whole process.
One of the things that we did in Carlo and also in Dublin on the different things, we took the operations people right to the fab shop so they could see exactly what they were getting and what it was going to look like. So the best thing I can tell you is to go ahead and make sure that you keep them in the loop during the fabrication process and take them with you. The other thing that with modularization, you got to really, really be careful with, like if you're building it in Europe, and you've got instruments that are CE rated, well, they've got to go ahead and be rated for the States. If it's going to end up in the States, you've got to go ahead and look through all those design issues too, to make sure that you're meeting all your local codes. Lots of times with the modulars, they'll do the sprinkler work too, in the modular. Well, you got to go ahead and make sure if you got local regulations that you have those people go ahead and come. And we've had, on a lot of our jobs where you got local guys that are there that's going to go ahead and sign off on it. They're coming to the fab shop to take a look at the plumbing. They're looking at the electrical, the different things like that. So it's a lot of people coming to that fab shop to take an early look at what you're actually getting. So when they get there, they're not that surprised about it.
Yeah, I would add, and this is a real challenge. Early involvement. You guys just both mentioned that. Digital engineering, 3D modeling helps out a great deal. Sometimes you got to overcome some perceptions. So if a module does come in a box, it looks like a shipping container. But if you're thoughtful and want to have maintenance access points, to where if it's in a box, it looks like it's restricted, and I can't do my job if I'm a maintenance leader. You can also design in, okay, I'm going to take out that support column. But if you've engineered it ahead of time of being able to provide that to where this piece of equipment, in my case or our case, some of the things in the shipping are removable once you get them into your operation. So, with the tools today, digital engineering, having debate, bringing the right people into the room and looking at the design and welcome that challenge, welcome that debate, and use this. The digital engineering space, just in the last 2 or 3 years, what it's done to open our eyes inside of Owens Corning has helped us overcome many of those barriers.
Another real good example of that is lifting beams. You get the maintenance people in because they've got different pieces of equipment that's got to come out, and adding a lifting beam after it's already there is never a great idea, because then in the end, is the structure rated for it? Are you ready for, that lifting beam to be put in? So, all those things have to be thought out, and that's why operations gets involved early, so they can go ahead and see where they would want to go ahead and have that, and then it can be designed and all part of the module. And when it shows up, you got your lifting beams, everything else in place. So
The other thing I would maybe add on is we got a particular it's kind of a global project or a repeatable project due to sustainability. When we melt stuff, so we consume a lot of energy to do what we do, but with great energy payback. But we're going to be doing some things that hit some of our sustainability goals, and so we're going to be doing a very similar project 5 to 10 times over the next 10, 15, 20 years. And again, the tools, the digital engineering, the 3D modeling, being able to see where your conflicts are. But we're able to take it from one plant to the other. Each plant has a little bit of difference in their infrastructures, but we're able to build off of the first one to see how we need to adjust it. And then if you're in my role on the sourcing side of this, now I don't have a project, now I got a program. And so now I can have different negotiations. I can go after different partners because I'm doing it 10 times, not once. And with that type of planning, and you learn things along the way. So, if you didn't do it perfectly on the first one, you build a program, you build a partnership with a person or a company or companies, and then you can just along the way, just continue to improve, correct mistakes, et cetera.
Catherine, do you have any addition to that?
Yeah, I feel like I'm pivoting from the original question, but I'm going to build on what was just said. Really, the power in modularization is the repeatability and the design reuse, because we build the same things over and over again, but we design them as if they're all bespoke. And we really need to start thinking about what are the things that we build repeatedly and modularize those so that we can take that and make it a product and then just purchase that product for multiple projects. And again, leveraging the digital is so key. I've been on projects where we've taken facilities teams into the model. We've put them on lifts virtually and had them go to where they needed to go to do the maintenance work. And it really made a huge difference because it costs nothing to move valves and to move pieces when they're still in the virtual environment. But when it's out in the field and it's already been put in place and they're trying to get to it and they can't, then it costs us a lot of money to move. So the more we can leverage the virtual environment and bring facility teams in when it's still a virtual model and have them walk through the process of their maintenance, we're really going to drive down the cost of making changes later on, because they'll know before we even build it that they can maintain it properly.
Yeah,
that's definitely how you control costs, is minimize those changes and the different things that you have to redo.
Okay, thank you very much. For my experience, part of the execution strategy is to include operations and maintenance, including commissioning in the integrated project management team during the different phases of the project. During FID, we have operations, maintenance, and commissioning team during FID. During the engineering, we have those guys. During the fabrication, we have those guys, and during construction, we have those guys. And Catherine, Chris, and Dave mentioned about engineering change. As I mentioned, I was the lead project engineer for the furnace, and part of the maintenance on the furnace, the retubing of the radiant tubes and radiant coils. And if we didn't have the maintenance and operations folks during the engineering stage or during the 3D mold or the conceptual design, we'll have problem, big, huge design, because we have to design the steel structure and the equipment close to those retubing in such a way that we can pull those radiant tubes and swing it to the other side so we can do the maintenance. So that's what we have. That's a lesson learned in the past projects, that there are some issues on the operation maintenance. That's the reason why we added them or included them in the integrated project management team during the different phases of the project. So we have their inputs early on during the conceptual design so that we can minimize design change. Okay.
So mine is a bit of a question and a comment. And I support the questions that were asked before about logistics and engaging the operations and maintenance folks, because that's been exactly my experience with modularization. I've done a couple of them the last couple of years. But the one element I start to see is a bit of how modularization could sometimes limit our ability to master plan our facilities. And the reason is because, like we talked during logistics, there are logistic constraints on how big, how large you can ship, you can move, you can transport, that constrain our design. And so eventually when the structure shows up on site, we want to be minimum code in code, right? Same from an operations and maintenance perspective. We want to accommodate as much requests as possible, but we want to keep it modular. So we try to design to be very minimal. And then when we eventually do it, it becomes very difficult to expand that facility or expand that structure in the future when the plant is growing or the business is growing and you need to make an expansion. And I'll give you a very unique case I've seen, which is typically we design buildings just to be able to fit to house the equipment we are installing today. In the future, when we need to bring in more equipment within the same space or put them on top of the space is not structurally possible because we designed for the structural minimal. What's your perspective on that? And how do you think we can unlock that constraint?
I'll take a stab at it. So each one of our manufacturing processes is different, so I can only speak, to what I know. But the way that I think you're right, number one. But in what we're looking at, I can't even say that we've done this yet, but what we're looking at, and I'll go back to that pilot line conversation that I mentioned earlier. If you have the foresight of where it could go, your expansion could go. I mean, could you do a right-hand turn and expand, or do you have to expand in the current space? I don't know. I know what we can do. But in that pilot line concept, you build things in sections where you can take them out, take them in. And so I don't know what each one of you, what it takes to get more pounds or more feet per minute or whatever it may be. But we're trying to build our production lines in the right industries, our right business units with flexibility of moving in and out, replacing it 10, 15, 20 years later as new technology comes along.
Okay.
But that's our space, and it's not even in all of our business units. It's in some of them.
Okay.
I mean, I'm just going to tell you, when we're looking at capital investment and everything else like that, the future planning and everything else that goes in it, you have an idea of what you're going to do, but you don't want to spend all the money trying to go ahead and beef up steel and do different things like that. You're not going to go ahead and do that anymore. So you got to have a plan. There's usually a master plan for the site on where the expansions are going to go, and they will go ahead and make tie-ins for valves, for piping systems that go into that next system. And you can do that with the modular end of it, but you got to go ahead and have that in mind beforehand. It's not a flexible thing that says, well, we had planned to do it here, now we're going to do it over here. Now it's going to go ahead and be a whole different thing when you do that. So you got to have good master planning to go ahead and know where you're going to go ahead and be expanding to. But as far as the flexibility, you are absolutely right. You're not as flexible as you are with the stick build. Normally with the stick build, you're over designing steel, you're over designing different things. You don't do that in a modular space. That's a whole different way of thinking about it. Catherine, do you have anything you want to add?
Yeah, I think as an owner, we have a group that looks at our agility, and because when you're in a specific project, you're worried about building for that specific project. So over the last year, we've had people looking at how we can set facilities up to be agile, to shift. And we've had to do that. I mean, candidly, over the last couple of years, we've had facilities where they were going down the path to support one product, and then we had to pivot and support a different product. So I think you need a team that actually looks at how you design for agility so that you can shift facilities. And sometimes you can't do like a full modular approach because it will it will block you in. But there are, when you think about modularization, there's a whole spectrum of things that you can do, and there's kit of parts, and so we have kit of parts clean rooms that are very agile. So if we have a facility that we know is going to need to pivot, maybe we go to a more agile modular solution that doesn't move as much work offsite, but still gives us the flexibility to shift to a different product at a later time. So I think you have to have people that are thinking about that outside of the team so that you can set projects up to be agile to support your business long term. Hopefully that answers your question.
Okay, I would like to add to that. For us on that project, we have specific items that we already knew that's going to be built in the future, very, very few. So we took those lists into our design, like future elevators. We designed a structure based on adding future elevators, adding this equipment in the future. But you're correct. So if you're doing the modularization, you're not flexible because you're limited. You have constraints. You have dimension constraints. You have weight constraints, and etc. But if there's a capital project that we need to consider, if you add design margin in your design, so it's kind of limited. That's from experience.
On a maybe a brief positive side of this, there is restrictions. You're spot on. And again, each industry is different, production lines different. But in our space, a lot of times in our glass plants, a lot of our manufacturing facilities tied into the building from a support standpoint. So what we've been able to do is the modular, because it's been built off-site, we're building the building while we're in an off-site construction building other parts, and that's that parallel path to save schedule. But one of the benefits is now you're not tied into the building. And so moving things in and out, again, at least in our world, that is something that we see in the future will provide us an opportunity that we don't have in all the other plants that are 50 years old.
Okay, thank you. Thanks for the question.
Quick question or observation rather. The biggest obstacle that I've seen is project approval and funding without modular consideration. Because if you've already set your business metrics and your project metrics without modular consideration, it's too late. Because I've seen clients come to us and say, okay, project's approved, now let's go modularize it. And then it's a conflict, between what you've already established for schedule or cost or other project or business metrics. It just seems to be a conflict.
And like for us, if we have a manufacturing facility that has to produce a product, for us, not having the product is a much bigger disaster than a cost overrun. So there's other dynamics that feed into that on why you would go to that. But you're right. If you don't have that modular approach in mind when you're doing your estimates and everything else like that, you can get into a lot of trouble. Absolutely.
Okay, thanks. Thank you.
Nothing further to add.
Any other questions?
Thank you. I merely have an observation or something to add. I work for Mammoet, the heavy lift transport company, and you all were talking about untapped markets and opportunities. I think one of the things that really nobody really talks about, but I've seen done very successfully, is reverse modularization. We were involved with 2 existing methanol facilities, taking them out of Punta Arenas in Chile that were stick built originally. And together with the EPC, we set the constraints for the ocean shipping, and we did the ocean shipping and got those modules, new modules actually, moved to Louisiana, got them over the Mississippi levee and got them in place, and got that plant up and running well before anybody could have built a new plant, and they were able to take advantage of the low gas prices. And as such, that strategy, I think, especially in like remote locations where it's hard to find labor, and that definitely was a very remote location, I think has a lot of merit that is probably untapped. Just wanted to add that.
Thank you.
Thank you.
Very good.
Any other questions?
I had a couple of questions that for when you develop your module strategy and come up with your plan and you're doing your risk analysis and your cost analysis, do you consider, what additional uptime by, shortening your schedule? I mean, how do you go through that?
Yeah, William, from our standpoint, that's the single biggest benefit of the whole thing, and I'm glad you brought it up. Some of the statistics I would share earlier, very early in this, I mean, we're talking 3 to 5 months on this particular project is what we're calculating. We had a pretty big one before that. It saved us 6 to 8 months because of the productivity issues that we had. But right now, like, many people, we're busy, we're sold out. And so when you look at total installed cost, but also just from an EBIT or, generating revenue for your firm, I mean, it can be worth millions easy if you can shave, 4, 3, 2 months, whatever your production lines, generate. But for us, and it's not just the up and running, but if you can do that in this plant, and you add up all those months of downtime, you equivalently prevented your company from having to build a new plant. Yeah, from a production standpoint, and there's $200 or $300 million, or in my world, that's where this is starting to really stack up.
And even if you go ahead and you stay 3 or 4 months on a schedule, that's a lot of overhead costs too on your project that you're saving along with that. And, like for us, like if you talk about a drug being on patent and then coming off patent, you lose 2 or 3 months of selling that drug while it's on patent. That's a huge problem for us. And I mean, so there are different dynamics that go along with that, and the schedule savings really, really become more paramount when you go ahead and start looking at it from that standpoint.
And one other question for Catherine. She'd mentioned something around clean rooms.
Mhm.
And have you ever experienced a situation where, not related to cost or schedule, but you was driving modularization because of proprietary information protection? And
It depends on the vendor. I mean, we use Daldrup for a lot of it. One of the things that I've always been talking with Daldrup about, I mean, it's a great system. It's a great clean room, comes in all these pieces, and they don't modularize it very well. And so you get all these boxes, and when you get to the site, you got a lot of different things that you have to go ahead and do with their clean room. So we're in a lot of discussions with Daldrup about how can you modularize this better to go ahead and do the clean room. Catherine talked about that before. And it is a real problem on our jobs because in the end, the clean rooms, we have to do a better job of getting those modularized. Size right, everything else like that. Everybody likes to have room the right size that they want it, but sometimes you have to go ahead and make that compromise to go ahead and get the cost savings and also the schedule savings to go ahead and really save yourself some time. Catherine, you want to talk to that a little bit more?
Yeah, so we haven't really run into proprietary issues because we tend to work with a lot of the same vendors. And so we've developed relationships, and that provides us a lot of different benefits from a modularization standpoint, because you don't want to necessarily go to somebody new when you're trying to modularize. You want to understand what makes them effective. But we do use Daldrup a lot, but we're also using like full modular clean rooms. Like what you see out of a germ-free or a G-Con product, where you can start to put clean rooms together, and they'll come with the airlocks and the clean space and the mechanical space. And what's really valuable about that is they can test these clean rooms off-site so that you can bring them in. And if you actually build facilities that are set up to accept them, you can basically click them in, and you've got a lot of your testing already completed off-site. So you shorten the amount of time it takes to go from the time when the business says we need an area to manufacture this drug with these process pieces of equipment till the entire facility is set up and ready for the business to start testing out the manufacturing. So yes, we use Daldrup, but we also look at full modular clean rooms. We just work with certain partners that understand our business and work closely with us to help make products. And the goal is, again, to productize. Like, once we figure out exactly what works for a lot of our different modalities, then we can kind of get to the point where we can already say, give us something like what we just did before, or give us the product that is exactly what we need. I mean, imagine a world where ordering parts of our building becomes like what we do ordering Amazon. If you can productize, then you can really speed things up and be very, very responsive to the businesses that we support.
Right.
Thank you.
So are you productize driving standardization? Are you seeing the acceptance of that more building? And I think we talked about expansion, where you're building more of a standardized module. And
Yeah, I think in the end, you just have to keep having the conversations with your clients, with the people that are going to actually be using the buildings, and getting them to understand what they're getting and why they're getting it. I mean, we have a lot of hard discussions about that, but is it fit for purpose? Is it really going to go ahead and supply the need? And we got to go ahead and make sure people do understand that's what we're trying to do, is make it fit for purpose.
Thank you very much. Any other questions? That's going to be our last question before we move to another session. Sorry.
Stephen Booth, Southwood Industries. I just wondered, obviously all of the cost and the schedule impacts that are great and very important that lead on to other savings for the project, for any kind of partnership. Has the panel seen any major benefit, real impact to the metrics of safety and quality assurance?
No doubt.
Keeping the modularization in a controlled, prefabricated environment, one would assume that the safety metrics would become more desirable, and so would the quality control.
Taking those hours offsite is critical. I mean, for us, it absolutely goes ahead and helps your safety. It helps your quality. It helps everything. It does. You're absolutely right.
Yeah, in addition to offsite, even when it's, or on your site, when it's offsite, a lot of times, at least in our world, people are working from the ground and not over each other because of what we do. We got crafts on top of crafts, and so we're able to improve safety even for our partners as well. And then on the the uptime, the TPM and factory acceptance tests, all that stuff. So when it does hit your site, what we call vertical startup is part of our TPM process. We've seen some definite improvements in addition to safety, but also the startup.
I mean, a good example, I was just on a project the other day, and it's one of my little things that I do when I'm doing a safety audit. When I'm walking through, I count the number of man lifts. There's 150 man lifts on the job. It's a stick build job, but in the end, got 150 man lifts on the job. Well, you got 150 chances of somebody going ahead and doing something work at height, and if you can eliminate that, which is what the modular does, that's a big safety savings when you go ahead and look at it. Just think about all the welding that you could do in a shop versus doing it in the field and writing hot work permits. Going ahead and doing all those types of things. That's all cost savings when you go ahead and look at it, and also quality savings, because you can do that welding in a controlled environment in a shop a lot better than you can out in the field. Absolutely.
And you may need different partners, because when the modulars do get to site, when you're replacing stick build with modularization, you're kind of moving over, instead of steel erectors, you're moving over to riggers. And so it's a whole different type of partner that you're looking for, that is experts in lifts and sliding things and things of that nature.
Okay.
Like
Thanks.
our gentleman in the back.
Okay. Thank you very much, Dave, Chris, Catherine. I think we'll move along to.
Well, I just had one thing I wanted to add here, and this is something to from a safety standpoint. We go into a module yard and they build modules, and that's what they do. They're very good at it. And we come in as an owner and an EPC. Say, we want you to follow IOGP, International Oil and Gas Producers safety requirements. And then our EPC comes in and say, well, these are our safety requirements. And then the subcontractors come in and say, these are, Well, this modular yard's been running fine. They're building. So don't go in and say, well, we want you to follow our owner standards because now you can disrupt that whole assembly line process. So what we did is we got everybody in one room and we sat down and we did a gap analysis and we came up with a site-specific project safety procedure that allowed the modular yard to operate and do what they do, but met our minimum requirements as far as what we expected to see. And basically, we just want to see your data from your safety program. We want to make sure you're running a safety program. If there's any gaps or any concerns we have, we would bring that forward. But in a lot of cases, one of the complaints I hear from modular yards is the owner comes in, they put too many people in the modular yard and they're disrupting their whole flow process. And then they have safety incidents based on, well, the owner said, this is what we should be doing. So take that step with a little caution.
Okay. Thanks, Bill, for that. Thank you very much.
Thanks, guys.
Thank you, everyone.
I think we have a time we can do a 10-minute bio break, and then we'll start in the next presentation.
I don't have the big countdown clock in front of me, so this is going to be a bit of a challenge here to meet my time here. Anyway, my name is Michael Cluck. I work for KBR. I'm the chairman of the Modularization Community and Business Advancement with CII. So I've done a lot of work, a couple of research projects on modularization and standardization. I'm currently working on a new one, hopefully on a module manual. But anyway, a little bit about modularization. I feel like I'm preaching to the choir here, but I'll try to give it a little bit of a different twist. I do Robert Roost here with Mammut, and so I'm going to show a logistics issue we had about 90 years ago. I worked for Exxon at the time, not at the time, I'm not that old, but 1931, this is an example of a low pressure, 40-ton, 80,000 pounds, but it's a riveted vessel that was being taken through the piney woods of East Texas. It was pulled by 2 vehicles and 20 mule team. So, and it had the tracks on it, but you can see even back then there was some interesting work that they had to do to try to get some of the large vessels out there. So we always start with a little bit of a safety moment. And this one is a modular logistics one. And it's the big jobs, they seem to get all the attention. The one on the upper right there is a 1,200-ton module that we put in a gas to liquids facility in Nigeria. The other 2 are some very, very large equipment that I didn't have anything to do with, but they're pretty impressive pictures. Those all work pretty good. It seems to be the little ones that provide all the drama, whether it's on the upper left with some mooring issues, center of gravity issues in the lower right, or maybe hydraulics issues in the upper left, or just some rigging failures. So what can we do about this? How do we eliminate the drama? Treat every module and logistics job as special. Treat each heavy haul and heavy lift with respect regardless of the size, and then do the same effort of early planning. And I heard this in the previous talk, you've got to do things early, and no matter what it is, be consistent. So first thing I always start off with whenever I talk to somebody about modularization, I have a general term that I include. It's an all-encompassing type of term for modules. It is anything that's a transfer of the stick-built construction effort from the job site to one or more local or distant fabrication shops or yards to exploit a strategic advantage. And so a modular job is really a project business or execution strategy. So it can be as small as the upper left, the skid, all the way to the upper right, where that was a 6,600 ton. Yes, sir.
Sorry, I had a question. First question, I look at a picture right to the right, the one that has like very buildings already made. Rocks below that?
Yeah, those are SPMTs. If my eyes serve me right, there are 1, 2, 3, 4, 5, 7 lines, I believe, of SPM self-module transporters, and they have it's 30 plus tons per axle. So you've got 6,000 tons, so you probably got 220 axles underneath there to move it on. And it's the same way that earlier they talked about GCGV bringing those big modules in. They're a unique instrument. I won't be able to get into that, but Robert Roost and those can talk ad infinitum about them and Adam. So anyway, but it's any of these from the 6,000 to the truckables. We use the same general term. So back in 2000, Mark Wahlberg and George Clooney had a movie called The Perfect Storm. So I'm taking a parody of this, and this is the module Perfect Storm. And it's a little bit tongue in cheek, but I think it'll tie into some of the critical success factors that I'll be getting into. So the jobs awarded, the first thing the project group says is, what did we leave out? Not quite sure. The schedule's too short, but again, business is tough, and so they accept the schedule. So the first thing project does is they ask construction. No, construction said they're not going to adjust their schedule. So they go back to engineering. So they reduce both the schedule and the man hours for engineering. So what does that do? The vendors are pushed by engineering. What do the vendors do? They don't give you real good data. It's incomplete or it's late, hadn't been designed well. It develops a poor scope of work, but they go to the fab yard too early. And the fab yard says, yeah, you give me everything on time and I'll get it to you on time. But the fab yard is forced then to start too early by a contractor because he thinks if he gets there earlier, he can get it going faster, which is not the right answer. So then you get some final late changes on the equipment data. Later on, the IFC drawings come out. They're even different. All these changes are going to the fab yard, who's already started designing the steel, the late equipment arrival, and then you have a wrong mix of material. We've got a lot of stainless steel fittings, but we have a lot of carbon steel pipe and we can't do anything with it. And this results in a completion delay, but the one good thing is that transport vessel that we ordered about 1.5 years ago, it arrives on time. So now what do we do? So the decision is what we'll ship incomplete to the site where they can catch up, forgetting the fact that we went to the modules in the first place because the site doesn't have the manpower or the skill to take on extra work. So we're just adding, piling on there. Carryover scope becomes a mystery because the fab yard didn't do the documentation correctly because they were rushed. Bulks and equipment now have to be redirected from the site, from the fab yard to the site. There's more out of sequence work. The site is not sure what was done as far as pre-commissioning, so they said, we'll do it all at the site. So what does that result in? Project overruns. Second guessing begins by all. Conclusion, modularization was a bad decision. So perfect storm, modularization, a recipe for failure. So what do we do? Next time we stick build. Wrong. So the rest of my conversation will be about why this scenario went so bad and what you can do about getting modularization correct. In 2012, I was part of a research with CII on industrial modularization. We developed 5 solution elements. The first 3 are shown there. They're the business case process, which is how to go through a business case analysis. I'll get into that in some level of detail. Execution plan differences. This was brought up by the previous panel up here. We found over 107 items that are different between a stick-built and a module job, and they start in the assessment phase. Everything changes a little bit. And once you decide to make a module job versus a stick-built, all your groups, procurement, cost, and everything, they need to adjust to fit this new fit. And then the main one is critical success factors. I'll get into different ideas on that. Then what I call the holy grail of modularization is standardization. If you can go ahead and build several of these, you have additional costs and savings. It was brought up in the last meeting, last panel. That's what you really need to be doing, if you can find a way to standardize. And then from an industry level, we found 10 modularization enablers that we need to start as an industry to start teaching from the universities and move out. And one of them that I can say right away is we need to teach at the university level that you should plan every job as a module job and use stick build as a fallback. And I'll give you reasons why. So this was our Rosetta Stone for our group. We had 15 different people from different companies. Nobody really understood. We were going across the top, the 6 items: opportunity framing, assessment selection, basic design, EPC, and then startup. Okay, some of the groups had gate process, gate 1 through gate 5. Some of them were an IPA reference, the FEL 1, 2, and 3, and some of them referred to it as pre-feed, feed, and EPC. Some of them just totally based it on the percentage of the estimate, how good it was. So we lined all that up and we said, this is how we're going to start talking to each other. And it's the same thing you do on any job. You get everybody on the same line of music, same sheet of music. But the point I want to make here is your best opportunity is in what I call FEL 0 or FEL 1. It's an opportunity framing when the owner is still looking at what it is. He hadn't even brought an EPC or a designer in there. That's when you can do the best as far as getting your optimum module opportunity. By the time you get to selection or FEL2, you've started to limit yourself because you've picked sites, you've picked routes, you've done some design work, and you may not be able to do exactly what you want to do. When you get to FEL3, which is feed, and then into EPC, if you're going then, there's very little you can do at that time, because once you've gone to basic design and you're into EPC, you're in the execution mode. Everything is just being executed on what you've done previously. You don't make changes at that point in time. So again, the point here is got to do it very, very, very early. And the owner is responsible for pushing a lot of that. And why? Because the fabrication yard is a critical path. In a module yard, it's the intermediate stop for everything. They talked about stick build. You can always ship things over to the site. In a module yard, you're starting 12 or 18 months earlier to get that same piece of pipe or whatever. It's got to go to the fab yard. The fab yard has to design the structural steel, so he needs the information for the design of all the equipment so he can get the secondary steel designed and holes drilled in it and all the other details put in it so he can design the structural steel before he puts all that stuff in there. So all of this pushes everything back. And so it becomes a critical path. Challenges to overcome. I reiterate on some of these. Module design must mature fast enough to design the entire structure, both secondary and tertiary, in time for the steel to start the fabrication. You need to look at rotating equipment, the dynamics on it. Can you work out the harmonics? Vessels and towers, are they too tall for you to put them in a module? Do you have the steel that you can actually put in the bottom to withstand some of the moments for shipping? The flare system, this is always an interesting thing. Process always designs it last because all the inputs from their processes, but the pipe rack is one of the first things you install in the field. So they have to design it so that the fabricator can now put this flare system in as one of the first things that he does on the job. So you're really flipping over how some of the engineering's been designed. The fabricator, there's different fabricators for different modules types. Grillage and sea fastening on an industrial project, when you have 6,000 to 7,000 ton modules, you need to find an easy and efficient way to hold it to the deck, but it can't be so cumbersome that it takes days to unhook it or really cut it loose, because that boat, that vessel can run at 65 to 80, used to be 65 to $85,000 a day on demurrage if you don't let it back to let it out of the contract soon enough. And then there's additional engineering that was brought up earlier, depending on where you put the engineering in your budget buckets. But there's fab yard shippers, heavy haul contractors that get involved with engineering. Pre-FID funding is very, very important, because if you don't have this engineering design of your equipment that's in the vessels, you don't know how to do the secondary steel. And so you can't do the secondary steel. The fabrication yard cannot fabricate it in time to start his schedule. And then there's the alliances, fab yard shippers, heavy haul contractors. So then to complicate all that, you don't just build a box around a stick-built process. This is a process that we had recently designed for a fabrication. We blocked out the areas, but the 6 colors there are the 6 processes that equal the 6 modules on the lower right. It's not intuitively obvious. They're split up. There's some discipline. You can obviously get some cost savings by the plot plan, by reducing it, but you have to go start from scratch basically with a process and put it together where it makes sense. So Who's the key player in a module decision execution? You can see all the circles around there. It's everybody from HSE to procurement to engineering to the owner, constructions, logistics. And they all have to participate. It's a group. Not only do they have to participate, but they need an early and cohesive plan that they all agree to. And an early commitment by everybody that they want to get this job done this particular way. And it requires continuity and collaboration. So it starts early and everybody gets on the same page. Okay, I'm going to go into the 3 solution elements that had to do with the project level. The big one being critical success factors on the end. But this is a business case process that we put together in the research on RT 283. I'm very familiar with it because I co-authored part of it. So right or wrong, but it was a 12-step process that one of the companies was kind enough to share. And you can see it's basically, you took this 12-step process and you took it through each phase of the process, and you started with FEL0 or opportunity framing. The owner took this thing and looked at it. Number 1, it makes sense. Is it technically feasible? Some jobs you have, you just can't modularize. Then you look at module stick built and module schedule and stick built schedule. Is there a business case for it? You look at where you're trying to take it. You look at the yard that you're going to try to build it at. You then look at the drivers that you as a project owner are trying to resolve. Is it a labor issue? Is it a site issue? Is it a weather issue? And you put those in there. You then develop module sizes and scopes. You develop an index. You develop an execution strategy, a cost estimate, and then you determine whether it's viable. And if it is, then you go into the next phase and you do it again. The reason I bring this up, opportunity framing, or what I call FEL0, that's new in the phase. The owner has already looked at half of these, or five or six of these 12 at FEL0 without any input from the EPC. So he should be making decisions then. When he gets to assessment, or which is where you're assessing which options you want to be looking at, you've already completed 3 of them and you've looked at another 6 more. By the time you get to pre-feed, you've addressed all 12 of these major issues on the business case, and you've completed half of them. And by the time you get to basic design or feed, you've completed them all. So when somebody comes to you, or you as an owner goes to an EPC contractor and it's the beginning of feed and you say, I'd like to modularize, and you go, well, you've got a lot of ground that you've already covered. You better go back and check and see if you can even do what you want to do. So again, start early. This is a very complicated slide, and it's meant to be that way because the optimal man hours that you take off site in the upper left-hand corner equals the maximum NPV, but it's a combination of the upper right, which is the main cost driver. It's the economic productivity factor. It's basically the cost, the labor cost of a man and his productivity multiplied together. So at the construction site, if I can read that, it's like 2.5 is the productivity. So he can do in 2.5 hours what the average Gulf Coast is supposed to do in 1 hour. And the cost of that labor is $125. So his effective rate is $318. The module yard is over in Southeast Asia. They have a poorer productivity rate. It takes them 3.5 to 4 hours to do that job, but the cost of the labor is only $12. So he basically gets it for $42. And this is exaggerated a little bit, but basically what you're doing is for every hour that you take off the site, you have 7.5 hours to use in the module fab yard. That is the driver that drives you for modularization. That is what allows you to pay extra costs for shipping, for some of the extra engineering, the extra steel, and all the other things that's typically involved in a module. The lower right-hand corner is a 12-step process, just shown a little different. And over on the left-hand side, there's a cost and schedule. You talk to an owner and we say, what's more important, cost or schedule? And the ultimate answer is both. Okay, well, no, it isn't. Okay, if I can get it to you 6 months earlier, or if I can get it to you for $500,000 cheaper or $10 million cheaper, or use whatever, which one means more to you? And then they'll finally come up with what means more. Well, that's important because as a module designer and as a module planner, you have a different approach, whether it's a cost-driven or a schedule-driven project. So solution execution plan differences, I mentioned these. The panel did a very good job of talking about execution plan differences. 107 of them, they start in every phase. Some of them are very subtle shifts. Some of them are major shifts. A big shift in engineering, because I have an engineering background, is piping doesn't drive the engineering on a module job. Structural drives it. Structural is the one that says, I need the equipment, I need the piping stress, I need the layout, I need to know all this stuff because I have to design the steel, because the steel is started at the fabrication yard 3 to 4 months before they ever put a piece of pipe or a piece of equipment on that module. So all of that has to be done. So basically, the structural guy is the one that drives the engineering group, not piping. You've got to get that set different. In this case, 40% of the differences of the 21 topics of the 107 items that we found in the analysis had to do with planning and cost estimating, modularization, scoping, layout, basic design, and detailed design deliverables. All of it's touched, so everybody needs to know what their plan, what their part is in a module job, and what they have to do a little different. Okay, now to the reason for the discussion. Critical success factors. We identified 72 potential success factors when we did this research. We ranked the top 21 and called them critical success factors. We confirmed this with a review of a committee, outside committee, and also experts in the industry. The importance of this is these 21 are related directly to either a module success or a module job failure. And we found statistical analysis that was then proven with postdoctoral work at levels way above my pay grade, but they proved it both theoretically and directly. So these are the success factors. There's nothing special about them. Take a look at number 2, alignment of drivers. Number 3, owners planning, resources, and procedures. Number 4, timely design freeze. Number 9 and number 10, pay close attention to these: contractor leadership and contractor experience. They're going to be coming up a lot. Number 15, O&M provisions. 17, owner delay avoidance. Number 19, continuity through project phases. It's all common sense. You can use this on a stick-built job too, and it would work. But I grouped them by subject just to get it in my head a little better. You have 5 of them that are based with logistics. 3 of them are based on alignment, project alignment, the alignment of the drivers with the owner and the contractor leadership and experience. 6 are owner involvement. They directly impact. 2 are on benefit recognition, a couple on vendor support, fabrication, O&M, and risk. So my perfect module storm. And I'm not going to go into all the details here, but those are the critical success factors that they failed to follow in some form or fashion for each one of these. For instance, the schedule was too short. Okay, obviously alignment on drivers was not met. Early completion recognition was not met. And contractor leadership was not met. If we go to engineering pushed, that was cost savings recognition wasn't met. Again, contractor leadership wasn't met, and investment in studies wasn't met. If they'd done some investment in studies, engineering would not have to do the extent of the scope of work that they had before. And we can go on and on through this thing. The point here is, as you look at all of these, who's the responsible party and at what phase should this have been initiated? If you look on the left-hand side, the owner is responsible for over half of the 21 critical decisions made. The contractor is for 1/3 of them. By project phase, opportunity framing or FEL0 and assessment have over 42%. So before you even get to pre-feed, you've got 40% of the critical success factors identified. By the time you get to the selection, which is pre-feed, you have over 62%, if I do it right, of the critical success factors analyzed. So it's very early, and it's critical that the owner and the contractor get involved at it early. So on my perfect storm, which ones did they actually meet? They met module envelope, which was great. They met the heavy lift and site transport capability. Remember, the ship got there on time. And the transport infrastructure, they figured that out. So in addition to these critical success factors, we look to see how common or rare they were in a module job. Okay, well, very common and common were the ones that they met. So almost everybody on a module job was able to figure out the limitation of the module envelope and the transport and that issue. The ones that we really get concerned about are the rare and very rare ones. And I'll bring that up in a little more detail here. So by color, just for your information, the blue and the green I attributed to the contractor, and the yellow I contributed to the owner. So if we look at incomplete module team, number 14 is vendor involvement, and number 9 is contractor leadership. Poor planning, guess who's involved in it again? Number 10, which is contractor experience, but also 3, owner planning and resources. If we go to failure to commit necessary pre-FID funding, so early studies. Number 5, early planning recognition from the owner. Number 12, investment in studies. And number 14, vendor involvement. Then we go into poor engineering execution, my favorites, 9 and 10, contractor leadership, contractor experience. Starting the fabrication too early at the fab yard, that's the kiss of death. The fab yards run like, I always compare it to Ford Motor Company. You don't tell Ford how to build their trucks. You don't tell a module fabricator how to build their modules. All you do is get in trouble. So again, 4, timely design freeze. We were still designing when it was at the fab yard. 9 and 10, contractor leadership, contractor experience. Go to late engineering changes. Number 4, timely design freeze, and 9 and 10, contractor experience and contractor leadership. Shipping the module incomplete, not a smart move. Contractor leadership, contractor owner, contractor experience. And then poor coordination between the fab yard and site, same thing. So when I get to the, you can see as far as analysis frequency, from a contractor standpoint, it's rare and occasional that you have contractor leadership effectively done, investments in studies done, a timely design freeze I've never heard of, and contractor experience, as well as management of execution risk. So that is on the contractor. So while the owner may have over half the critical decisions, to me, the important ones are the contractor, who must sort of regulate how you approach the job once it is being executed. Now, the owner, on the other hand, it's hard, it's rare or very rare to get these done in the series of jobs we looked at. Owner delay avoidance. The owner in many cases is as bad as the contractor in trying to delay things or change things. Data for optimization, he's constantly tweaking it. And then you've got owner planning, resources and processes. I'll get into that, but the owner, as was mentioned in the panel here, they need to have a module team, just like the contractor. It's important. And then investments in studies and vendor involvement, as well as occasionally early completion recognition and cost savings recognition. The owner often doesn't recognize the impact and the benefit of an early completion and an on-time schedule. But it was mentioned here, and they recognize it as one of the key drivers, so it is important. Again, the critical success factors, I'm not going to go into that. The duplicate slide, and then again, this critical success factors by responsibility. So this next set of 4 or 5 slides are something that I put together that I talked to my when I'm presenting modules or trying to present to the owner or my group at KBR or a company. There are certain things that I think are never really mentioned that people need to understand if they don't understand modules real well. And again, first one is modularization and pre-assembly, to me, are the same thing. It's the goal. The goal is to take man hours off site. And the reason you take man hours off site is because they're too expensive, they aren't enough of them, or they aren't very good. It's just pre-assembly is a simpler form. A module job is always a mixture of different modules. It's nice to see this big 6,000, 7,000 ton modules, but within most jobs, there's smaller ones, there's pre-assemblies. They mentioned MCC buildings and REI buildings. They get built as a modular pre-assembly. All this stuff gets worked together. The key is that you take the big ones and the small ones and you figure out the best way, the most efficient way to get that optimal man hours off site. And you don't have to go across the world. Moving man hours off site can be as simple as pre-assembling right next door. The issue is if you've got a problem, especially a brownfield, or you've got an area, if you just move it over to the next few acres, anything that you can minimize the amount of impact that you have on that facility, the concentration of the people or whatever, it allows you to build it at grade. Anything that allows you to do it more efficiently, it's fair game. Boundaries and limitations. Not everything can be modularized on a job, but every job can benefit from modularization. The goal is the same, moving man hours off site. And again, pre-assembly is just a simpler form. A properly designed module will improve O&M access. If anybody tells you operations and maintenance is going to be impacted by a module, you go tell them they're designing their modules wrong. There's absolutely no reason on a land-based module to have operations and maintenance have any problem at all with the module. Again, you're offering them a third dimension in most cases that they can use for pulling valves, pulling equipment, moving things in and out. And a properly designed module is not cramped. It will minimize safety hazards. It will not add additional ones. And it's different than its older brother, the offshore module. You have to remember that the offshore module is based on a standard footprint that you had to put in because that's the size of the jacket or the semi or the floater that you had to put it on. So you had to put all that kit on a given space. You don't have that problem with a land-based module. You can make it as big, as long, as wide as you want, as long as you can get it to the site. Cost. Early module planning, if you approached every job that you had as a module job, it will not cost you any more than doing that same projection as a stick-built job. The work in the very early phases is essentially the same. It's high-level planning. It's still working with concepts. The difference is very early on a module job, you need to look at the path of construction. You need to look at where you're going. You need to look at procurement issues. Can you get the procurement information you need to a module intermediate stage early enough to get the module yard, to get the module built? Engineering has to be done earlier. And if for some reason you decide that you can't do a module job and you've been planning it that way, you end up with a better planned job. A module job will increase the cost of the engineering portion, depending on how you look at it, because you're now interfacing with fab yards, shipping and setting efforts. But the earlier planning and schedule surety that you get from the fab yard, again, the Ford Motor Company analogy, you tell them you want a truck on one end and 2 days, 3 days later, they get it on the other end. The fab yard is in the business of getting tonnage out the other end. And so they know the best way to do it. And if you give them the engineering, you give them the equipment that you wanted to ship to them that they didn't buy, you get it to them on time, or when they want it, they will get it out to you. That's the way they make money. Impacts, execution plan differences, I mentioned these. There's almost an impact to every piece of your project on a module job. Some of them are subtle, but timing is critical. And especially in the Gulf Coast here, where we grew up with stick built, you cannot allow your favorite construction managers to re-engineer your on-site execution. It doesn't work. We have a specific way of putting the modules in, just like in the buildings, they have to go in a certain way. The industrial is the same way. You've got to get your undergrounds in first, and you have a certain path to get there, and you have to put it in a certain order. Critical success factors, they are critical to the success of a job, but they're really common sense for any job that you do. But important for a module job because there's less latitude, there's less wiggle room in the process of designing and shipping these modules. Experience and commitment, I heard it over here. You need a module expert on your job. The EPC owner, EPC and the owner both need module jobs. They need a module team. They need someone familiar with it. Those people need to be identified and they need to be talking to each other very early. And if you don't have one, go hire one. There's companies out there that do it third party because you need a module savvy team that works with each other. Inadequate technical background, I've been there. I spent more time trying to tell the owner why I was doing something different than what it took me to actually do the job, just to convince him that this is why we had to do it different. It requires some extra effort and explanation. If you have the guy on the team, he can work with the owner internally. We can work with our team internally, and then we talk. And a commitment. The module teams, both, it needs to be a single team. It means committed to the module solution. Everybody must be flexible and understand why the execution plan differences are there, that they are necessary, and they need to support them. And then they must work with each other in a collaborative rather than transactional manner. You really are going to have two strikes against you if you have a hard core contract, a transactional approach from an owner to a contractor, and you're trying to do a module job. It won't work. That's it. Questions? Yes.
Thanks, Michael.
Yeah.
Doug Omachinsky, I wanted to ask you, and I'm going to put you on the spot a little bit.
I'll go.
If we were to incorporate AWP concepts into modularization, do you think we could eliminate a lot of the mistakes that are occurring because of that early commitment that's required for AWP?
AWP, let me get back over here. AWP is, I don't like talking behind these things. AWP is a marvelous concept, and a lot of the owners are pushing the fabricators to provide an AWP type of project. EPCs are being forced into AWP. Yes, it will help. The thing you have to remember with a fabricator, he has a lean process where he assembles the piping and assembles the structural steel. He's got that to a science, just like an assembly line. Then he gets out to the fab yard and he uses the AWP, all the things associated with it to make sure that he has the material there. He has the sequence for putting it together. The issue is, it's sometimes hard. You can't tell them to use a specific tool to get the AWP, but you need to figure out what it is that you want from a support standpoint and what kind of input you want, and work with the fabricator, work with the EPC contractor to get that information back into your system. The companies that have a half a dozen of their systems for tracking, they're not going to change to a new system. So they work within it. And I think that's the biggest issue, is just making sure that we have communication both ways. But we believe in it. CII was looking at AWP and lean, and it's the way of the future. And really, it's no different than planning your work. I mean, it's taking the end, pushing it backwards to the front again, and just doing what you said you were going to do, and the best way to approach it. It's identified, and it's a good tool.
So can I add on to that, Michael? The project I just came off of, part of the contract requirements was max modularization and an AWP process. So all of our EPC said, yeah, we run AWP. We this is our normal process. But when we got into it, we found out the EPC really didn't have a process. But the saving grace was the module yard, as Michael said, was a lean assembly line process, and they pretty much run an AWP process. So what we were able to do is kind of backfill, work backwards and generate that EPC's process, incorporate the module yard process. So it really helped a lot. And what was interesting at the end of the project, because they were kind of against the AWP in the beginning, at the end of the project, I asked, how did we do with AWP? How did that help us in the module yard? And they grinned at me and said, well, I can't share our unit rates. And I said, well, I don't want to know what your unit rates is. I just want to know if it helped. And they finally said that they saw 10 to 15% improvement over their baseline estimate as far as. So that was significant. I thought that was very important.
It's basically forcing you as an EPC contractor, you as an owner, and the fab yard is already there, into figuring out what it is that makes the most efficient approach to your project and pushing everything backwards to get that done, 1, 2, 3, 4, 5 on through it. So.
Hal Kane and Associates. Michael, with these modules and the way the modules are designed in the office and so forth, does this push out your start of foundations?
It's an interesting concept. Actually, it allows you to spend more time getting out of the ground with a module job. Because you don't have as much stick-built scope of work, you can actually start it later. I was just working up a talk for another group, and I was looking at 2 module versus stick-built schedules. And basically, where on the stick-built schedule, you were starting at about month 4 or 5 to do the undergrounds. With a module schedule, you could start in this particular one like month 8 or 9. And because you have a smaller stick-built scope, you're basically doing piles and supports for the modules and the undergrounds, and that's all you do. The other stuff is already in the modules, so you bring those in late. And so you have the ability, you don't have to do that, but you have the ability to do it later. So if you have issues with underground or something like that, it offers you more flexibility. That was too easy.
More questions? Yeah, that was pretty easy. So you did a good job.
No. Just talk fast.
Minutes here. We could just let everybody, we have a mild schedule for 15 minutes, and then we'll go into the next presentation. The next presentation is going to be virtual. So like to have everybody back in here for 10:30, okay?
Good, thanks.
So Palmer, yeah, the next presentation, we have, I have to get my, Joe Coate is a vice president and general manager for Chinbro. He's going to give us a presentation on data centers and e-room modules. So let's have a welcome for Joe. He's trying to bring him up. Can you hear us, Joe?
I can hear loud and clear from Maine, yes.
Okay, just a second. We're trying to get your presentation or get you connected here so everybody else can see you.
Mm-hmm.
And there we go. Okay, we're good to go, Joe, if you want to go ahead and get started.
Good. Good morning, everyone. I apologize for not being in sunny Cape Coral in person today, but I'm up here in not so sunny Maine, a little cold and weather, but that's not going to stop us from having a little fun this morning, getting down through some modules discussion here today. So thanks for having me. And again, I apologize for not being there in person. So I'd like to talk a little bit about data centers this morning and e-room modules. I'm not here to educate us all on data centers and their components and exactly what they do, rather than to talk about the types of centers that are there and electrical room modules and how we can modularize these things and add benefits to customers and improve customer delivery and things like that. So I think that without further ado, we'll get going on some of the slides we have here. So a little bit about Chinbro, just so help someone understand who we are. We're an employee-owned company. We have about 4,000 team members. We operate up and down the eastern seaboard and westerly and into the southeast and south, into Texas and a few other spots in the Midwest. We are a parent company of Starcon and AZ Corporation. Starcon primarily works in the petrochemical and refinery businesses, and AZ does a lot of vertical construction, some design work, a lot of mechanical type work, and things like that. But together we are comprised of the Chinbro companies. As a company, we're certainly diversified, and we focus on buildings, vertical construction, industrial manufacturing, infrastructure, power and energy, and refining and petrochemical. The module concept, part of our business, actually falls in the industrial manufacturing market sector. And in terms of how we go about executing the work we put in place, we do self-perform most every major discipline. As you can see down through them, I'm not going to read down through them, of course, but we do take pride in that. And collectively, between Starcon, Maisie, and Chimbro, we can assemble a good team and help and execute the work we're doing. So that's a little bit about who we are, and just to give you a little flavor about what we kind of do. So let's talk a little bit about large-scale data centers, and then we'll contrast them against smaller edge data centers. So I think most of us are familiar with what a data center is. Again, I'm not going to go into particulars about that, but when you look at the picture of the screen here now, this is a very large center, and as you can see, it's with the solar panels, it's a very large energy user. I think we all know that, and the amount of energy that we use to move this data around creates certainly a lot of heat and things like that. So there's lots of ways we can do to modularize a otherwise stick-built center. If you look at the photograph in front of you now, you can see some of the HVAC cooling skids and things like that. So we can actually build these modules, if you would, ship them to a data center for it to be assembled in smaller building blocks. We kind of call them Legos, for instance. So get some idea about what they look like on the inside. Again, there's lots of equipment, between routers and switches, firewalls, servers, application delivery controllers. Again, not here to give the details about some of those things, but quite sophisticated, but we have installed them, and certainly the owners install them as well. But at the end of the day, you look at them, it takes a lot of energy, a lot of power, and you can modularize these skids, set them in place, bring them to the site, and assemble these things, certainly reduce your construction time. So again, these are large-scale data centers, generally speaking, house a lot of data, and they're centrally located. In contrast, we have the new and emerging edge data centers, and I'm sure a lot of us have heard a little bit about some of these things, but basically, these work on the perimeter, if you would, out on the edge, closer to the point of data generation. And again, I'm not going to give the details about them, but our experience in building data centers for edge data centers, and we'll go into more of that in a few more slides. But again, I think the salient difference between edge data centers and large-scale data centers is certainly the improved speed at which the data moves back and forth, or reduced latency, as we call it. And it does enhance the customer experience. And depending upon the business you're in and what it might be, an edge data center may be better for you than a centralized data center. But what we do see in edge data centers right now, that according to Cisco, for the last couple of years, the next decade going forward, we're going to see an increase in growth rate around 25% annualized, which means that this industry with edge data centers is going to grow from a $5 billion industry to a $53 billion industry. So we have, again, played on some of this space already, and we see this going in a direction that we can definitely support from a modular perspective. So before I get into the benefits of modular approach, any questions so far? Modules have been around for the last couple of decades, and we'll talk a bit about the benefits here. I think that certainly it took a while for the industry to even embrace the modular concept. A lot of customers in engineering companies, contractors like to stick build. I think we're there in terms of modularization. Undoubtedly, that's why we're all here today. But I see over the last decade that the industry has certainly warmed up to those benefits. But some of the benefits, and we've all heard a lot of these things, that we can define the scope specific to and tailor it to the end user's needs. So we can take and put some uniqueness in some of these things, and they're certainly compacted and all interconnected. And so we can really refine the scope of work in smaller units and tailor it exactly to what the customer is really looking for. But beyond that, the new approach to these things in the industry now is productization. We've talked about productization is new to construction, not quite as new to probably manufacturing, but this embraces, design one, build many, versus design one, build one. If you stop and think about construction, and we're all in that business, at least we are here at Chimbro, we try to make construction as efficient as you can. And candidly speaking, it's somewhat inefficient because it's so much uniqueness to it. And every time we do a project, it's by the time you get a good stride going and get the benefits of it, the job is done. Unlike the modular concept where we can introduce productization, design one, build many, you start to get economies of scale, you start to improve on the execution of the work, productivity goes up, and basically it's removing the snowflake effect of design one unique, where we build one, and now we can build many of these things and deliver them. So the industry is certainly embracing productization. You can hear a lot more about that, and we certainly are taking the benefits of that and passing those savings on to the customer. Those savings come in due time to market. We can improve the cycle. We can reduce the amount of resources we have on the project in terms of headcount. Equipment can be reduced. These projects are scalable. And anytime that we can do these things, it also enhances safety. Safety is enhanced. I would say it this way with quality. I'm not saying you don't get good quality when you stick built at the job site, but certainly the cost of attaining quality is more cost effective in a modular control setting than it is on an otherwise stick built premises. So all these benefits turn into savings and to the customer. And it goes without saying that we're all very sensitive to the environment now, and with all the carbon reduction initiatives that are out there, I think we all need to embrace this. When you contrast a modular shop compared to stick building in the field, certainly the amount of energy that gets consumed and the type of energy that gets consumed is different. We use a lot of electricity here at the yard and the shop, and whereas you go to a stick built, you have a lot more equipment, power generation in some cases, burning electricity, fuel to make electricity. All those things have a negative impact on the environment in terms of carbon, and not certainly lending itself to carbon reduction initiatives. I can also say that from a delivery perspective, we have clients out there that we work with from time to time, and a lot of them are getting more focused on logistics and emissions impact. They would rather pay a premium to have it built probably in the United States, closer to the point of delivery, than to have something built offshore where they can save, but because of the transportation costs and things like that. So a lot of responsible large companies have become a lot more sensitive to the impact of global warming and carbon reduction. So we're seeing a lot of that as well, and certainly we can all work to reducing carbon by going with the modular approach. So these are certainly the overall benefits. There are many others as well. We'll not have the time to get into the details of those, but certainly as we looked at the benefits of modularization as it applies to data centers and e-rooms, and for that matter, anything else that we build with the customer. So a little bit about our experience to share with you here this morning. We have experience dealing with data centers. We built 25 centers. Each one of these was 3 modules apiece. So 3 modules made up 1 center, a total of 75 modules altogether. Again, these were plug and play. This lent itself extremely well to productization. We were able to strip out a lot of cost, a lot of savings, pass those on to the customer, working with the customer, and certainly as you build one, if you see that you want to make a modification to it, or whatever it might be, you can build that into your system and then build the balance of them. So we had a great project here, and again, 75 mods, 25 centers. All it was completed at the shop, server racks, wiring, all the like. So some customers like to do that in the field, in the building we deliver, others like to have us do it for them. So on a larger scale perspective, we've also built electrical room buildings. A lot of people don't think about building a large electrical room building, especially one that's going to go on the water for voyage delivery. We built 22 1, 2, and 3-story electrical room buildings here for a client a few years ago, and these are all delivered on the Atlantic, and they were roughly 140 feet long and roughly 70 feet tall and 45 feet wide. These were the equivalent of a 480 megawatt power plant, whereas we had one building that took all the commercial power in from the local commercial company and redistributed to all these electrical room buildings. They had all the variable speed drives. In fact, you can see them in the background behind me, and I'll show you another close-up of that in a few minutes. But you get some idea about what these have. They have harmonic rectifiers, battery systems, fire alarm systems, and we build these as well. So when you look at, again, from a concept of modularized, these buildings were unique by themselves, but the building itself was assembled the exact same way with welded moment connections. So we were able to stand a building in just one day, inside it and floor it in, and you'll see a couple of photographs of that coming out. So some sample data centers here for you. You know, because of some confidentiality reasons, we cannot really show you specifically what we built for the client. This stuff is relatively proprietary and whatnot, but you get the gist of what we're talking about here. That again, a single design, allow for construction, efficient installation, build one, design one, build many. Again, 3 of these particular mods would be make up one data center, all outfitted, and some were built with Connex boxes, but you can also start with a custom built fabrication, again, to fit the space that the module needs to go into. Sometimes a standard Connex box won't work, but we can certainly customize exactly and tailor it exactly to the customer's needs. So again, I can't show you the exact photographs, pictures of what we built, but you get the idea from here. This photograph is 6 of those 22 electrical room buildings we put together. You get an idea of the scale of these things. The brick building is actually where I'm seated right now, but some of these buildings in the background are 2 stories tall. Again, there was some 3 stories tall buildings. These all got built, tested 100%, and basically were plug and play. What's unique about these is that, you know, when you build a building like this, you don't use a lot of temporary stuff. You build the building as it is, you put the permanent lights in there, and you use those for your lighting, versus put some temporary lighting in and remove them and reinstall the permanent lighting. So when you're in a modular yard, there's a lot of things you can do that help strip off some of the costs and things like that. So here you can see what they look like from the exterior. The next shot will be an interior shot, but these are all picked up, put on a barge. They're protected from water intrusion and get delivered to the premises and side up to an existing building that houses all the equipment. So, and this is a picture of a finished product of an electrical room building. Again, I've talked about the lighting, but if you can envision standing the frame up for this, welding it out, siding it in, and putting the floor in and putting the equipment in, but everything from the top down, you know, from fire suppression systems to detection systems to cable systems to lighting. We build them from the top down through and light them up, and you have a finished product. So basically, that's what I had for you this morning here, just a little introduction to help kick off some of the next roundtable we have, but I'd be happy to answer any questions anybody has on data centers or e-rooms and the modular approach to it.
Have any questions? I guess I have one question, Joe. Is there any special, you know, when you start shipping all this electrical equipment, you know, especially down the Atlantic coast, is there any special preservation requirements that's needed to ensure that, you know, this stuff doesn't absorb any salt water or any issues?
Now, that's a great question. So that's the one that everybody's more concerned about. Certainly, number one, the design of the building and the way the building is built has, to try to keep weather out anyway. I mean, we have a lot of storms anyway, especially up in the Northeast. These happen to be going to Canada. So they have to be able to withstand during construction and during operation the weather events of 60, 70, 80 mile per hour winds we have up here, a good nor'easter we call them. So number one, the building designed that way, but we do take extra care and caution into how we maybe seal up around the doorways and other places that water could infiltrate. Lighting systems, we take the ballasts out and protect them, whatnot. So literally no water will get in. And depending upon, obviously you try to sail during a good voyage weather if you can. If you're going to make a transatlantic crossing, you can do those, but you want to pick the right time of year, of course. But it has a lot to do with the design of the building, the skin that goes on it, how we fasten them down to the deck of the barge, and like again, the design will withstand weather. So, and we had no callbacks or anything, and zero water infiltration.
Okay, thank you. The other question I had is I'm used to working with an EPC, and when you go to the fab shop, a lot of the detail design, like the steel piece marker drawing, steel detail design. A lot of people use Tekla, and if there's any piping and stuff, they would use like a spool tracking program. How much design do you guys have to do with these type of buildings in your module yard, your design office?
Great question. Now the E-rooms, that was actually design build. We're the design build contractor of record. We actually partnered with Stantec on the design of the building. The company gave us general arrangement drawings of what they wanted to look like, but in terms of the design of the building, the accelerations due to shipment all had to be taken into consideration. All that design was done with us internally partnering with Stantec. What we brought to the table on that is our constructability approach. So they would design something and temporary shipping steel and things like that, how to put it in, how to take that stuff out at the point of delivery. So a lot of that was done with that way. Other buildings we've done have been completely designed, and the data centers we showed you earlier, the smaller truckable ones, they were designed by someone else. We actually built them, again, maybe made a few modifications, whatnot. So it really depends upon the customer and their relationships or how they want to go about certain things. But we've certainly done both ways. I would say that the larger the building scale, the more fundamentally for us, it's a little more cost effective for us to partner with somebody to do design work. If you're going to buy one small building, maybe a smaller shop or something like that. I'm not trying to push work away from us, of course, but certainly someone who does internal design work might be better for that. But we'd be happy to entertain anything like that, of course. But that's how we've approached it.
Okay, thank you. We have one question that was submitted online. It says, is there any water for cooling, plumbing, or fire protection in any of these modules? If so, how do you deal with the drainage?
Yeah, good question. So yes, there is. All of those things are involved. I mean, each one of the buildings you looked at on the those E-rooms, for instance, and a smaller data center too, for that matter, all have their own self-contained HVAC systems, right? Now you can modularize it such that you could put separate modules together and have an HVAC unit that takes care of all three, but these have their own units with them. In terms of plumbing, whatever the plumbing needs are, get installed. It all gets tested. All the piping is put into the local code and gets pitched and drained appropriately, so we can charge things up. We test them. We build year round up here in Maine, as you all know. It's not quite like it is down in Florida in the wintertime. Up here we have a lot of sub-zero weather sometimes, and we build right through the wintertime, and we make sure we drain the water and pitch it out, and it doesn't present a problem at all. We've had zero callbacks for any module that we built due to things like weather or temperature sensitive equipment, but all that stuff gets installed right from fire detection, fire suppression, all house load for electrical work, all that stuff is lock, stock, nameplate, everything. They literally drop it in and plug it in and it goes. So it's really saves a lot of work hours on site.
So one more question we have is with all that electrical equipment that we've seen behind you and in the previous picture, is that procured by the architectural firm, by the owner? And one of the biggest complaints we get is this equipment is free issued, and the modular yards say it's always late. So how do you have any of those issues? And if you do, how do you address that?
I tell you, a lot, I think I'll answer it this way. A lot of clients, if they, on a larger project, especially when they lock up with maybe a designer EPC company, the company likes to buy the equipment. And if they got good buying capacity, they ship it in. And I'm being right straight up with you all. When you do that, and the contract is trying to maintain a schedule that we submit to you, you got to get the stuff to us on time. And we all know what happens when that doesn't happen. There's certain things we can do to work around those things, but from time to time, free issue material and the supply chain of such does cause problems, and it ends up costing more money sometimes. Whereas if the contractor were to source it, we control our own destiny. It's on us. So the electrical room buildings you looked at, we supplied most everything on that, all the steel and all that. But the switchgear was issued to us, free issued by the engineering company. A lot of that stuff has very long lead items, right? So obviously, for those reasons, you want to get out in front of it. By the time the mod yard gets involved, sometimes it's too late. If we're involved early, yeah, we have buying capacity. You can simply buy those things. So it has a lot to do with the timing of the project and what we're buying. But honestly, when we erect steel and piping systems, it's convenient for us for you to free issue it, but we'd rather control our own destiny, and it's usually cheaper for the customer if we can source those things ourselves. That way, when you come at us and it's late, you're only going to come at us, and we're not going to throw it back at you and say, well, you got to talk to your engineer because he didn't get the stuff to us in time. So I'm just being straight up with you. That's all. So.
Yeah, thank you. Appreciate that. Any more questions? If you think of something later you want to talk with Joe about, or Peter's just here also, we can always catch him. But Joe, thank you. We appreciate it. It was a good presentation. A lot of enlightening ideas there.
Thank you very much. Good. Thanks.
And the next thing we're going to do, we have our panel. No, yeah, I sent you the wrong one. So we have our panel here, and I believe this is Joe. You're also involved in the panel, and then Joe Dorsch from Lyondale, and I think Michael also. So the next panel was going to discuss commercial building challenges and opportunities. You still with us, Joe?
Yep, I'm right here, Bill. Yes, I am.
Okay, so we have Joe from Chimbro is going to stay online and be one of our panelists. Also, Michael Gluck from KBR and Joe Dorsch from LyondellBasell. And we're going to continue on this same vein of commercial, kind of the commercial view of modular, and get some views from these folks. Now, not only is it in a pure commercial view, but also in the industrial space, we have commercial applications as well. We've discussed some of that, such as your electrical bill, MCCs, control rooms and whatnot. And so we're going to see both industrial and commercial space. And I think it'll be good for us to look at some of that. So looking at that first question there, again, Joe, I know you know, obviously the data centers and electrical rooms have been very good in terms of modularization. But is there some other opportunities you see in this commercial space for additional modularization, maybe more in hospital pharmaceuticals. I know some of the pharmaceutical companies are here. So Joe, can you speak to that?
Bill, a great question. So absolutely, again, as I mentioned a few minutes ago, that, the whole modular concept is beyond its infancy here now. I mean, we're starting understanding it better, but I think what a lot of engineering firms are and a lot of designers are really understanding better how to take it and go a lot further with it. So look, we can modularize anything that you want to build. It can be panelized, it can be modularized. And certainly from a commercial perspective here, whether it be a pharmaceutical or hospitals or buildings, whatever it's going to be, I mean, again, it has to do with the mindset of starting right at the beginning, exactly what the goal is, how you want to go about building it, constructing it. So we see a lot more building modules, hotels, things like that. Condos are starting to look at those types of things with BIM and all that. So certainly we do hospital work as a company. We have yet to modularize something, but when you look at you take a look at a hospital room, for instance, you may have I know we've all been in rooms, we don't like to go there, but you look at the headboard and there's lots going on between clinical oxygen and other electronics that are all centralized, whatnot. There's so much you can panelize and modularize in a particular room. So yeah, I don't want to say the sky is the limit, but certainly we are finding ways, and you can think in some ways of with the COVID thing is causing us to look at different ways and different approaches to things. So you're going to find where there'll be a lot more of this stuff going forward. And there is some now. Again, I think now that the industry is warmed up to the modular concept, I think we've got that decade or two behind us. I do think that you'll see a whole lot more of this going forward. So by all means, yes.
Very good. And I guess from the industrial space, I know we're picking up some modularization of some of our commercial applications, such as control rooms and MCC, switchgear. Is some other areas you think in the industrial space from a commercial standpoint that we could see?
Hello? Okay. One thing that I heard actually when I was in a previous PIP convention, we were talking about some hospitalization, is there was a concept of modularization, some of the utility pieces within the hospital, and they were basically pipe racks. And so what they did is they built a unique design to fit little carrier that they put all of the ductwork, all the piping, the utilities, all the oxygen, everything that normally goes up into the ceiling. They designed this stuff and they made it the length that they could get through the different hallways. And they used this little device to just roll it in there and basically just jack it up and then tie it to fixtures or fasteners on the top. And so they basically took all of that stick-built stuff and used the industrial modularization concept of a pipe rack and put this together. And it was really slick, and it saved a lot of time and a lot of space. And they could build this stuff at grade on site, all the things that you normally do with modularization, and it worked well. So
very good.
Just maybe one comment. Within Lyndell, just about all of our ECR rooms, MCCs, remote enclosures, all of those things are fabricated offsite now. One of the things that drove us to doing that was most of our sites are built in areas where you have flooding issues. So we elevated them, right? And we started elevating them and stick building them, and it seemed to make more sense to elevate them and just bring them in and set them on those areas. The other areas I would say that we're moving more and more to, and I assume other industries are as well, is more remote, IO associated with it's not connected with cables anymore, right? So fabricating those, I'll call them enclosures. If you do it offsite in a controlled environment, you may have different levels of quality that you need to pay attention to, for example.
That's good. Again, we're starting to see more and more applications. Obviously, as we said, modularization has been around for a little while, but as we get more sophisticated, better technology, smaller technology allows us to do more things. And like you said, it's less and less cables, right? Where you're getting a little bit more wireless and being able to get more flexibility there. Okay. Yes. Any comments from the audience here on commercial applications that maybe we aren't seeing? Again, just think about that, because that's just something we want to look at as we all go back home and go back to our offices and our teams. It's be good for conversation.
Russell, maybe a comment. We've been talking about trying to standardize design for a long time. It seems like that could be a focus area that as an owner, I really don't want to redesign a cooling tower or some thing that's not really adding a competitive advantage to my whatever I'm trying to build, right? So if we can continue to find ways to standardize some of the design, it would be extremely helpful.
You know, and that's one of the things, I go back to my IT days, with our modular coding, we take code that's already been built. Why do we need to rebuild it? And again, as we go industry forward, if there's standard things we can do, and we always say in our industrial space anyway, that, everything's got to be different on every site. It's not necessarily so. We do have opportunities to make it industry standard and even owner standard. Like you said, you set some standards. Why shouldn't we have that available? Okay. Let's look at our next.
So Russell, before we leave that, I have a question for the committee. In a lot of the industrial areas, we have control rooms out and we do dispersion models and all of a sudden we find out that we built a control room that it was in an overpressure zone and it had to be rated for that overpressure. And I know we have a lot of people from the State Department here and we're designing a lot of our buildings, embassies and stuff for an overpressure situation.
You're talking about like blast-proof buildings?
Blast-proof buildings. And just wondering if you've had to deal with any of that and on a modularization level.
Yeah, most definitely. Just about all of our ECR rooms have had blast resistant kind of buildings around them. I mean, to be honest with you, it's not a big deal. I mean, it's a kind of a standard in our environment that's what we deal with. They're not meant for, human occupancy, but they're meant to protect an individual that might be in there that's working on the unit, right?
Yeah. Okay, so kind of a general question here, but I think it's very important. We've kind of addressed some of this in some of our earlier panel discussion, but again, thinking about commercial space and even commercial applications in the industrial space, what are some of the challenges facing our industry in these type projects? And what are the roadblocks? I know Michael in his earlier discussion brought some of those challenges up. Again, just if you want to touch back on some of these, on some of the challenges that we may have.
Yeah, I'll touch on two or three of the ones that are really key to me. I think one of them is contracting strategy. Along with that is the collaboration effort that's required for a modularization job. Because we're moving a lot of stuff to a intermediate fab yard, we're having to do things out of sequence. We're having to get things earlier. We rely a lot more on owners and contractors to go ahead and get information to get that to the module yards. We can get it in time to get it out. The other thing is just planning early. AWP was mentioned. I think if the owner and the client and the EPC agree that they want to build this somewhere, let's start at FEL 0, FEL 1. Let's start talking about how we're going to do this from a prefabrication modularization standpoint. Let's get your teams involved, get everybody involved, and start designing with that as the basis. If, like I was telling somebody else, if it falls back to a stick built, you're in way better position with your job, assuming it was module to start with, because you've done way more planning than you typically would have done for a stick build. So I think there's really no downside for planning a job as a module first or a module job first, and then just seeing where it goes.
Just some context. So we're building a large facility on the northeast side of Houston. We put in about 50 modules on our project. Most of them were pipe rack, cable tray, pretty straightforward modules. It went very, very well. It allowed us, as we talked about, to get the undergrounds, to get the concrete. We had issues with some underground or some differential settlement in some things, and those issues were able to be resolved prior to getting, things so we could get really pretty much out of the ground. But a couple of learnings for us. I don't know how many people would say that when you did a modular job, you wish you would have done less modules. I think all of us would probably agree that I would have liked to have done more modules on our job, right? It just, that decision point of what to modulize and what not to modulize seems like a a debate all the time, right? I don't know.
Yeah, it's absolutely. I mean, some of the bigger projects that I was on, the construction manager on site was going, why didn't you modularize this? We ended up modularizing a 12, 1,500, 2,000 ton module, and then we built all kinds of stuff around it when we could have simply just included that, but we had directions on pretty much stipulated on what we would modularize and what we wouldn't. So yes, you almost can't over modularize it once you make that decision. So typically you do under modularize. That's correct.
The other simple thing I would suggest is put platforms into the modules that allow your constructors, whenever they're going to install the modules, to access versus using scaffolding. We tried to do some of that and we've eliminated some, but we still have more scaffolding on the job than I'd care to have. And the clips and the design for a permanent scaffold, it may not be used after construction, is minimal compared to the labor cost you have when you're installing it, right?
And if you work with any of the groups in Canada, they've created the pipe rack modules and some of the stuff that goes up the Alberta highway. It's a standard, and they have a standard process for designing these things, so they actually have walkways between their electrical cable trays. So not only do they do it on the end, but they do it in the middle, and they design it that way into it. It's very cheap. It's very reasonable. The key thing is you've got to plan it ahead of time and think about your hookup crew and what they're going to need to get to it, and just provide the access. It's just have to think about it.
So Joe, from Chimbro's standpoint, commercially, what are you seeing as some challenges commercially on some of your projects or with some of your owners or whatnot?
Well, I think certainly, I think we touched on a couple of things already in terms of free use of material and things like that. Those are always will be challenges that are out there for us all to deal with. Whatnot. Obviously, right now, from a labor perspective, certainly that's always a challenge to get the right number of technical skill set at a job site. I mean, we are, in some respects, we're sometimes our best customer. We modularize stuff for ourselves because of the ability to put staff on a job site, or because of trade stacking or things like that, and lack of workspace, whatnot. So certainly, again, we make that challenge an opportunity by modularizing a component and sending it out. So those types of things there, I would add as well.
Okay. Anybody in the audience wants to chime in on challenges you may have seen from a commercial standpoint, maybe in the industry as a whole?
One of the things, as far as you were talking about pipe racks, one of the things that I've seen in the past with large modules and working in large refineries and putting in a whole slew of pipe racks is access, and some of those plant roads are very narrow, and so the planning has to be such that you're aware of that, and you don't go in with blinders on.
I think one thing that I always suggest anybody that's looking at a modular job, the absolute first thing you look at is the location of the plant site and the biggest box, as I call it, you can ship to it. And before you do anything else, that would include not only to the site, but also once you get inside the site, inside the plant itself, what is the biggest box you can move around to where you want to go? And based on that, you can get pretty creative on the size of the module and how you put it together. But that's critical. That's the first thing, and very critical.
Yeah, and I would, and to add to that, in addition to how big a module can be to get it there, but also while you're on site in terms of craneage, can you get that crane in the position? Because some of these modules obviously are going to have some weight to them. Is it wide? Are they wide enough to get in there and get a crane in there to do it? Do you need a huge crane to reach over things to drop these modules in? So these are all considerations.
Yeah, along with getting the module there is the whole heavy lift study within the site. And that's an art in itself. And we were fortunate in our company to have somebody with many years of experience, and he would go in and lay out the different types of cranes and determine what you could lift over, what you couldn't lift over, and whether it was, and then at that point, did it make sense to do that, or did it make sense to go some other way?
The other thing that and maybe it was my inexperience, but the fact that you can jack most of these modules versus lifting them. We predominantly didn't lift hardly any of ours. And we built that into the design so that, you know, the limitation on the cranes and what have you. Obviously the SPMTs and the jacks and some of those things are limited as well, but we figured out some ways to get around the crane issue, just to focus on the.
Yeah, if you have a way of jacking it, I don't see. Oh, there's Robert. If you can have a way of getting it in there, Robert can jack it up and put it in place, no matter how big it is. And there's some amazing things that they do. And like I was telling somebody else, I said, bring these experts in, bring the people in that along with your startup and your commissioning people and your O&M people, bring your logistics people in. They have some things that they can do that you won't even conceive in your wildest dream, and they can make it happen. So again, get them early and it'll open your eyes.
All right. Any other questions or comments regarding challenges? Okay. All right. So, you know, we continue to talk about modularization in general terms, but you know, if we start looking at this, and I know, you know, Joe, you just brought that up about from an owner standpoint, if I'm repeating these plants over and over and I have certain components that are the same, you know, there's an opportunity for repeatability and standardization, and not just from an industry standpoint, but even from an owner standpoint, correct? I mean, that's what we're looking for. So any other, I guess, comments regarding that, where you can see some repeatability and even some standardization in the industry regarding module in general? Any comments on that?
Well, one thing, and I mentioned this yesterday in our meeting, but your utility systems, your air, your nitrogen, all the stuff that you design every time you build a plant, you know, you really don't need to do that. If you as an owner can say, we're happy with off the shelf, let the contractor do a quick analysis on, you know, buying something slightly oversized, maybe not quite the right fit, but still provides the product. If you can just get it off the shelf, you can save a lot of time and a lot of engineering.
To tell you, within an owner organization, that challenge is sometimes difficult. So what we tried to do was to try to say, these components are going to be off the shelf, and get agreement from the engineering commissioning, the owners of the facility, that those are really not meant for discussion, right? But that was a challenge, right? Because everybody in a plant has an experience on how vendor X didn't work, or whatever the issue might be, right?
Yeah, you have the obvious owner side with their preferences, engineering sides, EPC contractors. They're in the business in some cases to sell engineering man hours. So they're separate profit centers in some cases. So, you know, not pointing any fingers, but it makes more sense for some business case bottom line to redesign those each time. That's it.
That was going to be my exact question, right? So if we stay with the contracting approach that we have today, where is the incentive for standardization from an engineering standpoint?
I think there's some profit sharing that could be involved there. From an owner's side, I always call standardization the holy grail of modularization. You can cut off the FEL0, FEL1, FEL2, maybe even FEL3 when you go to your second project, and the schedule savings and the cost savings for doing that. If the contractor does, this is Michael Cluck talking, if the contractor does a good job on the first one, give him some benefit for providing that and cutting the schedule and cost, and give him incentive for getting to it.
That is my point, right? We've got to look at a different way to contract if we're going to try to drive standardization to be more of the standard versus the bespoke one-off every job kind of thing.
I was just going to add to that point and say, as you talk contracting strategy, that's one of the great things that Lean IPD does. So the incentive portion that comes with the Lean IPD IFOA contracts, standard solution for something like this. So I think more and more as we go into a service-based, you know, engineering world, the engineering firms will need to play a bigger role in an IPD, and I think there will be a ton of benefit for them for that. Because Lean IPD says the more you can save for the client, the more you get in profit sharing, right? It's supposed to be that way.
Yeah, the whole contracting scenario is a whole kettle of fish, but it's really, it's valuable and it could be very profitable for both EPC and owner if they just, look at the options and put a pencil to it and,
And you gotta look at it as margin, not more value, right? So the contractor will make more money, but not spend more hours.
So a question back to you, are you seeing the modularization actually driving some of the modular providers into essentially developing a catalog that these now are standardized assemblies? They could be scalable to suit your particular needs, but there's no need to design anymore.
I have, it's the shipbuilding industry. I haven't seen it as much in modular, but wherever you can get the shipbuilding industry, and there was some CI research done several years ago, the IPD interim product database, but where the shippers said we have 2 or 3 different types of hulls. Within that, we have 2 or 3 different types of bows, thrusters, machinery rooms, whatever. It was a Sears catalog type of thing. They said, you want a ship, you pick this, you can add this and this option. That's all you get. But the results of that were literally hundreds of % in reduced savings, cost, schedule, and safety. So if you can get the design to something that you can repeat to the point where it's like a catalog, I don't see that too much industrial modulation. I would see it more probably in business, in hospitals, in municipal type of things where you could do that more often. But there's too much uniqueness on a lot of the stuff that we do that you can't quite do it to a lot of the stuff.
I'd say Joe mentioned the ECR rooms, MCCs, the control buildings. Most of that is starting to get more and more common that they're all modularized. I mean, most of our projects over the last 5-10 years, we don't stick build hardly any of that anymore.
So Joe, I guess from Chinbro's standpoint, are you seeing, in the commercial space with your data centers, e-centers, that repeatability and, the standardization seems to be more robust probably than our industrial side, I would assume?
Yeah, so right now we're working with a client on repeating on a very large scale their product. They think they've got it mastered. It's designed right from the get-go as a modular design concept, and they get installed together in a training, get installed at different places around the globe. So they, right from the ground up, have started with the design on that. So I see a lot of that stuff going on. But there's one thing I'd want to also emphasize with all of us here. We talk an awful lot about the client, the customer, and the engineering company. And for those of us who are the contractors, that's the third leg of the stool. And at the end of the day, we have to build or construct or assemble what gets designed. And a lot of it is left off the table sometimes, not having pulled in the contractor early enough to get that collaboration going on early on. We've talked about how much better a module design job goes in terms of schedule, maybe heavy lifts. It forces you to think about these things. Well, if you can just take it back another step further, and it's better to catch something early than it is in the field or in the shop on how you're going to assemble something, having that early dialogue also with the contractor and the engineer, because look, I'm an engineer too, but look, we're not always right 100% of the time, right? And if you subscribe that, no one in the room is smarter than all of us put together, as a company we do, getting that early feedback from all three, the design, EPC, the engineer, the owner, and the constructor, now you've really got something, right? And then, if we can standardize that, it'd be the way to go. So the projects that we've had some of the most success on, we were involved way upstream. We just finished doing a job for Shell. We built a ethylene cracker for them. And it was designed, of course, by Lindy, but that was an evolution of years and years and years of some of the design work. And most of the modules, whether it's an A, B, C, D, E, F, G, or H module, were all the same. And we were able to streamline those things. I'm making a number up, but if it took us 4,000 hours to put an A module together, it only took us about, the second time around took us about, 3,800 hours. And at some point in time, you get the laws of diminishing returns on that, but you can really strip out that learning scale. But having the involvement of the contractor early on, I've been on some module jobs where you walk in and say, we can't install that component because no one was thinking about how they're going to put it together. So there's not enough emphasis added on the contractor's input early on. So.
Absolutely. And I also concur as a contractor in the industrial space, we certainly like to be involved early on. And just recently we won a furnace pre-installation job where the technology providers are going to provide us with their components. We'll put it together, not inside the fence, but we'll put it together. And then we won the installation, obviously. Another thing, these local fab shops, module shops have asked us to get involved on some of these module RFPs. So they're talking to owners and they're getting these RFPs and they call us and say, hey, we want you to come on site and assist us in the assembly, which is interesting because, we hadn't pursued that module with them initially. So it gives us a good opportunity to get our foot in the door and go talk to the owners and potentially be involved in the job on site. So it's so important, as Joe said, to get your contractor involved early on.
Yeah, and I was going to say that the fact, just like the logistics people are very willing to come in at the very, very early stage of the design, so are fabricators. Bring the fabricators in that you're thinking about looking at. Bring in more than one. It's not, you can't, just limit yourself to one. They're interested. They'd like to get their foot in the door. They'll give you and your engineering group ideas on how to approach it. And that's the best way to do it. Bring these people in and start talking.
I just think it's so interesting. We've matured quickly in other ways, but this modularization, as Joe said, has been going on. And I know, Bill has been doing that, was with his previous employee for many, many years ago, but yet the maturity, it just took time, right? I mean, it's just taking time in our industries. So, okay, let's see. I guess another one here is kind of open to the whole panel here. Are owners driving more offsite construction and modularization for these type projects? And if not, why? So what on the big question to me with this is that, do you see, you're as an owner, I mean, you are the drivers, right? I mean, we see that happening, not so much from an engineering standpoint or even from a construction standpoint, but let's say, Joe, are you seeing the owners really taking hold of this concept and starting to drive it as they should?
I'd say for our larger capital projects, yes. For some of the smaller in-plant capital projects, I think there's a huge opportunity there as well. For us, it's all about de-risking the project, right? Predictability is the name of the game in most of our business cases, right? If we can get it done, I mean, and it's not just, it's predictability across cost, schedule, safety, startup, all across the entire line, right? So that's where we pull the most value from.
Okay. Michael,
Yeah, I think the only thing I'd add to that is, yes, we see as an APC contractor, we see a lot of owners pushing it. What we sort of have to educate a lot of them on is not only the obvious benefits, but the subtle benefits that are involved. And especially as it goes to brownfield, once they finally find out that you're not going to mess with their product line, you're not going to mess with their going in and out of the plant, they're sold. Even if it costs more, they're willing to keep you out of their business, and they will do that. And once they figure out all the benefits, and that's why it's really important that you really examine all the project drivers for a job, not only just cost and schedule, but all the other things that impact it. And when you educate them into that, you get a good idea and you get a good direction from the owner as to where they want to go with it.
Okay, we got it. Doug's got a question or comment?
but a lot of the owners are dependent on either the EPCs or the constructor to do labor surveys. I mean, labor drives some major decisions in modularization. And so, you know, in Bechtel's case, we're engaged very early on labor surveys and labor studies for the region that the project's going to be built in. So that's got to be a driver. The owners don't typically take that responsibility when it comes to surveys, labor surveys, and availability of labor throughout, and especially domestically. Would you agree?
Yeah, I would. And we have our own business unit or people that do those labor surveys. They've got all kinds of public publications you can get. Anybody can subscribe to. But yeah, that's an important thing. And again, in some cases, though, the owners have been pretty proactive in determining where they want to go and why they want to do this. And they've done preliminary surveys, looked at industry stats on that, and they realize there's a labor problem. They realize there's a craft issue with a certain thing, and just with maintenance and O&M, they probably run into that on a day-to-day basis. So they have that in the back of their head, I think, and I think it's up to the EPC to flesh that out and make a case for it.
Okay, Joe, I guess as Chimbro, I mean, I know from a construction standpoint, you just said that a lot of times you wish you would get involved a lot earlier, but have you seen the owners and developers in the commercial space really drive the modularization, or have you actually had an opportunity to maybe recommend certain things be modularized that they hadn't thought about?
Yeah, so I think that I would be wrong if I were to say that the owners are there 100% right now, because there are lots of things that are changing out there. I think that we are well on our way. I think with CURT, and this is a wonderful setting today, and in the past with some of the workshops we've had and talking about this, helping us to, I don't want to say educate, but introduce the module concept. Of course, it's out there. Honestly, I really think that we're going to be forced to get there. Right? You know, when you and I'm speaking for the industry here, not just Chimbro, but you know, trying to find qualified, talented, you know, construction workers and engineers is getting more difficult in the industry that we're in. And if you look at the millennials and the Gen Xers and all those, you know, a quality of life for them becomes an issue. And trying to move 6,000 people to a construction site is going to become an extremely big challenge, especially if there's some work going on. So I think that because of all those things, I think you see that the industry as a whole, beyond just the benefits of what we're discussing here, I think is causing us to really look from within and to do a lot more to modular work. I think that for all the discussions we've had here today, that removing the hours off the site and trying to keep people close to home best we can is tough. And I will go on to say that you know, certainly large companies like Fluor and Bechtel and some of the largest, they got a pretty good handle on where talent is and availability of it, whatnot. But there are a lot of engineering firms out there who put engineers' estimates together who don't have an idea what the local labor costs are, or the ability to get attract and pull talent to a job site, or just productivity, those types of things. The next thing you know, you get to some of the budgets. Next thing you know, you've gone from a $2 billion job to a $2.5 or $3 billion job with labor costs rising, and the owner says, "Well, what's up with that?" And again, that's more reasons why you need to get the contractor involved early on. So, but I think in terms of modules, I think that because of the way we see baby boomers getting out of the industries and way of life and lifestyle for others, I think it's a space that we're going to be forced to be in, but it's a good space, and it's a space that will add value to the end use customer.
Very good. Yeah. How are we doing on time?
Yeah, I think you're good. Any more questions? We'll wrap it up here.
Okay. Do we
appreciate everybody, you know, our panelists for supplying the information, and I guess if you have any more questions, they'll be around for a while, so we could go ahead and thank you guys.
All right. Thank you, Bill. Thanks, Joe, Mike.
Michael, you need to stay there. I think this next one's with you and I, next presentation. And this is between us and lunch, so we'll go ahead and go through to bring this up. But I wanted to say one thing, on the owners driving, the project that I just come off of, we started back in FEL 0. And we had the luxury, we had a lot of people that had experience in modularization, and we looked at where our site selection was, and modularization played a big part into the site selection. The site selection played a big part into modularization. Now that was a greenfield project, so we were able to kind of control our destiny a little bit there, position ourselves for success. We don't always have that luxury, but here again, we started in FEL 0. We looked at our shipping envelope, and when we compared the sites, we looked at how big of a module and stuff that we could get there. When we went into the contracting, portion, we pretty much knew what we wanted to do. Modularization was there. That, it was already proven. We looked at the labor, we looked at the availability of people, all the costs. We did all the data gathering and analysis. And so we knew we were going to modularize. What we didn't know is how big or how much we could modularize. So we had discussions and we said, we're going to put in the contract, we want 50% modularization. We finally landed that we're going to say the successful bidder is going to do max modularization and let the EPCs and the contractors come back and tell us what they're capable of doing. So we thought we could do about 50% of the man hours off site. Ended up, we got 80% of the man hours off site. So when people got involved and I will say that some of the EPCs came back. We had one case where they come back and said, well, we think we're better off to stick build this project. And our answer was, well, you'll turn your bid in and good luck. And so that they changed their mind after that. And it turned out that they actually, once they got into it, it was a win-win for them and a win-win for us. So it turned out very good. But anyway, our next discussion, we wanted to just kind of share some of the committee's perspectives on some modularization and what's available. I get a lot of questions now, queries about data centers. Data centers are a big thing, and I think Joe showed earlier. There's a big market there, and we just got to get ready for it because it's coming. Data centers. I think we seen yesterday in a Mammoth presentation these windmills. Although we may not be building blades or building generators, it's going to impact us. When we think about the ships are going to be harder to get. Just cranes are going to be harder. So the long range forecast of what we're going to need, we're going to have to be get into that pretty deep. But also we got some inquiries the committee did recently about, hospitals and administration buildings. And so we did a lot of investigation, talked to a lot of you guys and found out there's quite a few people out there that build modularized hospitals. And when they're finished, you can't tell that they were modularized. And schools and administration buildings. Our project, of course, we was just like Joe and everybody mentioned, at the end of the project, we took 80% of the man hours off site, but people say, well, we should have modularized that building and that building. There was a few that we didn't. And in the beginning, we were pushing. At the end, we're trying to hold them back. But the same way with our admin building, our administration building, and our control buildings, they said, well, we should have modularized that. But in the beginning, it was a different struggle. So let me go ahead and start us through the slides here. We have a couple videos that we wanted to play. And I guess if you guys could bring up the first one there. This one was recently, they built a bridge across the Ohio River up between West Virginia and Ohio. And I thought this was pretty interesting. I wanted to share it with you. I thought that this is a little bit innovative. People thinking outside the box. They actually built the main span of the bridge. And I don't know if you're familiar with the Ohio River. It's a pretty big river, not as big as the Mississippi.
In case you missed it, the new West Virginia-owned bridge connecting Brillion, Ohio to Wellsburg, West Virginia became the first bridge to be built on the banks of the Ohio River, then shipped a mile down on barges to then be lifted into place. This impressive engineering feat is not only the first of its kind design-build project in both states, It's also one of the heaviest structures ever lifted in North America at a whopping 4,800 tons. And that's without rebar or concrete, just the structure itself. So how do you lift a 4,800 ton, 830 feet long bridge structure from a barge? Well, check out this time-lapse video shot by ODOT engineer Adam Litton, who oversaw the Ohio side of construction and is a native of Bridgeport, Ohio, and graduate of Shadyside High School. So you can see how the bridge was constructed on land with an opening on each end so the barges could float in under the bridge. The barges were already equipped with the lift system, so all the crews needed to do were slide the barges in and safely raise the bridge. Then off it went down the river until it reached its permanent spot. Crews then lifted it a total of 65 feet in only 6 hours. And finally, crews above secured the bridge to the piers. Although there is still plenty of work to be done on this record-breaking project, the bridge is set to open in the fall of 2022. It's incredible that crews were able to save money, reduce impact to river traffic, and complete the construction and placement of the structure in just over a year and a half. And finally, the lovely communities of Brilliant, Ohio on State Route 7 and Wellsburg, West Virginia on Route 2 will finally be connected, improving quality of life and economic opportunity. Who knew?
I think one thing you'll see there, you see a lot of red iron. That was the Mahmood effort. So again, get your logistics heavy haul people in there. They can do some phenomenal things that you'd never even think about.
So the next video we have is actually of the GCGV, and anybody can go to GCGV on this website, and they have quite a few videos. But we thought we would show this one. This is, these are mega modules, and I think we all get excited about those. But I don't really believe that that's where our sweet spot is. I think there's a lot of brownfield and retrofit projects where we can really use modularization to our advantage.
The highway was down for even less than 2 hours.
These modules are large. Many of them have a footprint the size of a football field, about 100 yards long by 40 to 50 yards wide. Some of them are over 200 feet tall, and more than the size, their weight, 8,000 to 9,000 tons. That's about 40 times the weight of the Statue of Liberty. The size of these modules is what's so impressive.
We had a lot of different groups that were involved in this that really made it a success. As one team, first you have Mahmood. They are the men in red. So these are the guys that are actually out there moving the modules and doing all the heavy lifting. And then you have highway barricades, also known as HBS. They are the ones who physically close the roads and implement the detours and put up all of the signs and barricades so that we can cross these modules across the road. Then you have Site-Wide Services. It's a local firm, MMR. So they are essentially our superheroes. They manage all of the details in each crossing. They put up all of the lighting. They literally move buildings and replace them when the modules have passed. They really take care of just about everything to clear the path for this module to come. Last but not least, we have our security team. So we contract 10 off-duty police officers who come in and they're really our eyes and ears and keep us safe as we're moving across the road. And you have our GCGV security team. And then we've been lucky to have the support of the local municipalities and law enforcement as well. We appreciate their support.
We've modularized to a great extent here, and if we had stick build, which is a common execution strategy in the Gulf Coast, we would have required more than double the people we have on site today. That would have had a significant impact on the community. So through this modularization strategy, we were able to have much less of an impact and continue to be the good neighbor that we've been throughout this process. We always believed that if we did our moves safely and efficiently, which is what we committed to do, that the community would support us. And that's been the case. We worked with TxDOT to plan the moves at a very detailed level and minimize the impact to the community.
know, when we first thought about moving these modules across Highway 181 and 2986, we thought this was just going to take hours each time that we did it of road closures. The great people we work with were able to shut the highway down and allow us to get across very quickly, so that in most of these moves, the highway was down for even less than 2 hours.
So we crossed a total of 44 nights. We planned and anticipated about double that, but we were really able to maximize our efficiency and combine shipments wherever possible. Across US 181, we crossed just over 10,000 axles. So that was about 42,000 wheels.
I just want to say thanks to everybody here in the Gregory Portland area for allowing us to complete this project and to finish up our final moves across Highway 181. You know, it took a lot of coordination and a lot of patience by everyone involved, whether you're part of the local community here, my new home, or whether you're part of TxDOT or local law enforcement agencies. I really appreciate your patience and just want to say thank you for allowing us to complete this project.
I feel a great sense of pride and accomplishment for our team. You know, we've been through a lot together in the last 2 years. We've braved the cold, the rain, the South Texas mosquitoes. Together we could accomplish anything. We could go to the moon. You know, I just thank them a lot for making this what it was. We're excited to watch the plant come to life.
When I think about the wow factor for me personally, it's that we chose a different execution strategy. We went big. We did the best we could, and we have no regrets. And now what we need to do, that all the modules are here, is to focus on commissioning and starting these up. And we're going to do that this year.
But one of the things they talked about TxDOT crossing the highway. We did a lot of that early discussions before we even had our site selection. We had discussed with Texas and knew what our incentives was, and one of the incentives was to allow us to build a heavy haul road and get in there. And Mammoth, we had engagements with them on how are we going to get these there and what are our restrictions. The big thing for this site is that we selected was we had a deep water channel. So we were unlimited. We could bring the new Panamax ships in and could bring these big submersible ships and our barge and module size was unlimited. Once we offloaded off the ship, we had no restrictions. We had to move some power lines. We had to work with AEP, move some power lines underground. But that all was decided before we even went out to talk to a contractor. I wanted to also address here, other modularization possibilities, and you can see, the top right corner there is an electrical control room. Comes in 2 units put together. And I think Joe mentioned earlier. For me, if we're going to do a project and we're not going to modularize pipe racks or electrical control rooms, these type of things, I want you to tell me how you're saving me money and how you're saving me schedule because I can't, I don't believe it. It would have to be a unique situation. The middle item there is a sump, and I put this on here because I thought this was unique. We had a turnaround, and we had contaminated soil. It was right in the middle of an operating unit. Basically the people working there doing the excavation had to wear a full suit with breathing air, and by being able to modularize that sump and set it down, we shortened that turnaround by about 10 days and had a lot safer process for our people. And then the bottom left, that was a modularization job we did in actually in Indiana. Now we talked a lot about involvement and owner's commitment. This was a module job. This was one of the failures. Okay, we talk about the successes. The GCG was a big success. This was a failure. What we did, we said, we're the owner. We're going to supply all this equipment. And so we went to the module yard. Well, our equipment was late. So now we've tied up the module yard, our equipment late. Then we made another bad decision. We said, ship it anyway. So then we shipped it. So the site where we didn't have labor and why we were trying to move man hours on, now we throw extra labor and work on top of them. So that was turned out, we got through it, but it was a big challenge. But here's just some of the other things we need to think about. And I talked with Joe, blast buildings and stuff, control rooms and, administration buildings, hospitals, embassies. I mean, a lot of these type things can be data centers. They're all getting a lot of traction right now. And what we've seen, we did a labor with FMI, CII in 2017, and we rerun last year. And what we've seen is, that we had a 19% improvement or increase in owners that were making modularization part of their strategic, process. So people are starting to see the value. We're getting a lot more traction, and we're getting a lot more questions around what can we do in commissioning too. I think we've got a lot better commissioning in the modular yards. And then Michael showed this earlier. It's an owner-driven process. The owner has to drive it. He has to have a plan when he comes in. He has to have done that evaluation. And if you don't have, an owner engineering organization, you can hire consultants that, like Michael, for example, will come in and help you, put your plan together and understand. And here again, assessment, selection, that's that early phase. You got to make that decision early. Changes happening, strategic planning. We're seeing this, people want to control cost. Got a lot of cost pressures, a lot of schedule pressures. Labor concerns are still an issue. I heard in the beginning, some of our procurement people said, oh, with COVID now, we have all this people out there out of a job. They're looking for a job. Well, has anybody found them yet? Because I haven't. And, recent successes have demonstrated the value of a well-executed offsite construction and modularization strategy. So we have a lot of successes. We don't advertise our successes as much as we do our failures sometimes. And, we talked about the owner's blueprint. We talked about this a little bit, what we're trying to do to try to give owners and contractors a better guide. And these are some of the things that we wanted to address. And I'm going to solicit anybody in the room that wants to be a contributor. We'll take all the help we can get, but we're hoping to get this done by next year and kind of give people a good idea how to start. I get a lot of questions. Well, we want to do modularization, but how do I get started? And hopefully, this will help. And I think CII is also doing similar things. We're working together, and I'm going to let Michael take it from there.
I promise it won't be very long at this, but this is a sort of a history of where CII has gone with respect to modularization. And it seems to be in a 10-year cycle, but 1992 Modex RT 029, it was their first foray into modularization research. Basically, they said, yeah, there's a general lack of information on modularization in the industry, and there's limitations on a systematic approach. So they captured some basic understandings, did some basic pros and cons, but currently it's been archived. It's been superseded by 171, which y'all may be familiar with, PPMOF, which is it was a prefabrication, pre-assembly modularization, offsite fabrication. This was a really good study. They did hundreds of actual surveys of module jobs. They developed a 10-page spreadsheet that basically you filled it out, you weighted the categories, and you really went into the details of it. The problem was, at the end of the day, it said, if it was positive, you should modularize. If it was negative, you should not modularize. And the question was, okay, how do you do that? Okay, we know we need to modularize. What do you do next? So that was 2002, 2012. I talked a lot about this. I'm not going to repeat it. This is where we actually went in the research and we actually identified the project level, the execution plan differences, all the stuff I talked about. Again, it was a great effort. I talked about this. It gave a lot of good information, but the feedback we got from this was, it's great, but I really need something that I can read. I don't want to read 120 pages of research. I've got 45 pages of the business analysis case. That's way too much. Can you just tell me 1, 2, 3? And so where we are just last month, we got 2022, 10 years. RT 396 was just approved for CII. It's a research. It's the business case analysis guide for industrial modularization. This is my modularization for dummies, my cookbook of modularization. This is what we've been pushing for years. It's going to kick off next month and start in January 2022, not 2021. sorry. But the essential question is trying to identify, and I'll read it. What changes or enhancements in the modular industrial project planning, design, and execution, and the advanced planning, AWP, lean, and other coordination requirements will be required to ensure success? And the goal, an industry guideline to encompass advanced planning guidelines for industrial modularization. Very similar to what CURT is doing with their blueprint. And since CNII and CURT are getting together here, we've been talking and I've been sending it back to CII. Let's get some CURT people involved in this research. Let's get it as one big thing and let's make it really good. But it'll include a gap analysis, brainstorming sessions, the typical research stuff, industry surveys. We had some tools we developed under CII for modularization. Those will be updated. It's about 1.5 years. We hope to actually come out with something that industry can use and not a research thing that gets very well written but stuck on the shelf. So that's sort of where we are. Questions?
Okay, it looks like we're going to open up some questions here. We got a few minutes before lunch, so we'll go ahead.
So my question wasn't on that one. I had a question for Lois. All right. So my question is more around logistics, and it's probably two-pronged kind of question. As we looked at that video, I was just thinking in my mind how the logistics industry is ramping up for modularization, because it sounds like on the engineering and construction side, we're starting to push that a bit more. Do you see that similar response on the logistics side? That's the first question. And then the second one is, as we looked at the video, the other question that came to my mind is how easy is it to find those kind of logistics vendors? Because I did 2 big modularization projects outside of the US before, and that was a very big struggle.
I'm going to look at Robert for a response to this and wake him up. But to answer that one question, it's easy to find the module logistics. It's hard to find a qualified one. And I'll leave it at that. But I think that's where you bring in your module experts because they have the experience. And you bring in the logistics people, and maybe Robert can fill in a little bit. But I think they are arming up for the onslaught. He mentioned some of that in his discussion yesterday.
Yeah, I mean, globally, there is a lot more interest in modularization. I would say we actually been pulling that effort more than anybody ever since I've been with Mahmoud. And I'm glad to see that it's going globally as well as in the US. I mean, we're very heavy into Arctic LNG right now. We've seen a push towards modularized LNG terminals, which until recently, a lot of people didn't see possible. So people recognize that we can bring a lot of knowledge to the table and latest technological advances to speed up installations and stuff of that nature. Shipping likewise, we dabble into that as well as a service provider, but there's also very specialist people with Boskalis, Dockwise, Costco, and those types of folks that you even need to engage earlier than you engage us, because those bookings need to even be made earlier than what you do with us. So I hope that answers your question.
So one of our project, the module yard that we built a lot of our modules in, the project before us was the Yamal project, which was actually built in Antarctica. And so that was a very successful project for that owner. They actually built the modules there and shipped them all to Antarctica. They had the right logistics process in place, and everything I've heard is very successful. Any other questions?
Stomachs growling.
Sound of silence. Yes, stomachs growling. Okay, with that said, we're going to do a
All right, appreciate you having me. Got the post lunch slot, so I try and keep everyone awake, keep it brief. This is typically a sit down panel discussion, but my colleague had to back out last minute, so kind of had to adjust on the fly. So bear with me, but how do I switch? Okay. So the plan is just to give a brief introduction of myself and my experience in modules, and then give kind of an overview of Maccabee, who we are and what we do, and then get a little more specific with our approach to modules for both barge ship and truck ship, and some of our experiences. So like I said, I'm Robert Morris. I graduated from the University of Alabama in civil and construction engineering. This was pre-Nick Saban, so I didn't go there just for the football. Yeah, but so that's kind of my background, civil and construction, and then hired on with Maccabee in 2009 as an assistant project manager in modules. And so I've been in modules for a little over 12 years now. So I've been there my whole career, starting down in the weeds with RFIs and document control and kind of down in the details, and then have moved on to project management, so I'm contract management, subcontract management, and business development, and now kind of oversee the department from a higher level and have my hands in a few other things. So I've got an opportunity to see projects from start to finish, and at multiple levels. So that's a little bit of my history with modular construction. And Maccabee as a company was started in '62 by Leroy Maccabee in Tuscaloosa, Alabama. So we're coming up on 60 years next year, and primarily started as a field construction company, working in paper mills primarily, and then kind of in the '80s expanded into pressure vessels, autoclaves, modular construction, pipe fabrication. So kind of expanded into what we are today. Now we at our Tuscaloosa facility have a large pipe fabrication shop, about 40 something acres of modular assembly space, tank and vessel shop, an indoor paint facility, and have direct access to the Black Warrior River. So, we're set up primarily in Tuscaloosa. That's where our home office is and all of our fabrication shops. And then our field side primarily stays in the Southeast. This is just an overview of our facilities. The kind of bottom left is the fabrication shop. And then you can see in the top right, that's right next to the bridge is our assembly yard and directly on the river. So this first project kind of gives us an idea of how we integrate all of our capabilities. So this project was a CO2 capture R&D facility that went down to South Alabama. You can see those center modules that are all in a row. That's actually part of a kind of the core process. That's about a 260-foot tower. So I'll kind of use this as an example of what we mentioned earlier in safety in modular construction. You can kind of see the last little piece on the far left is the 7th module. That module would have been on the site would have been about 260 feet in the air. So you can imagine hanging that steel and all the things that go along with that module at 260 feet versus in our yard here where we're working at 0 to 40 feet. So being able to build things on the ground, obviously we're more productive, but we're definitely working safer also. So all the steel was fabricated and delivered to Tuscaloosa, assembled by our guys. We had our pipe fabrication shop built every stick of pipe that went in that process. So all pre-assembled in large sections in Tuscaloosa. And then our field construction guys also did the install in Mobile. We have a pretty heavy presence in Mobile. So they were able to take that from what we did in the field and then put those pieces together on the job site. So this was an example of one that was built and shipped by barge. So primarily most of them had about a 40 by 40 footprint. And then you can barely see the bridge and that on the left side, we're limited by about 50 feet by that first bridge that we hit. So those are kind of our limitations, are really barge size, site access, and then that 50-foot bridge. So still fairly large size modules, not really considered mega modules, but for us, these are some of the bigger ones that we built. So that's kind of an example of a fully integrated where we're start to finish. We were involved early on in, 30, 60, 90 design reviews, and really had a lot of success because of our collaboration and efforts with the engineer and the owner, and then taking this thing from start to finish from a modular assembly standpoint all the way through field installation. So, just talking a little bit through some advantages that we touched on earlier. One of those was schedule certainty. One couple of the big things from schedule are we're working in a controlled environment, and we're also working with a known workforce. So I have known productivity. We're not competing with other things going on around a lot of these job sites, especially brownfield projects. That first module was going in an active power plant. This example here is another CO2 capture project that was going on about the same time, also going in an active power plant. These things were taking flue gas off the backside of a coal burner and extracting CO2. So we get in these active plants. We're fighting for space, we're fighting for resources. And so when I'm in the module yard and have 45 acres of open space, we don't have any of those challenges. And the other thing, throughout the module yard, we have utility stations set up. So I've got power, water, and electricity, readily available to run tools and equipment. So we're able to be more productive and, not have to bring things in that you would have to bring in temporarily on a job site. And the other thing is, we're able to start sooner. So, for both of these jobs, while we're assembling the first bit of steel, they're just now starting foundation. So, we're really able to compress that schedule and get started, earlier than we would be with stick build. Cost certainty, we talked a lot about that earlier. Along with that known productivity, comes a known cost of what it takes to do that work. So I'm able to put together unit rates early on in a project that don't have, excessive contingency in them, just because I don't know maybe I don't know the labor force of where we're going, or I don't know how much other contractors are going to hold me up because we're all working in the same area. So, when I'm in the module yard, I know what it takes to make a 4-inch weld, or I know what it takes to hang a ton of steel. So I'm able to early on in the project, even if you come to me and say, hey, I'm at 30%, I've got a rough bill of material. Well, I can, pretty much be open book and show you, unit rates that I feel confident that we can perform at. And you can use those unit rates throughout. So we can be involved at 60%, 90% as we're dialing that in. And those unit rates, I'm not going to change them. I'm confident still in those unit rates because I know we can perform to that. So, then it really becomes an engineering thing. Hey, if you add quantities, your price is going to go up. But if you're able to cut quantities, price can go down. So that contracting strategy has been fairly successful for us, kind of starting with a unit price at a budget, and then applying those unit rates, at IFC that can then be kind of rolled into lump sum, basically. So it's kind of unit price converted to lump sum. So that just gives us certainty and cost from the very beginning. A couple other things, we mentioned problems identified earlier. It's a lot better to know that piece of steel is not going to work when it's 40 feet off the ground than when it's 260 feet off the ground. So identifying those earlier, and then drastically reduce rework costs. So even if I do have a problem, if I do have to fix a piece of steel, I can do that at a much cheaper cost to the owner or to the engineer by doing it in the module yard before it's being hung, in the middle of an active job site. And then specific to truck ship modules, got a couple different, this is kind of a traditional pipe rack module you might see in a combined cycle utility module in a combined cycle plant, or a utility module in a refinery. We do a lot of modules like that. Typically somebody talked about the box earlier. Ours is about a 14 by 14 by 40 to 60 foot. It's kind of the box that we typically work with. You know, all the shipping contractors say we can move, you know, we can move anything. It's just a matter of how much it costs. You know, that size is kind of what we found to be. We were able to move it pretty much anywhere in the country, you know, without the need for police escorts and utility trucks. You know, we've moved, one of the pictures earlier was I believe 16 by 16 by 80, and that's the largest over the road module we've built, but it had a bucket truck with it and a police escort and serious limitations on when it can travel. So when we stay in that box, you know, we can fairly economically move it without big issues. And then the only other thing that limits us is obviously site access. So, you know, we need to find that out early before it gets on the road, you know, to make sure we can get it in the job site where it's going. And this is kind of the other type of truck ship module we get, which is more of a process system. This one actually went to 2 identical units that went to Chad and Cameroon, Africa. It was kind of a unique project that we truck shipped to Houston, and then they were put on a barge to go to Africa, obviously. But this kind of gives an example of our approach to modularization. We want to build these in their operating position. So if it's a pipe rack module, we're going to build those end to end. We're going to make fit ups as if we were making those welds in the field. Same here, you know, where we have equipment tying, you know, to another piece of equipment on top, we're going to make those fits in between modules. We won't make the weld, but we make sure that, you know, if it's flange connections, we'll make those connections. But we're test fitting everything to make sure that we have confidence. I mean, obviously we want the owner to have confidence that when it gets there and it's going to fit up just like it is here in the module yard, but we want to have confidence as well. You know, we want to be certain that when they pick it up and set it in place, that it goes together just like it did here in the module yard. So, you know, we take a lot of steps to, you know, add extra supports that may not necessarily be designed into that process, or, you know, it may not be in their structural design, but we're going to take steps to make sure everything is rigid. You know, we use a lot of red iron that'll be removed at the job site to make sure when they fit these things up that they go back together. And so just a couple other considerations, a lot of, you know, I don't want to rehash what some other guys have said, but, you know, starting early, having the module mentality. We get asked to come in and consult with folks that have already have a 60% design and want to go back and make it modular. It's tough to do, you know. Yeah, I see a lot of areas that you could make a module, but if you haven't done that already, it's hard to go backwards. So, you know, that mentality from the get-go, from the engineering standpoint, is very important. Obviously, front-end planning and ordering long lead items, especially when you're dealing with P91 chrome material and long lead valves and things like that. Having the engineers pre-purchase that ahead of time, you know, is obviously necessary. And now, honestly, even basic procurement items we're having to start catching earlier, making bulk orders earlier, just because, you know, things that used to be off the shelf items are now, you know, it seems like every time I order something these days, hey, it'll be here, you know, 6 to 10 weeks. So that's kind of a new challenge that we're having to navigate right now. And then on top of that, quality requirements we haven't really talked about, but for us, there's been an increased, you know, desire for more information. And so one of the biggest thing we've done recently is kind of embrace technology. We couldn't find anything off the shelf, and so we actually partnered with a design firm that kind of developed a program with us specifically around pipe fabrication and all the welding that we do in the field, that tracks all of our quality needs. It tracks, you know, basically gives us a checklist of items that have to be done on that spool before it leaves. But it keeps up with welder IDs, welder quals, lots for x-rays. I mean, tracking from a management standpoint. And so this program has really allowed us to go kind of the next step and really reduced a lot of effort on the back end from making data packages and things like that. Now it's click of a button, where we used to have 5 people with stacks of paper trying to figure out where that all fits together. So, we can at the click of a button have a data package ready, whether it's by truck or at the end of the project. So embracing technology has really helped us, especially in the quality and tracking. And then finally, lessons learned. Just a couple quick. One is obviously that getting in early. Our most successful projects have been when we've been in on the design phase and really developed a relationship with people. And so it becomes more of a partnership, and you're, all going in the same direction, working together, with a collaborative, effort. So our most successful projects are there. The other thing I wanted to hit on was kind of a misconception that just in talking with engineers and experiences over the years, there seemed to be a misconception on from an engineering standpoint of engineered deliverables. I had a conversation with a guy recently that, he kept asking for like, what module drawings do we need? Like there was an extra step. And, really from my standpoint, we're using erection drawings, equipment location drawings and isometrics. So the same thing you're going to have in the field assembling a stick built is what I'm using in the module yard to assemble. So, that's been unique to have conversations where there's a misconception of, hey, all this extra stuff and extra effort is needed to do as a reason to not do modules. So convincing people that, hey, you need to have the mentality up front to make sure you meet your size limitations, but from a deliverable standpoint, it's really no different than stick building in the field. We're just doing it starting earlier. So that's really the main parts I wanted to cover, and I just wanted to leave time for questions, from the contractor's perspective. So I'm gonna open it up. Absolutely. I think, yeah.
I had a question. It looks like you shrink wrap. Is that some type of preservation?
Yes. So periodically, depending on, there's kind of two reasons we do that. Some of them, if we're sending stuff to the Northeast in the, winter time where there's salt all over the road, we've had requests to do that. And then secondly, a lot of times, sometimes we'll have equipment that's, weather sensitive. And I believe that's what that one was. That we had some heaters in there that were not able to get wet. So a couple of reasons we do that, but we've gotten pretty good at it over the years. So we found a pretty good material that holds up for several months if we have to put them in storage or whatever we need to do. So it seems to hold up going over the road.
Questions? I've got a couple of questions over here. I need to go look at them. Oh, one of the questions was, how big of a core group do you have in the yard and what is the experience and what's the turnover that you're seeing now?
Yeah, so that's a good question. From a company standpoint, we keep about 700, 800 core employees that we have working all over the Southeast. From a fabrication side, we're usually in the 50 to 100. But with that labor pool being in the Southeast, what we're able to do, having the field and the fabrication side, is we're able to share resources. So, we don't ramp up and down a lot. The only time we really ramp up a good bit is if we're doing a bunch of outages. So, we have outage season where we do ramp up for, temporary work. But year round, we keep that 700, 800 group of core employees that if we have a bigger job in the modular yard, we can borrow from the field and vice versa. So it allows us to minimize that turnover by keeping guys working, and also really give us, and like I said, that known workforce that we can pull from and know what we're getting.
There's a couple more here. Let me go ahead. Talking about you said you build modules for, I believe, 30 countries.
I think that's right.
Yeah, 30 countries. And this question was related to transportation between states, permits and restrictions that you run into?
Yeah, so between states, and obviously we're not experts in logistics. So like we were talking about earlier, we hire somebody that is. So Mahmood or Barnhart that has that experience, and they have the relationships with the state DOTs, know the routes. And then, so, you know, we hire a contractor that handles that if the owner's not handling that. But yeah, we may have restrictions in Alabama that we can only travel at night, and we may get to the Mississippi line and they say you can only travel during the day. So that's definitely a challenge, and we have to schedule that in, schedule that time in for transport. All of my experience with the overseas has been, we ship to an export group. So the ones that went to Africa, we handled shipping to an export packer, and then they handled that. We had a little bit of the paperwork side from our scope, but as far as handling actually getting it on a barge and across the water was kind of picked up by the contractor, by the owner's representatives.
And I think the last question I'd received was they were asking about dimensional control and what tools do you use for equipment?
Yeah, so we've done a couple of different things. A lot of times we're using surveying equipment. If we have a certain tie point, obviously we have tie points on the isometric. So we're going to shoot those in with survey equipment. And then we've also used laser scanning. So we've used laser scanning for verifying base plate holes. So anchor bolt holes. So we verify that, hey, we know when it gets there that this is going to sit down on the anchor bolts just like we hope it will. And then we've also used that same technology for tie points. So seem to be using laser scanning more and more. We've got a contractor local that will come out and do that. It's not extremely time consuming. So
any issues when you get to the field with how's that work?
Very few. We have very few issues. A lot of that goes into any connection that we can make, in the module yard, we're going to go ahead and make. So those interconnecting points from module to module, we've already checked and locked in and have extreme confidence, that those are going to fit back up in the field. And we feel good enough that, once we get those things, at the tie point and verify it with, by shooting it in or laser scanning, we have very few issues once that thing's got to the site.
Any other questions for Robert? Okay. Appreciate your time, Robert.
Absolutely.
Thank you.
Thank you.
So our next presentation is John Mullion. He is from Raceline Associates, and he's going to give us a presentation on industrial manufacturing, owners, modularization needs, and competitiveness.
All right, so again, John DeMolin with Raceline. We're based out of St. Louis. And before I jump into my presentation, it's interesting. Bill and I were talking prior to lunch, and in conversations yesterday and this morning, you have people across a wide variety of industries, whether it's pharmaceutical, oil and gas, chemical, petrochemical. Bill, this time we even had a conversation about data centers, and there's one common goal, and it's how do we use offsite construction to improve our products as it relates to cost, schedule, safety, quality. And you're going to hear a little bit of the same here from me, but I did take notes. I was going to share some of these things that I thought were rather interesting or intriguing, and hopefully I'm sure you all took some notes too. Raceline, we've been in the modular business for 31 years, and this isn't new to us, but it's nice to see that, one thing that was said is know what you're going to build. Kind of makes sense, doesn't it? Keep changes to a minimum. That's huge. Decisions must be made much, much, much earlier. 3 times. I wrote it down right there. 3 times. Engage operations and maintenance. That's huge. If you can get those people involved, not only in the fabrication side, but if you can actually get them involved further upstream in the engineering, it's gonna benefit your project greatly. Fit for purpose. The perfect storm. This was one I really liked, de-risking the project. That's huge when you move work from the field to a controlled shop environment. Predictability, owner-driven process. This was said yesterday, you need corporate sponsorship from the top down. Force design earlier, we said that, being redundant now. Cost certainty, commitment. Once you decide to go modular or stick built, stay committed to it. Don't try to change midstream. No one wants to pay for engineering twice. Own it together. Teamwork, partnerships. Begin with the end in mind. And then what you're going to see me talk a little bit about is standardization. Okay. So we have a little bit of a unique business model at Raceline. We're engineering firm, started off as an engineering firm, now have fabrication capabilities, as well as we will follow those modules to site and do the installation. As I said, we're based in St. Louis. We have 10 offices or manufacturing facilities globally. We've done work in more than 60 countries on 6 continents. And for the first 20 years, we designed and fabricated everything in St. Louis and shipped it across the world. And about 80% of our business at that time was international. So we listened to our owners, and obviously shipping cost plays a role in their projects. And then in 2010, we opened up the Shanghai operations. And sometimes it's better to be a little lucky than good. In 2019, we opened up operations, actually acquired a construction and fabrication firm in Poland. And then January of 2020, we opened up operations in Brazil. So we all know what happened in February, right? Or was it March? March 17th, we basically shut the country down. There's no way we could have executed our projects globally if we didn't have regional fabrication. You've heard this before today. You always like to showcase the larger modules. For us being in St. Louis, you're landlocked. This is about as big as we're going to get. And we try to do as much as we can do in-house. And this was for a refinery in the Midwest. They had a rather bad experience with shipping modules up the Mississippi River years prior to this, where Victoria, it was a 500-year flood that hit the St. Louis area. And they had modules stuck on barges below St. Louis because they couldn't get them under bridges. Okay. And here you're looking at the last pipe module that's being set, but what you see in our shop is in the background there. There were over 40 modules as part of that project. So again, just to give you the idea, the footprint that we can do over the road, and this actually went down to Port Arthur, Texas from St. Louis. So now I'm gonna actually take a little bit of different approach from what you've heard. I'm gonna go the other direction. Raceline, for 30 years, we've been building projects in the aluminum can beverage business, and we'll use this 8 foot by 40 foot by 3 foot bar joist type system for the process systems that we're building. We'll integrate it with piping, electrical. We'll completely pre-assemble it in our facilities, even turn the lights on, do your factory checkout, put it in sea containers, unload it at site, no heavy cranes required. And in about 12-month time, 250 containers later, this container manufacturer is producing 1 billion cans per year. So now we tried looking at, and you've heard this previously. Obviously, we want to improve safety, cost, schedule, quality. I don't care what owner you're talking to, they're always going to bring these 4 issues to the forefront. And we certainly believe you can impact these 4 positively without having to give up or sacrifice any one of them. Then there's, of course, manpower availability, constructability, productivity, and then risk. So we believe that you can influence safety very early on in the design, and you can prevent incidents from happening by the way you design your systems. And then you can also reduce the project and industry safety incidents. And if you're designing that way, you can reduce variables equate to reduce risk. Here's an instance where the insulator is insulating the pipe using that lightweight bar joist system. And it's going to be installed by the iron workers 60 feet up in the air on top of a 1 million gallon fermentation tank. You can see the date stamp there, 2008, right? So it's not something that we just started doing yesterday. You'll also notice that the 2 tanks there are still under construction. When they stick built these, they couldn't even get in to that area to do the piping up top of the fermentators until it was completely built out. But because of the approach we came up with directly with the owner, they were able to go ahead and do that installation as they were sequencing the build out of those tanks. You also see the iron workers are using the module that they just set previously to set the next module, and they're tied off to it. So from a safety perspective, there's things that if you're designing it into your systems, that will definitely impact your safety numbers on your project. Cost certainty. Okay, so whether it's stick built or all-site construction, you're going to have engineering costs. Certainly could be a little more on the modular side. You're going to get started earlier, and they're going to stay in the project longer because you do have, you also might have a slightly increased cost of materials for shipping purposes, right? Than if you were to stick build it. And then of course you have the module fabrication piece. Then you'll have the construction because you've moved that, some of that construction from the field to the shop. Your construction labor will go down. Your indirects will go down as well because you're not going to be at site as long. And then you have your savings. And we say anywhere there, if it costs the same, or we've demonstrated up to as much as 30% savings on the portion of the job that is modularized, not the entire job, right? Got to be clear on that. So when you look at what does that time savings do for the owner? Okay, so it's the money value of time. So you have your start, you have your end, and you have this piece in the middle, which relates to schedule. We're going to talk about this here a little bit as well. You're going to have your planning stage. You're allowed to compress your engineering, your procurement, and your construction. They'll overlap one another. You'll have your civil work in a modular portion of it. You're able to decouple the process from the site work and get started on it earlier. And that is ultimately going to impact your construction schedule. So there's your time savings. So I mentioned that we go all over the world and we build aluminum beverage can facilities. A line in an aluminum beverage can facility will produce about 1 billion cans per year. At roughly 11 cents a can, so you do the math, it's $110 million in revenue a year. It's a little over 9 million a month, a little over 2 million a week, $300,000 a day. Every day you can shave out of that schedule is days they can be generating revenue. And in that industry, we've taken it from a 24-month schedule to a 12-month schedule by implementing a modular approach. This is a job site that's actually here in the States. And one thing you'll notice there is that the building is still under construction. It's not completely built out. And we're coming in behind it with the process line.
we've got a roof over our head. We're going to start putting in the system. Then you talk about quality, and we've heard this quite a bit. If you're working on the shop floor, you're not up on scaffolding, you're not out in the elements, whether you're welding, flanging, using a Victolic system, whether it's your electrical, you're going to get a better product. Manpower. What is the biggest unknown on your project? It's not your materials, it's not your equipment. Those are fixed costs. Your biggest unknown, of course, is your labor. So now, just like Robert stated, where'd Robert go? There he is. Why not put that in a shop where you know it's a known entity or a known resource pool, and you can control it. Constructability. You know, constructability begins very early in the process, in your design phases. And when you look at this particular process, and if your process allows for it, everything's being supported off the floor. Nothing is being hung from the ceiling. The conveyance, the piping, the electrical, all being, you know, floor mounted systems. Here's just another picture that what this allows the owner is to have a fairly basic pre-engineered building without having to have a beefy structure, because they're not utilizing it to support the steel or the piping systems. Okay, so there's cost savings right out of the gate on your building when you work with your pre-engineered builders. And then again, are you going to use a welded system, a flange system, a Victolic roof system? A lot of times the process will determine what you're going to use, but if you can utilize a Vic roof system, you know, your throughput in the shop, your throughput, or you know, the schedule you can make up in the field, it goes a lot faster if you got a 10-inch or a 6-inch, 8-inch weld versus a Victolic system. So that's something we certainly look at when the process allows it. So here's Raceline has a sister company called Raceline Alternative Energy. We do a lot of work in the biogas arena, and you can see not a large facility, right? But we found a use for that pipe bridge, if you will, in another application outside of the beverage container industry. And then you have some electrical, you know, e-houses and what have you there as well, some gen sets. And the biogas system itself is a series of skids. Productivity, it's, you know, I don't know what more I can say than what we've already discussed. When you're in a controlled shop environment, you guys have their tools there. It's pretty easy to know that they're going to be more efficient, increase their throughput, be more productive. And then risk. What was it? De-risk your project. I love that. You're taking your biggest wild card in labor and you're shrinking the risk that is associated with it. Also, you can take it a step further from an owner's perspective. And if your construction process is shortened at site, things like builder's risk insurance and things of that nature, there's cost savings there. How am I doing on time, Bill? Okay. All right, so challenges. We've kind of been through this. Lack of available skilled craft labor. We're also seeing it on the professional services side. Mechanical engineers, structural engineers, chemical engineers, designers, they're in high demand, very high demand. One thing we're doing on the skilled craft labor side is we're going into area high schools and we're doing internships with the professional services side. This year we had 25 internships in St. Louis. Of those, there's five young men and women that are graduating this December that are coming to work for us. We're developing our minor league system, if you will, right? So I think it's important that we're pushing kids to go to college, and not everybody's meant to go to college.
So the trades, I would encourage all of us to, work closely with your local trades, the trade schools, what have you. I don't think we need to talk about that. So yeah, we're just, one thing you notice, if you look in the background there, on any of these photos I've shared with you, there's not hundreds of people on these sites, right? It's a small crew. So you're reducing the amount of resources that you actually need as well at site. All right, I think we've heard this a number of times as well. Define your build strategy in the conceptual stage. Dwight Eisenhower, plans are nothing, planning is everything. Now, what he means by that is he doesn't mean don't have a plan. What he means is develop your plan and you got to keep developing it because it's ever changing. So that's key. Engineering and design must be executed earlier in the project. That's kind of been a theme up here from the roundtables. This was a study done in 1986. Our CEO, Rudy Raceline, participated in it with Stanford. I think you've all seen a variation of this at some point. But basically what it's saying is you have the ability to influence the decisions of your project earlier and the cost of your project earlier. The earlier you make those decisions, the less expensive it is to do that. The further you wait in your project, you can change it, it's just gonna increase. And again, maybe a little dated, but Frank Lloyd Wright said you can use an eraser on the drafting table or a sledgehammer at the construction site. We kind of have a saying, it costs you $10 to change, or it costs you $1 to change it in the model, $10 to change it in the fab shop, $100 to change it at site. And this has been mentioned, but it really hasn't been focused on from an owner's perspective. It does force you to, drive decisions earlier in your project and have the expenditures of your capital outlay, because that equipment, materials are going to the fabricator, not the site. You're building it earlier in the process. So that is something that you need to think about when you're going to go with an off-site construction approach. And then there's, I hear this often, well, oh my gosh, you have to use more steel when you're going to go with a modular approach. And this wasn't our design actually, but all the red steel there was just for shipping purposes. It's got the site, it got taken out and discarded. Less than ideal, but what you don't know about this project is we had all these modules fabricated, built, and staged in our yard while they were still going to get the permitting. They were supposed to get the permitting in October. October came and went. November came and went. December, January, finally in February, they got their permit. And we were ready. As soon as that concrete was poured, we were shipping modules. And this is a project that you go all the way back to one of the first slides I shared with you, where they were setting the last pipe rack module. There's barely any pipe on it, but they had a tremendous amount of steel. So we worked with this owner. It was a chemical plant outside the St. Louis area. And we removed 80 tons of steel from the project, about a $500,000 cost savings to go with a lightweight bar joist pipe rack system. And this was a project that we brought their maintenance people from the plant to our facility and showed them examples. And they were like, you know what, this isn't going to work, but maybe if we just gave it not 3 feet, but give it 3.5 feet, so we can get somebody in there when we need to maintain it. So again, it's a standard product, which is kind of what we try to do, is make it more like a manufacturing process than a fabrication process, and use those lean principles and 5S's and things of that nature in order to do so. This is a video, if it will play. It's that same plant that I just shared with you. And it's an existing facility, so a brownfield, where they're lifting what I would determine a more traditional pipe rack in an area that's very congested. And without using a modular approach, this would have been a very difficult challenge and schedule impact to their project. So it went very successfully without a hitch. The iron workers that did that, they're in the St. Louis area. We didn't install it. It was a union job site, but it was, they did a phenomenal job. And then the last, there's many challenges, but the last one I'm going to speak to is, you're limited to the size of the roadways that you have, the avenue to the plant you're going to. So that is definitely something to consider when you're doing your modules. This is my last slide, and this is a quote that one of our clients made about a year ago in their third quarter earnings call. And what he said was, Wall Street stock analysts, have specifically mentioned our company's ability to execute new capital projects faster and more cost effectively than the rest of the industry, as what sets us apart and positions us to capture the lion's share of the market growth. So here you have a Fortune 500 company, they're about 250, that Wall Street is looking at how they're executing their construction projects to put a valuation on their share price. It's huge. So if you don't think that we impact our company's overall health, we need to rethink that, because we certainly do. Okay, that's all I have, Bill.
Got any questions for John? Good presentation. Do have one question, John.
Sure.
Let me go back and read what it was. It's how do you acquire labor internationally? And I think this was related to, do you take your people? You send a lot of these factories, you build them, box them up and ship them and then assemble them?
We do. We'll do it one or two ways. When we acquired the company out of Poland, they were a construction company. They have road warriors, they're travelers, they go. They want to, send us wherever you can send us. But just like if you were doing if you were headquartered in Atlanta and you were doing a project in California, you'd use the local labor pool. And when you go to places like Angola and Nigeria and Russia, you're not always going to the prettiest places. You're not on a beach, beautiful ocean view. You're in some pretty shitty areas, right? And you'll have guys show up to job sites and they won't come back the next day because you gave them a pair of work boots. I mean, it is a challenge. So when we are getting involved in projects in certain areas, we'll try to get as many people as we can that are direct hires or a third-party contractor we worked with before that will travel with their resources. Did that answer your question?
Yeah, I think so.
Okay.
I think it was a question where another company, they build tanks and a computer cut them everything here in the United States. They put all the shell and flooring and everything in a container. They ship the containers there. They hire a local crane, I believe, and they send a small group of people from the United States goes there, knocks these out right back. Wondering if you did a similar process.
It's interesting, Bill, that when over our 31-year history, we began as an engineering company, and listening to our clients, they we wanted to control the fabrication, so we started our first fab shop. And then we were hearing from our clients that, hey, you're telling me that we're supposed to be seeing these cost savings at site for the installation, and we're not seeing what you're saying we should be seeing. So our construction group was born. So we had guys that were fabbing it, pre-assembling it, taking it down, then going to site and reinstalling it. Because of the growth of our company, we can't do that anymore. But so we do work with known entities, third-party contractors that travel with us. Yeah, but we are at least going to have people at site to to oversee those installations. Absolutely. It's the best outcome for the client.
John, thanks for the presentation. Curious if you have a strategy similar to Robert's where you're able to share labor from your fab shop in St. Louis to your job sites, or if you're union shop in St. Louis and an open shop outside?
We are a non-union shop. We're just far enough outside of St. Louis proper that we've got 400,000 square feet on the roof where we do pipe fab, electrical, structural coatings. And we're there because we have we're an ESOP, employee-owned company, and our skilled craft labor force is part of that ESOP. So they are not unionized. But we work often with union pipe shops. When we have peaks and we have overflow work, we'll send out pipe fab and they'll send to us and we'll assemble. We're constantly working with other steel fabricators, other pipe fabricators when we're in a peak period. Definitely. We have to meet our clients' schedules.
Sorry, second question.
No,
So
sure.
Through this morning here, and I guess I'm a noob to some of the stuff. I was just struck by some of the cost savings, or what seemed to be a lot of the perceived cost savings or potential cost savings modularization is due to offshoring of the labor to build these modules, right? And the one slide that I think it was Michael shared was, $125 an hour of labor compared to $12 an hour of labor to build it in China, I think it was. And, so I noticed you have a China shop and a Brazil shop. I mean, is it similar strategy for you, or was it really about just regional and shipping and that side of it?
It is 100% about regionalizing our fabrication. We are committed to U.S. engineering, U.S. labor. And like I said, for the first 20 years, we took pride in the fact that we shipped that overseas as opposed to having it come back this way. So, and we maybe a little ahead of the game from a modular approach, but we had clients that they were U.S. clients that we just kind of rode their coattails to their international project sites. And our CEO at the time, he wanted our people to go there and get home. No one wants to be away from their family. There was a conversation around that yesterday. I think it was that, you're away from your family, productivity does what? For most people, it goes down. Maybe for others, it goes up. So, all right.
So I was going to say one thing to your point on the cost. We talk about in the U.S. and China, for example. I think one of their examples. But my previous employer, we built a project. We had a project in just outside New York City. Actually, it was in Linden, New Jersey, in a refinery there. And when we looked at the labor rate in Linden, New Jersey, we modularized in Indianapolis with truck shippable modules and shipped them there. We had a significant savings there. So from a cost standpoint, but the other big thing with when you go from a site to a controlled environment fab shop, your productivity at least doubles. We
had a refinery client that told us that if you looked at the labor that they would get out of a fab shop when they moved it off site versus what it was on site, that it was cut well over half. And it's not because they don't have a good work ethic, right? It's they're on hold, they're waiting for a fire watch. There's just all kinds of things that take place at site.
Even on a greenfield, you're seeing that, but then when you get into an operating facility,
that's
now
absolutely.
It's just completely the equation completely changes. We got a question from Robert.
Just a quick comment on the labor rate. So that I didn't mention is we're uniquely in Alabama, but a union contractor. So I mean they're almost non-existent. So in one aspect that presents challenges, when we're competing against non-union in certain areas. But we've done work recently in Ohio and New York where we've sent modules up there. Well, I'm even within the states, I'm cutting their labor rate in half basically. So every man hour we spend in the module yard in Alabama, I'm doing union labor, but my labor rate is half of what it is in New York. So you know, even within the states, you can see some of that. Like I said, it has advantages and disadvantages, but we're kind of in a unique spot. Yes, to get every craft person in our shop is union labor, so it's a unique setup. But
so when we get into that productivity equation, there's a lot of factors that you know go into that. But being indoor in a controlled environment is a huge advantage. And also, I think we talked about your core group of people. You have 800 to 900 people. That's huge, especially when you go up. I've been in yards where they didn't have a large core, and then all of a sudden we bring a couple thousand people in, and it was just, you know, the amount of work we had to put into safety and quality control, you know, was significant. Where if you have that core group, you know, they have a lead person that teaches them what the site procedures and stuff are. So it's a huge advantage. Any more questions for Robert or for John? Sorry.
Okay.
I appreciate it, John.
All right. Thank you.
Thank you. I think we're a little bit ahead of schedule now. This is the time we would have the networking break. So why don't we go ahead and just take a 15-minute break? I know we've already lost some people. A lot of you have early flights and have to leave early. So why don't we go ahead and take the 15-minute break, come back in, and we'll continue with the last couple presentations, and hopefully we can get everybody out of here 15 minutes early. Thank you. Okay, guys, I think everybody's had a chance for a break. We'll go ahead and get started. You know, Adam's got a good presentation for us here, and we'll go ahead and get that started. And Adam?
Thanks, Bill. I'm not a podium guy. Usually you'll find me with red coveralls on and work boots, or behind my computer crunching a bunch of numbers for you guys. We're going to talk about modularization, logistics, and transportation from the Mammut perspective, from your heavy lift and transport team side. Maybe. There we go. Okay. Who am I? That's me. Hi. I've been with Mammut since 2007, right after I got out of school at Texas A&M. Any Aggies? No? One, maybe? Yeah, we're far from home. Anyway, I started at Mammut in 2007 in the engineering department. As soon as I started, we were already talking about modules. So I kind of came into the industry and modules is what we did. Specialized cargo, maybe not a module per se, but large dimensional cargo. I always explain to my friends what I did. We move things that are not supposed to move. Most of the time I've been around the Gulf Coast, a lot of time in Port Arthur, Louisiana. Did a couple jobs in New York, and then 2011, I got shipped off to South America. So they had to drag me back. Did not want to come, but I'm here. And then I've been following the projects basically. Still in the engineering department, supporting basically the technical aspects of the whole project realm. And then that's what led me to South Texas with Bill's project, actually GCGV. I actually dragged my whole family down there, which I've been doing for several years now. Now my kids are getting a little bit older and they didn't want to leave South Texas. So we're staying there even though the project's done, and we're still supporting, or I'm still supporting all sorts of Mammut projects around the globe. The last few mega projects I've done, I end up helping out EPCs or owners early on, route studies, early stuff to figure out how to get the project done. And actually the last two I've done, I ended up doing the whole life cycle of the project. We were in Trinidad. I was living in Colombia at the time, went to Trinidad, did the initial route studies, feasibility studies. And yeah, I was first boots on the ground, one of the last ones to leave. And similar story to GCGV, although my boots never left really. I live right down the street. So most of y'all already know what who Mammut is. I got a short video. Let's see if it cues up.
We all come from the world of big, a world in which big objects are moved by even bigger machines packing tremendous power. And while all that power is great, it means nothing without a plan. We believe our business isn't about size, it's about time. Uptime, turnaround time, and time to market. It's about bringing deadlines forward through careful planning, innovative engineering, and safe delivery. Time isn't set in concrete or forged in steel. It's not even all that heavy. And yet for us, it's the biggest thing we move. Mammut. The biggest thing we move is time.
All right. So, like I said, I've been in the module game since I started in this industry, but Mammut's been in it far longer. And then, over the years, everybody's learned a lot, and Mammut's seen a lot of things, and many, many lessons learned. All of the usual items up there that we learn about on a project. And we're going to talk about this. I know Robert mentioned critical success factors. We're going to talk about it from our side of the table, heavy lift and transport side. Let's see. Okay, this is a rough outline of what we're going to talk about. Construction strategy, site-wide services, basically all your on the water, at the MOF situations, foundations, module alignments, scheduling, and everybody's favorite, early involvement. Construction strategy. Okay, it's been touched on several times, but we got to look at the right equipment for the job. Every job is different. I mean, yes, we're repeating the same units over and over again, but something is different. It just might be the location, but it could also be our equipment that we're using. Cranes might be the solution. As our Robert with Mammoth mentioned yesterday, some of those larger machines are going to be harder and harder to schedule. We do still have quite a few of them, but yeah, it's getting difficult. GCGV, as Bill mentioned, most of that was just done with SPMTs. The modules were designed that we could just drive them in with SPMTs. And I think I might need to define SPMTs. I know a lot of us know about it, but I feel that some haven't heard that terminology. SPMTs are self-propelled modular transporters. That's one of our go-to transport units. They are trailers that are modular, and we use them a lot. So, on-site transportation and installation, again, the right equipment for the right job. A module like this, it is lightweight. There are a lot of axle lines of SPMT underneath it, but sometimes you have to look at the whole picture.
They pull it up.
Reconfiguring.
I'm trying to listen to this call real quick too. That's all right.
Yes, it's modular, but it still takes time to break down and reconfigure. So maybe this is not quite ideal for this situation, but we can reuse it for maybe every piece of cargo.
The one
coming
thing
off
I
the
wanted to
same
listen
ship.
to from
So
that conference that's going on now.
Another thing we go into, the technology is evolving. When I first started, there was basically, one model is surely SPMT. Now there's a whole slew of them. Some things that I get into more detailed is specifically what kind of units we need. We have now adjustable width SPMTs. Typically you're looking at 8 foot wide. For some of the other models, they were 10 foot, but most of ours are 8. But now we have adjustable, what we call scissor frames, that maybe you have a whole lot of modules on your site that are varying widths. We can adjust those on the fly. Also, we have a lot of spacers. Maybe you don't need lines for weight, but you still need trailers connected together.
They're such marketers though. They
had a whole lot of toys we have in our inventory. For corporate overheads. Okay. On-site transportation installation method. Civil work.
We're trying to make money, man.
We see basically two main concepts here. Push, meaning straight delivery of a module from receiving at the gates or at your dock straight to foundation.
So you never charge me these rates.
Get it there, push it to site, it's done. That's GCGV. And then the pull method.
Guest wireless.
Yeah, get it to site or your dock, and it goes to
all right, thanks.
You're waiting. We got to look at plot planning. You have to design your site so that modules can get around. We have to get in there. I spent a lot of time with GCGV early on with the EPCs, just going through the intricate details of how modules get to each individual location and what is the sequence that has to happen, which dictated what they had to build first. There was many flights to Japan to go through with those guys exactly what needed to happen. And there's other things to look at. Bridges, if you can work to get some of your utilities underground under the heavy haul road. I mean, you may need that connection early on, but then you're going to obstruct your module path. There's a lot of these kind of things that get popped up. Bill mentioned electric lines that they buried in GCGV. That was done way ahead of time. And if those were in the way, you would have really restricted your module size you could have got in there. Also plot planning, grid lines. You always got to think about how the SPMTs are going to get in, but also how they're going to get out. Sometimes you get so focused on getting your module in, you set it down. Maybe you came in sideways, set it down. Now you can't get out. There's something in front of you, behind you. You're blocked in. Common grid lines help out a lot too. You can, again, use the same trailer combinations over and over again and increase efficiency. All right, site-wide services. So the conventional method that we typically get engaged with is an owner or EPC, hires us to do what we need to do. But you get into these larger job sites, multiple EPCs. Each EPC might be looking at their heavy lift and transport contractor independently. And then you end up with 2 or 3 of us on site, which then you're just clogging your site with equipment.
I got 18 contracts, guys, this year.
Some of the newer models that we've been seeing lately, site-wide services where all the EPCs kind of come together and the pool of our equipment, they share our resources. A little more complicated, but it's definitely more efficient use of people and equipment. And then this was closer to what we ended up with at GCGV. We were actually, for the equipment, we were engaged by the owner, and then the owner had a logistics team that assigned our equipment to the different EPCs. And it ended up being very efficient.
Somebody help you with claims.
Yes, there was a lot of axle lines on site,
There you
but
go.
in the grand scheme of things, it was a good use of equipment.
There you go.
All right, on the water at the MOF. This is actually our office at our headquarters in Holland, and you'll note that it's on a barge. In this case, we built the office offsite, and we brought it to our location there in Schiedam. Why? There's limited access to build a new office there at the quayside. We did this again in the US when we built our new office south of Houston, Rocheron. Why there? Mainly because we could. All right. This was a good one from GCGV. A proper interface management in place at the dock to coordinate your shipments coming in. What are priorities? Oftentimes you had 2 ships with modules from different EPCs arriving within days of each other. Maybe the ship that got there first wasn't really the one that needed to come first. Somebody else needed to make that call so we could be organized and everything ran efficiently. And they did quite a good job with that there at GCGV. Yeah, just avoiding congestion for just-in-time delivery, pushing those modules to site, getting them installed. And yeah, the devil is in the details. A lot of times, the first time we actually get to put eyes on a module is when it shows up on a ship. I always get out there, I do a walk down because there's always some surprise. Luckily for GCGV, these things were transported to the ship. So if something was amiss, we usually heard about it ahead of time. We had 45 days to find out. But sometimes we don't get that luxury. So like this item here, there's something in the way and you don't see it until it gets to your dock. Yeah, these brackets, we didn't know they were going to be there. They might not have been in the drawings that we had. But surprise, now we got to go run to Home Depot or Lowe's or whatever's nearby to get some extra dunnage. And hopefully we can get our SPMTs lower than that so we can get under it without some extra jacking to get it high enough to accommodate the SPMT and some blocking to work around that. So that could cause a delay. Having a shipload of modules with different saddles, locations, different widths. Yeah, that again leads to reconfiguring SPMTs a lot. We try to minimize that as best we can, the reconfiguring part, because it just leads to more time, especially if you're doing the pull model staging and you're using maybe one set of SPMTs to unload every piece of cargo. Yeah, the ship is waiting and it's costing money. You need to get everything off as quick as possible. If we're doing the push model, yeah, we'll usually have enough SPMTs where we can just push everything to site in one go, every module on the ship. So it's not as big as an issue then. Ramps, ran into this one multiple times. A lot of places they'll just use plate to drive from ship to shore, and that works in some cases. But on the Gulf, at least in South Texas, you don't have a whole lot of tide to deal with. Elsewhere in the world, yeah, you get some pretty big tidal ranges. You need some adjustability. Our ramps are set up to handle that to a certain extent. But another part I wanted to mention, well, here we got the actual wedge that gets welded to the ship deck with some hinges on it, and then our ramp hooks into that. We have these in a variety of lengths, 20 foot all the way to, we built some special 120 footers for a certain job once upon a time. Yeah, there's a whole bunch of them. But one thing that to think about is what are the travel paths on the ship? Where do you connect your ramps? Ran into issue on a ship that showed up and the as-builts of the ship were not correct. There were recessed bollards that basically prevented us from using the ramps that we had on site. They were too short. So luckily, GCGV, we're only 3 hours away from our yard and we could get something relatively quickly. But if you were in Colombia or wherever, you won't have that luxury. So make sure everybody is well aware of what the actual layout of the ship is. Grillage beam, sea fasting. Somebody else touched bases on this, but yeah, again, trying to make it standardized so you don't have to do as much removal between modules. If you standardize your layouts, you don't have to fully remove the grillage between offloads. SPMTs just drive between the same grid lines and you're done. Also, the sea fasting itself, I mean, there's some large pipe struts and all sorts of things that get employed to tie these things down for the sea voyage. I mean, some of these crews, they spent 2 or 3 days cutting this sea fasting loose before we could even get on to get under them. But then we had some modules come in where, I don't know how they did it, not my expertise, but they just had some simple clips. They could cut it all away in 3 or 4 hours for a 2,000, 3,000 ton module. So again, if you're trying to get ships in and out quickly, think about that. And yeah, again, with the grillage being the same, trying to get rid of the reconfiguration time. Foundations. Yeah, there's been a lot of projects where modules get to site, foundations aren't ready. Where do you put them? Well, got to find a laydown yard. So you've got to find a laydown yard that probably doesn't exist because nobody was planning for it. And then that leads to the next question, what's the ground good for? Can we even drive it in there? Can we even stage it? Can we set it down? What additional equipment do we have to bring to site just to set this thing down and park it? A lot of things that are being thought of on the fly and you're scratching your head for equipment that may or may not be available. Here's a congested laydown at the top. I don't remember the backstory on this one, but yeah, maybe these modules showed up, weren't ready to go in, and you just end up with a giant parking lot, double, triple parked. Every time you got to handle these things an additional time, yeah, more time reconfiguring trailers. And then there's an example of some of our staging equipment down there on the bottom. We were getting ready for known shipments that we had to park for basically permitting purposes. We can only go from the port to the site a certain time of day. So we get a few ships offloaded and get them parked and get ready to go. The foundation side again, look at how you set these modules down and what height the trailer decks will be. There is a stroke range for every particular model of trailer. Most of ours, the range is 1250 to 1750 mils, but you still need some room to get out and you still need some room to get up and over foundations. So we try to consider that range of when you're actually setting down the module, that the stroke of the trailer is somewhere between 1350 and 1650. That gives us some wiggle room to get in and out. Yeah, for certain cases, we can cut that down. There's some other tricks we can do, but as a general rule of thumb, this will make all of the work go a lot faster. Higher foundation, somebody else mentioned it. Yeah, not a problem. You can raise modules after arrival. One of the things that we did at a GCGV, jacks. Bring it into site, you set up a jacking station, you elevate the whole module with your jacking platform, all your climbing jacks. There's actually a bunch of videos in here. Y'all can watch these later on. But once you get it elevated, you can either reuse your same set of trailers with false works or something installed on the trailer decks to go in and pick the module back up again and then drive it to the foundations. If you look at this module here, there's crane mats on the deck of the trailer just to gain some height once you're to get over the piers. Another way to do it is just pick it up with a crane and set it on false works so the crane can just install it. And the reverse, maybe the module needs to go lower. Not our favorite thing to do, but you can use the jacks again. That's an example of one of our climbing jacks. And we use hardwood blocks. It's amazing the power of these things, but yeah, these jacks, we have them up to 600-ton capacity. And they just one stroke at a time, one layer at a time of wood, we can go up or go down. And we're even able to do a little bit of alignment with them. You'll see the tabs there on the foundation where we can play with how we position the jack in each stroke to get it to go the way we want to. And those guides help it on that last step. But then this also can get rid of your crane. Less equipment to bring to site. And there's two main types of foundations. The foundations that are flush with grade, these are great for getting equipment in. We can drive over them, especially when you have projects where maybe they optimize the steel. So they have different grid lines. First module in, we got to drive over foundations and then you work your way out. One of the risks that is associated with this is now your module legs are longer. So you really have to pay attention getting to site that you're not dragging your legs or your module on the ground. And then you either damage your module or the road or both. And on the other side of it, you have huge foundations. This one, you really are limited to the movement of the SPMTs. There's basically one way into this thing. One way in, one way out. Yeah, they left enough room for us here to make our final adjustments, but this one basically was critical on this shipment. This had to be the first one. There was no choice. On some of these shipments, we had to pass modules just based on layouts on the ship. Luckily, there were some turnoffs where we could get one module past another. But yeah, all of these things are things that we look at when we go and help EPCs and owners do studies in the preliminary phases of a project. Just try to identify, okay, maybe this makes more sense up high, low. There's a whole bunch of things like this, little details that we've learned over the years. Okay, talked a little bit about it already, but module alignments. Yeah, define your sequence. And a lot of that comes back to how your road system is set up on site. South Texas, a lot of things are pretty flat. That's nice. You get some options. You get to some different territory. You have elevation to consider. So you might block yourself off your access road if you don't plan it right. Also, just the looking at all your connection strategy. Maybe you need to plant your first run. That's your basically 0-0 for all your module alignments, and then you work off of that. So maybe you start here, and then you make your first run of connections, the last run of connections, but then does that work with your module routing on site? And again, with the connections and alignments, think about this. We usually see single hookups or double hookups. Single hookups, you just have two pipes come together, flange or welded out. That's great, but that's a lot more fine-tuned work the install crews have to do to get it lined up. Yes, we can get it down to millimeter precision, but it's a lot slower. You go to double hookups, little puck pieces or whatever you want to call them. We don't have to spend as much time setting them down. There's a lot less risk of something not lining up exactly right. And yeah, we can get in and out a lot faster, but it increases all the field welds or connection time. Also, consider that when you're coming in with these, they're not going to be at your true elevation when you're mating them up. They'll be a little bit higher. because we have to come in and set it down. I've seen issues pop up where the pipe connections were designed kind of offset where they cut them. So when you actually came in elevated even a few inches, some of those pipe flanges were clashing with the already installed pipe flanges because they were elevated a little bit. So it became an exercise of, again, a lot of, we'll get to it in a second, became an exercise of a lot of spotters. You got to have spotters. You need a single point of contact. We have our own spotters, but you need spotters up in the air to see all these contact points. Scheduling. This was actually our SPMT schedule for GCGV, and this, yeah, every time we got a shipping report, it changed, and we're trying to forecast exactly how many axle lines we need on site. And I'm not going to go through all the different colors, but we put some of the various old forecasts on there to see how it changed over time. So yeah, more SPMTs. Is it faster to get things done? Yeah, it can be if you have the right coordination. Some questions to ask yourself: what is your overall construction strategy? Are you going to do the pull or the push direct to foundation? That makes a big difference on how many you need. What's the shipment arrival frequency? Do you need to get those ships out of there quickly? Do you need enough SPMTs to cover 2 ships, 3 ships? You got to look at the MOF, the jetty, laydown area, heavy haul road, side access. All of that has to be designed considering not just cargo flow on SPMT, but you also have to get the trailers emptied back. And sometimes we found these modules are getting so big that all of a sudden we wanted to optimize the number of times we close down the highway. So we want to take the empty trailers back at the same time a loaded convoy is going to site, but there's nowhere to pass because, I mean, the modules are hanging off the road. So what do you do there? Yeah, you can build laybys. In some cases, we actually turned the empty SPMTs out onto the highway, drove down the highway a little bit, let modules pass, get the empties back on the road, continue on their way down to the dock. But it's all things to think about. One early thought I had on that one is, you know, if you really had to, you know, when they're empty, they're 8 foot wide, they're long, but you could build a tunnel if you wanted to. Some outside the box stuff. And then this was supposed to be initial plan versus what actuality was. You see this time and time again. As soon as you get to site, everybody gets real excited with what they see. They start thinking about other things they can move with this. Maybe I can build this little stick build item over here where I don't have to deal with working at heights or out of the way of everybody else. And then I'm going to move it over to the actual install site later on. So quickly, we see number of axle lines increasing on projects. These are some cases, I'm not naming names, but I mean, a lot of these you end up getting close to double of what you expected. And yeah, everybody's favorite, what is it? Early involvement. When you start looking at these, all these different projects, it's hard to read on here, but all of these different aspects, when you engage your heavy lift and transport company, even if it's just for input, conceptual phase, we can give input on a lot of different things. Civil design, you know, lay down area, your heavy haul road, module design itself, how the SPMTs can support your cargo based on its overall dimensions, the COG, weights, going into, yeah, logistics, permitting. Each state is different, each country is different. Yeah, construction management, looking at sequencing, strategy, hookups, schedule. I mean, just looking at different methods. Maybe everybody thought cranes were the answer, but well, maybe not. We can jack and slide. We can do a whole number of different things and take cranes out of the equation. So yeah, you'll see our input is quite valuable in a lot of different places. I don't know if we can watch this video. There's a link down there at the bottom. This one talks a little bit about early involvement. Well, I'll let the video speak for itself as one I was involved in.
To successfully complete the build at this remote site, Samsung's primary challenge was getting 50 heavy components delivered in a timely and cost-effective way. So they approached Mammoet. We reviewed the possible delivery routes and immediately discounted two. That involved a tunnel too small for the components or a 3,500-kilometer overland journey, potentially exposing the convoy to additional risks. We knew there had to be a better way. So we dug deeper until we came up with a route that nobody else had considered. It was complex and presented a number of challenges, but it was faster, more secure, and ultimately more cost-effective for our partner. So we combined our logistical expertise and specialist equipment to create a unique solution. We first took delivery of the components in a commercial port in Uruguay before loading them onto hopper barges that would otherwise have traveled north empty and sailed them 3,000 kilometers up the Paranara River, neatly avoiding any trouble we might have encountered overland. At the end of the river journey, we arrived at Port Aguirre on the border of Brazil and Bolivia, a small port town that had never been designed to handle loads of these sizes. We employed our MTC-15 crane, a unique piece of equipment specifically designed to turn any key into a heavy lift terminal, without the need for ground reinforcement ropes. The MTC-15 can be quickly moved and installed in even the most remote locations, unlocking transport and delivery solutions unavailable to other companies. The MTC-15 carefully lifted the large components off the barges and placed them onto hydraulic trailers, ready for the 825-kilometer road trip to the construction site. One of the bridges along the route was neither wide nor strong enough to allow the loads to pass. So we constructed a temporary river bypass to solve the problem, and our transport convoy was able to safely continue its journey. Upon arrival at Bulo Bulo, 3 of our large cranes then lifted the heavy components into place. By combining creative thinking, innovative equipment, carefully planned logistics, and our extensive heavy lifting and transport expertise, we delivered Samsung's vital components in the fastest, safest, and most cost-effective way possible. Mammoet. The biggest thing we move is time.
That one was a really good showcase for early involvement. Everybody looked at it earlier. Yeah, they're looking at the traditional routes and maybe have to size down your cargo quite a bit, multiple pieces, leading to more work on site. But it's one thing that we actually do a lot of all over the world is route studies. What's the biggest envelope that we can get to site? Or maybe you have cargo already in mind. What routes can we get it there? Or sometimes, yeah, it's not possible, but we're willing to take a shot at it. I mean, we do stuff from offloading in the Gulf Coast of Texas all the way up north of Amarillo. I mean, everywhere. Yeah, it takes time, it takes money to run these routes, but a lot of times there's a way. And then we work with all the entities along the way, TxDOT, whatever State Department of Transportation, for permitting, doing bridge analysis. Like they mentioned in that one, that bridge wasn't strong enough, so we just built a bypass. Did one of those in the Dominican Republic with an 800-ton autoclave. We were going only 125 kilometers, but again, bridge was a problem. Built a new bridge, temporary bridge. That's where those 125-foot ramps come into play. We just took them with us when we left. So now we have them as another toy in our toy box. And the whole factory to foundation, you can see the little red man everywhere along the path here. Yeah, we could be involved any step of the way to give our advice, our input. And, you know, some of that work we can actually execute ourselves. But the earlier we can get involved, we might unlock another solution, such as the MTC crane located there that can maybe take a few pieces of the puzzle away, consolidate it. So yeah, the earlier the better. So that's about all I have. A recap, we talked about construction strategy, different site-wide service models, some of the challenges we face on the water and at the MOF, foundations, module alignments, scheduling, and everybody's favorite, early involvement. All right, and this is our new tagline, smarter, safer, stronger. And somewhere in there is me in my normal state with coveralls on. This is in Colombia. And you'll see this in like every MAMU presentation.
All right, thank you, Adam. Do we have any questions for Adam? Anybody have some questions? Okay.
I'd like to get a feel of what the price or what the cost of this would typically look like.
This would be more of a question for Mr. Roost back there.
A typical operation like this for you guys would look like.
In general, what we tell people, look at a TIV project, cost, transportation, 50%, and then you know, if you have really specialized routes for all that cost, maybe you would say plant. That percentage. Budgeting percentage. Am I talking percent?
Yeah, I don't know the people on the other side of the room here. You can talk about the percentage
Yeah,
of the project.
right. I mean, it's hard to say, oh, this costs this much or that costs that much. I mean, GCDV was basically a trailer rental project for us. We rented a ton of Exelines, and based on the schedule of the ships coming in, allocated the trailers as needed to each shipment. As I said earlier, if you have a project in mind and you're thinking about a total investment value, what I learned over the years is that if you take between 1% and 1.5% of your TIV and budget that for your heavy haul, heavy transport, even with some barging in there and stuff, you'll be all right. Not ocean freight. Ocean freight is a separate part of that, but 1% to 1.5% for our services, you're pretty darn accurate.
And you know, Adam showed where you actually build a bridge. The bridge wasn't good enough, you build a bridge. And I look at our project, we had to, you know, relocate high tension lines. We had some high tension lines overhead, we put them underground. We had to build a heavy haul road. We had to
Actually, I had to build a couple of bridges there.
Yeah, yeah. But when we figured that cost into the overall project, it was a no-brainer. I mean, that cost for what we were saving by being able to modularize and move them there, what we were saving on you know, startup and schedule and NPV, it was a no-brainer. It was minimal considering, you know, the savings from the project. Any other questions for Adam here? I noticed, I remember once we did have an issue and I think Presley was continuously, every month we went through the weight balances. Design came as we started building it, you know, we were continuously checking the weight. So every month, was it Presley, you gave it a weight balance report?
A weight control report.
Weight control report.
Yeah, that was a really good thing that y'all implemented on GCGV every month. And y'all were doing it internally, but we got to feed off that information. Just a weight control report where the latest estimates of weight were given with a center of gravity. And there, from the get-go, there was a upper limit, a not to exceed weight, and there was a bounding box for the center of gravity. So we were able to design from our side, we were able to design our transport arrangements to, if the COG moved anywhere in that box, so the weight, as long as it stayed under that, we were good. We didn't have to worry about any last minute surprises or changes. And the same thing for everything that Presley and all the other teams were looking at for shipping, ocean shipping, foundation design, everything. And I think there was only one module that I remember where the COG ended up outside the box. Yeah, shipment 3.
It's not outside, On the boundary.
It was close.
Good answer, good answer.
Yeah.
It's not outside, it's on the boundary.
Yeah.
We're about to ship it. When we weigh it at the yard, it's, the COG results that it's inside that, it's in the
Yeah.
line. So we panic a little bit, so what will happen? So that's the reason why it's good thing that happened in shipment 3 that's very, very light. That's
It was a pipe rack, yeah.
pipe rack. So our shipment of furnace on shipment 7 and 11,
Yeah.
so months after that thing happened. So we have a weight control engineer dedicated specifically just doing the analysis on making sure that the weight is within the COG boundary. So on the early months of the furnace modules, the weight budget exceeded the weight control weight exceeded the weight budget. We have an initial 10,000 short term weight budget, and we exceeded that because of the steel structure concern.
Yep.
Went up to 10,500. So we have this summit, make sure that so correct. We have to control the weight. We have to weigh everything. I mean everything, almost everything. Equipment, the valves, almost everything that we have to weigh, just to make sure that when we weigh it, it's gonna be inside that COG.
Yeah.
When I saw that if it's outside that envelope, that 1 meter by 1 meter, I guess. Sorry.
Yeah, it was something
We're
like
not
that.
be able to transport, but it's the line transportation. Super.
Yeah. So, yeah, you guys were doing your exercises and we were doing our exercises. The weight went up, and yeah, our first reaction was, okay, well, go ahead and throw the existing plans out the door. But there's other options out there. I talked a little bit about the different models of trailers we got now. Most of our axle lines now are good for 40 tons per line, but some of the newer units are good for 48 or 60. Yeah, so for the furnace, we ended up, and it was actually in the grand scheme of things, a pretty minor upgrade we had a lot of units that were capable of the 48 tons per line, but the only thing missing was the tires. Or actually, it wasn't the tires, it was the rims. So yeah, we had to purchase, I think it was around 1,000 rims. And so we had the summer before the big module shipments got there, our guys, we kept them busy and they were changing tires. We built some specialized machines. Yeah, and every one of those wheels, it has 20 nuts on it because they're 2-piece rims. Yeah, it took them all summer long and they knocked it all out. And all of a sudden we're good for 48 tons per line. We got more capacity. Got to look at some other things along the way. What's the road good for? And it turned out that the weight itself, it wasn't so high that we needed the full 48 tons. I think we were running at like 41 or 42, but it was enough for the road. We had the GCGV had their road civil team look at it again, and they were okay with it for that width of cargo. That wasn't taking up the whole road. It was more centered. But the COG and the not to exceed weight, we talked a little bit through the days about fixing engineering early or design early, but that envelope actually gave some outs. We designed our part, and everybody designed their part based on envelope. So there was some wiggle room in there. Things could go up and weight a little bit, and down. COG could move if you added to some piping here, piping there, but there was some contingency. That was one of my favorite things about the project. Everything was, yeah, it was well thought out so that there was outs for everybody. Some scary parts along the way, but we got through it.
Any other questions for Adam? Just one other thing I did want to share, and you kind of mentioned it, when you dealing with all these shipping companies. So when we're doing our layout for the grillage and the C fastening, we have to rely on their drawings. Well, they're hard to get and they're seldom accurate.
Yeah.
So when we first started and we designed the grillage in sizes and located it, when we actually got on the ship, where that support beam was supposed to be per the drawing, it wasn't there. And so we had to do the old tap test to find the steel, find out where the actual beam was. And from that point on, we designed our grillage to where we had a little more flexibility to move it around. That was the lessons learned that we learned earlier with the pipe rack modules. And that was something that kind of saved us a little bit, I believe.
And also all the access hatches, they showed up in strange places too. But one nice thing that y'all were able to do was you were able to contract ships for multiple voyages. So you got it the first time, you knew what you were dealing with for like 11 more trips. And then there were some other ship lines that y'all chartered that they had 4 identical ships that actually are brand new. Those are really nice, and you knew exactly what you were getting. They're brand new, you have better documentation, but they were literal copies. They were standardized.
So that was, we had 8 furnaces to ship that were basically identical. Yeah, so we used the ship and didn't remove the grillage. We left the grillage on when it came back and was able to, with minor adjustments, load the other ones on. So that saved us. And if you think about the grillage, that's all these big steel structures that we're welding on top of the ship and then welding the module down to it to hold it. And that was a lot of work, but just being able to, there, it goes back into that pre-planning. Any more questions for Adam? Okay. If not, thank you, Adam.
Yep. Thank you all.
So we're a little bit ahead of schedule, but we'll go ahead if no one has any issues. I think that the next thing we had was a panel. It's a modularization opportunity growth driven by today's economy. And I think Robert and John and Adam also on this panel. So if you want, we'll go ahead and get started. We actually, the co-chair Badar was supposed to lead this panel, but he wasn't feeling good, so he spent 2 days in his room here at the hotel and left today. So we said, if you're not feeling good, please stay in your room. See. So the first question, and these questions we have, members of CURT and CII have submitted these to us. These are the questions they ask us, so that's why we brought them in and try to get the panel to give us some insight on it, because these came from the panel or from the body. This breakout panel was designed to speak about growth opportunities in today's economy. And do you see today's and tomorrow's economies representing growth opportunities? And if so, how do we realize them? I think we've kind of touched on this a lot today, but I think this was more from, we've talked a lot about process modules, and I think this is more in the other side of the house. That's where they're trying to get to. You want to start it off, John, or where's your growth opportunities?
If you're speaking in regards to what industries we see where there's growth.
Yeah.
Well, for us, it's pretty easy. It's we do a lot in the packaging industry, and there's a shift right now away from plastics, single-use plastics, to aluminum. And the aluminum industry has done, like the aluminum beverage can industry has done a very good job with promoting recyclability, sustainability. And you go out here to the bar and you're not going to get a plastic straw, you're going to get a paper straw. So so for us in the packaging industry that we're in with regards to the aluminum beverage can, globally, they want to bring 100 billion cans to market by 2025. And that actually started in 2020. So it's the clock's ticking on that. So you may have heard me say earlier that a can line will produce 1 billion cans, one can line, just over. So that's a lot of cans that are going to be produced, or a lot of lines that are going to be built out across the globe. The other industry we do quite a bit of work in is renewables, with renewable natural gas. And we work with Smithfield Food and some of the other hog producers. And we've been able to help them solve some challenges they've had from an environmental and regulatory situation, where when you have 1 million head of hog in a concentrated area, you can imagine you have odor. You have, as part of their waste management system, they spread their manure across thousands of acres that they own. So when it rains, they have
run off into the streams and affects the marine life and so forth. So we worked with a number of those hog producers, and we've gone in and we've covered their lagoons, which are roughly about 4 acres. So we eliminate the odor overnight. And then we take the methane that comes off of the ponds, the retention ponds, and we clean it up and we inject it back into the natural gas pipeline. So for us, we see those two markets, whether it's renewable energy. I mean, you heard about solar and the wind farms, I should say. So I think that's really going to be a directive kind of spearheaded by our government too, with regards to renewables, and then any products that are coming to market where there's a sustainability or recyclability format. So.
Yeah, I mean, from our side, we see requests and inquiries for everything under the sun. Right now, it's a lot of renewables, and yeah, a lot of these turbines, they get built overseas and they come in, but there's a lot of other work behind that. The components will be built here stateside or somewhere else that need to support these turbines out at sea or wherever they're going to be. So there's that market. I mean, we get into stadium roofs, bridge moves, not necessarily module work, but it's over-dimensional work, stuff that, you know, bits and pieces could be considered modules. But yeah, there's a lot of interesting things out there. And from our side, there's a lot of big mention. That's all the cool stuff. But there's a lot of small things that are equally as cool. I mean, shipping industry, just like your car, they break down. We'll do camshaft swaps at sea. And they come to port, we get our guys on our equipment while we're going from port to port. We'll pull camshaft, get it to the side of the ship, stop, next port, get the new one in. And while you're on the way to the next port, reinstall it. I mean, there's all sorts of random little things like that that are out there.
Yeah, from Maccabee's standpoint, we talked a little bit about, you know, some potential opportunities in commercial work. So, you know, hospitals and, office buildings and things like that. Maccabee's notoriously been we're not we don't do commercial work for whatever reason. So, we stick to what we know, but here recently, you know, just with some younger guys reaching out and started, particularly on the field side, started doing some commercial work that we just kind of happened upon and have been successful with it. So I think there's probably opportunities there maybe to start trying to see where we can modularize some of that as well.
Okay, thank you. Any questions about anybody want to give any feedback on that question, or, you know, what I'd have to ask the audience here, you know, what do you see coming that you would want to share with us to help us get ready to try to prepare, give you better direction on it? So anybody want to address that right now, or? Okay. Mm-hmm.
I think that's just another perspective, social infrastructure, civil infrastructures.
Infrastructure developments, where I think I do believe, you know, sustainability is a big factor here, and we're hearing a lot around that, and you know, what people can do to and actually modularize that. I think the biggest thing I've heard recently was the mini and micro nuclear power generation. And that's pretty interesting, and we'll try to get more into that and find more information for next year on that. Oh.
I'll speak. I'm a loudspeaker. Okay. We've identified the State Department, and we do embassies around the world, and we've identified about $50 billion worth of annual appropriation, 2.5 billion.
Mm-hmm.
Another 20, 25 years, and I'd like to see an opportunity. Not everything, but just FYI for all of you,
And this type of work, you're looking at all over the world, some remote areas and I'm sure from a security standpoint, you want to be able to manage that and materials and stuff. So this is a matter of identifying that, identifying the location, identifying transportation and for I mean, embassy type buildings, compounds. Mhm.
So it's challenging to get laid on there. It's challenging to get materials. It's challenging to get out there and do some other work. So
Mhm.
we're trying to see how a lot of these are most
So to your point, I've heard similar situations there, you know, people question me, the data centers are a big thing right now. We're getting all kind of comments and questions submitted to us on those and they build those in urban areas. So here again, you know, they're trying not to disturb the local community. They want to be able to bring things in. So how do you bring them in and build them faster? So that's the other thing. They don't appear to be as much on, you know, the cost side is speed to markets where, of course, we always start schedule driven, then cost comes in, right? Go ahead, Robert.
You said bridges, right? So you saw the floating bridge. I do think on highway bridges, technology with float. We try with the bridge out and all one out and a new one in one night.
Yeah.
Other thing, you talk about micronuclear, great future for it. I strongly believe in that. I looked into it for a while. I also think that if we ever try to think about building new nuclear plants, the execution strategy for that building, I think that lends itself as well for modular construction offsite. Control your quality control processes a lot better. You get better control over your labor. Pieces to site and install. I think that there's definitely modularization.
Mm-hmm. Yeah. Yeah, great.
You know, from an point standpoint, my other hat was not executing product, but the product itself. So in modularization, you know, I think I've recently formed a new department of what we talk about indices for wall systems, our glasses and strong steels within our armor and our Humvees out in the desert. So now you combine those things and you think of a bridge, and you do that with composites, that way it's a fraction of what steel does. Then you use helicopters to bring in full size bridges and maybe smaller nature than what we saw video of, but still, so we think that infrastructure has, but in our world, it's because obviously we want to sell an alternative.
Yeah.
It does open up a whole lot of other possibilities.
Yeah. So new composite type materials, a lot stronger, a lot lighter. Use of that technology is moving ahead too, right?
Think of corrosion.
Corrosion resistance. Yeah.
One of our fastest growth we just bought into this a couple of years ago, but we're making composites rebar now. We can't make them. We make it, it's on a truck. Seeing people carrying around bundles of composite rebar compared to one stick of rebar to waste so there's things like that alternative materials can also open up the space for modernization.
Yeah. Good. Let's see what the next question is here. Okay, many owners are driving to offshore modularization. What should be the key considerations in making this decision? And in your experience, are the owners realizing the expected benefits for offshore modularization?
Well, I think the simple answer is yes, they are. It's I hate to see it. I hate to see that work overseas, but I don't know that here in the States that we're equipped to build some of these modules that we're seeing come in when you start talking about these large mega modules. I would say that if it's outside the mega module realm, then yeah, you've got plenty of options here in the States. And I think we can, as a country, can be competitive with what's going on overseas, without a doubt.
Adam, if you want to, anything?
Yeah, on that same token, in GCGV, yeah, we talked about the main fab yards being overseas. Obviously, there was a benefit, but there were some items that did not come from overseas. We actually ran barge trips out of Natchez, Mississippi, out of a fabricator yard there. Yeah, Mammoth handled that whole thing, factory to foundation. Actually, in that case, we did not do the foundation, but we got it from factory to next to the foundation. So yeah, there are options for homegrown stuff happening as well. But I mean, we see in our line of work, we see requests from everywhere, like I mentioned before. And you're the owner, so.
I second, that, you hate to see them go overseas, but, I also agree that, we're definitely not set up to build, the mega modules. We have limitations, with sizing. So, hopefully you see a mix.
Okay. Let's see what the next question is here. Yes, sir. Oh, sorry. Right. Yeah, we're seeing, I don't know, maybe it's driven by survival, but people, becoming a lot more productive using, AWP processes and becoming a lot more efficient, a lot more innovation in the type of tools and how they do things. So.
Absolutely. And, one thing that we're beginning to do is introduce robotics into our fabrication, and, robotics, they can go 24/7. And so that helps us be competitive in a global marketplace, without a doubt.
And I would like to second that comment. I mean, 15 years ago, I was part of the construction of several platforms in the Houston area, shipping to the Gulf of Mexico for Mexican clients. I mean, it's possible, it's economical. Right now, it's even more pressing to be economical in order to compete with Europe in that particular area, making our projects more efficient, cost-driven, and of course, scalable. I mean, we have the capabilities. We need to be able to compete. And I believe that's what we need to challenge ourselves. How to compete in a more economic environment with others on the globe.
Yes. So the other side of that, we're seeing it as, other areas develop, labor rates go up with it. So that balance becomes even closer. So anyway, in your experience, is there a right level of modularization for a given project? If so, how do you find that right balance?
Well, I think that, obviously every job is unique, but I'm obviously a believer in modules, and I don't think you can modularize too much as long as it makes sense. But I do think it takes a, upfront approach and, make sure we're doing things that make sense. If you're shipping air, it's probably not going to make sense. But if you have dense areas of equipment, piping, electrical work, anywhere where you can really take a significant amount of man hours off the site, it makes a lot of sense.
Yeah, I agree with that. It's, I think oftentimes the best system is a hybrid system. But someone alluded or made the comment earlier that oftentimes after a project is completed, there's always hindsight. I wish we could have modularized more. Sometimes you're limited upfront, limited based on a fab shop availability, or maybe just in your process when you do your analysis up front, you don't identify an area that would lend itself to a modular approach. But after the fact, you're like, the light bulb kind of goes off. So yeah, I think ultimately the best system is a hybrid system. The last thing you want to do is modularize something just for the fact to say, hey, look what we modularized. You got a piece of equipment and a module, and you got 2 sticks of pipe on it. It was like, well, we could have sent that right to site. What do we do that for? And that doesn't give modularization or off-site construction a good name when you start modularizing it just for the sake of saying that you built a module in a fab shop.
Yeah, it all, to figure out how much to do, it all comes back to the early involvement everybody talked about today. Yeah, do your studies, do your homework, pick your site. Yeah, base your site selection on what you can get there and what you want to get there. What is your cargo? I mean, all of y'all come from different industries, different backgrounds. Some people need the mega module. Some people need smaller stuff. Yeah, do your homework.
So one of the things, when we started GCGV, we looked at 44 sites, and a lot of the initial review was to Google. We got on a Google map, we looked at the sites, and and we ranked them, based on what we seen on a Google map, and then we tried to narrow things down. And when we went to the site, when you actually put your feet and got on the ground level, it was completely different from what we seen, and that was something that realization we had to come to was understanding that site and what we thought we could do from a Google map view, and when we got there and looked at all the obstructions and stuff, it changed the whole dynamics. So
yeah, you can do a lot with a desktop routes study like that or survey. But yeah, put boots on the ground.
Yeah, that was an eye opener for me. But anyway, let's go to the next question there. Right level, when I think about our project from a right level of modularization, we thought based on our early information, and it was, we had our team in there, the owner's team at this point. This is very early, but when we looked at all those Google Maps, we thought, well, we could do 50% modularization. Turned out we was able to do a lot more when we got more people involved that knew, brought more ideas to the table, and that was very helpful. Let me move to the next question here. Was that okay? I guess that was the last question that we had. And like I say, these questions came from the body. Is there any questions that you may have here of the panel? Anything?
I think you got maybe touched on a couple times, but there's been many instances where this happened to us when we were in Columbia. The fab yard was building the first pipe rack modules, and they were running behind schedule, and they just made that decision, ship them to site. And then they get there to site, and it's just, there was like 2 pieces of pipe and a pipe rack, and it needed 50 or something. Yeah, it just had a whole lot of extra work there to an already congested job site that had a really unorganized approach to everything. They didn't need that there. There's a lot of that across the industry. And I think some of the earlier module jobs that we got involved in, there was quite some difficulty in making the final module hookups. You guys touched on that. You build them connected and then you chop them. That seems to be the better approach. When some of those first ones came out, they built them to optimize shop space versus how they're actually laid out in real life, and they showed up to site. Yeah, it wasn't good. There was a lot of adjustments on the fly.
Yeah, I think several keys. One is that if you're gonna go with a modular approach, you've heard it today, you've got to make that decision early on, because we've gotten involved in projects where the original approach was a stick built and they tried to modularize from a stick built, and that never goes well. So that's one takeaway. The other is one thing we do is not just the fabrication side of it, but really the full pre-assembly. I think you all do the same. If you try to take shortcuts and you try to just do the modules individually and then get them out into the field, you're bound to have some misalignment. So the more you can fully pre-assemble in a fab shop. Now that doesn't mean you have to erect the entire process. You can do the at grade modules, the modules above it, and then take the at grade modules out and then do the next ones. But make sure that you're to whatever extent, piping, electrical, like I said earlier, we'll even turn the lights on. So it's important when you do your functional checkout, the FAT, that that's where you kind of catch your own fly balls, right? You design it, you check it, double check it in the fab shop, and when it goes to the field, you're I don't want to say you're guaranteed success, but your likelihood of success is much greater.
Yeah, I've got kind of a unique one, more from a front end than the back end, and this only happened once in my career. But we had a good front end approach on a module job. It was going right in our backyard in Tuscaloosa. Had transportation involved, had a plan, and then engineering took too long, and they didn't get a major piece of equipment that was going to be here on site. But I mean, schedule was very important. That's why we went the modular approach, but it was going to take some effort to move it and power lines to move. But they waited so long, and it pushed the front end piece back so far that they already had foundations done. And so, we really didn't have an argument to make it modular. So it ended up getting stick built because we really weren't compressing their schedule anymore. So, it just shows how important that, front end, the engineering piece and the procurement side, to really make it make sense.
Yeah, we kind of joke at times that, you have to shoot the process engineer, because if you allow them, they're never going to finish it. We build modules where the last rev of the drawings they're issuing to us as we're shipping them down the road. That's not a recipe for success. So if you can get the process frozen, you're going to put yourself in a much better position. Otherwise, it makes for a very challenging project when you do that, and it's headaches that with pre-planning you can't avoid. They're absolutely avoidable, but sometimes we don't like to make it easy on ourselves.
Also, don't underestimate Mother Nature. A lot of facilities are on water, Gulf Coast, hurricanes, but also somebody touched base earlier, the rivers. When you get a flood on the Mississippi, that shuts down a lot of operations on the levees. Each district has its own range of when we can operate on the levees and when we can cross. Keep that in mind. Somebody mentioned getting a bunch of cargo stuck on barges for months and months and months waiting for the river to go down. I've had that happen before too. Maybe you get lucky and find some place to offload them in a different spot, come back later, but it's additional cost. And actually that video in Bolivia, that bridge, it actually got washed away twice. So that was not the video. But yeah, don't underestimate Mother Nature. And I think even on GCGV, we had there were some extra containers on one of the ships. Actually, this is the one that made the long route around Africa. Yeah, I think they were at sea for like 3 days, and they encountered some rogue waves, and I think they lost a few containers over the side, and they had to make an emergency stop in Singapore and discharge a bunch. And there were some containers that showed up. I mean, I've never seen damage like that before. I mean, you had 3-foot indentations on the side of a container. Yeah. Don't underestimate Mother Nature.
So that was another thing. A lot of planning work went into the timing of when we could
Yeah.
cross.
Yeah, there was a lot of that. And that's why there was a big break in the deliveries to sites during hurricane season, basically. Yeah, there was a few, but most of the shipments came when there was, not major weather events like that typically happening at job site.
Mhm. Yeah, I think your point's right. You know, there's lessons learned that we still need to share that because we need to know why. Presley, you? Oh.
Since we're doing we're shipping the modules on time and before distribution, we knew back in the early stages, we had some preservation. It's a learning process. We should ship 70 modules in total, but when we did the shipment one and it arrived at the site, there was some rusting, there was some corrosion, and then some shipment, one, I think 2 and 4 inches pipe fell apart when it was on the sea. So luckily for some mentioned the biggest shipment that we ship it at the latter part of the project. So we have gathered lots of lessons learned already for the shipment. So we're able to implement that in the bigger volumes. But I think that's an eye opener for us is the preservation, especially if we're doing the Trans-Pacific shipment from China. It's very, very time consuming, a lot of studies. We need to do especially for the furnace, we need to, since that's a refractory inside the furnace. So, mentioned by Adam, so we ship it in such a way that the waves on the ocean will be not so much. Then the original design is in a 20-degree angle. So when the structural engineer did the calculation, the pipe will be bending 3 inches. So they still become malleable, but their factor will be not. So we did some mock up twice to side to make sure if we're going to experience this kind of wave at 20 degrees, we will not have problems with the refractory age of the bird. So it's a huge time preservation. That we did that, we consider a little bit at the early stage of the project. We just have that aha moment when we started receiving the first shipment at the site with some of these.
And what was interesting about that is we talked to a lot of people that had built the traditional stick built projects and had all kind of preservation issues. And we learned from that, and we actually did a better job with our modularization on the preservation during a shipment than the stick built project.
I would share maybe a more boring one. What our biggest failure so far is, I referenced a project earlier today, we had a productivity challenge. But that project, the shining star of that project was these 50+ modules that we sent from China into India. What didn't go well, but fortunately the productivity bounced the project, the delay that we had didn't cause any problems because it was so so it didn't get the shining star at our executive level. But it did cost us money, and if everything else was on schedule, we would have caused big problems in application. So we built these things in China, 50-some modules, all at $10 million each. But we have some proprietary stuff, so we were shipping in stuff from the US from other regions of the world, Europe, et cetera, to add to our process. So when it was delivered in May, it worked. It worked with processes around the world. But we added value to, so we had a contract with us and a China supplier, but we call it double the value. We couldn't get it out. The bill of lading was saying 10 million, but yet now it's worth 20 million. And it caused us 3 to 4 months of delays, and we did have to pay some extra tax. That was
my point is to introduce another question to the stage right now. Can you talk about modularization versus standardization? At least from a point of view, modularization adds a lot of complexity and customization to the project. Versus standardization, where we're trying to repeat things more often and often. Can you explain and
expand a little bit on that? How do you apply standardization to your modularization approach?
John.
I'll take a stab at this, but so when we get involved with clients that, existing customers, the idea is that what the conversation was earlier about why do we have to pay for engineering again? A lot of times the reason is because it's exactly the same except for everything that they changed on it, right? It's sometimes the owner has to get out of the way. And what I mean by that is you could have a plant being built in Arizona, but then you have one being built in Pennsylvania. And the idea is they're going to have the same footprint. But then you have the people on that project that want to start tinkering with it. Or you have it built in the States versus Europe, and they want Siemens versus Allen Bradley. Or let's just move this valve set here and change the orientation of it. And it's kind of like the butterfly effect, right? Small changes here, small ripples, big effects downstream of that. So I think sometimes we all need to collaborate and say, all right, if we're going to have a similar footprint on your projects and we want to standardize, then we got to stop tinkering with things. And that has to be communicated from the owner's side, from the top down, and not let as it gets filtered through engineering and then their project management team and then the plant and the maintenance folks say, oh, well, we prefer this valve versus that, or these type of pumps versus other type of pumps. That's how I believe if you want to standardize, there has to be buy-in all the way through the organization. Otherwise, I really don't know how you achieve it. Because we get that question oftentimes, well, you've built so many plants for us. Why are we still paying you for engineering? Well, stop changing stuff. We'd love to just pull a set of drawings out of the drawer, change the title block, and go. Now, you can't do that with every process, especially when you're in the brownfields and things of that nature, and you want to do a add-on or a renovation and upgrade the facility. Because you look at the oil and gas industry, there's no two refineries that are alike. They're just different. So I don't know if that answers your question or not. My best response.
Yeah, for us, we don't do engineering, so we're kind of at the mercy of the design. But the only times I've seen that happen is on projects where there's multiple units, and those units are made identical. So we've had several jobs where we'd never done that job before, but that project had multiple units that were identical. So we've been able to gain some efficiencies there. And then another couple of projects where the configurations were different, same type plant, different configuration, different number of units, but they, for the most part, kept the same. At least the idea around the structural design was the same. So the design, it wasn't the same set of drawings. The dimensions may have been a little different, but the concept and style of connections and things like that were kept the same. And so, at least, especially from an estimating standpoint, we knew what to expect, and from an assembly standpoint, we knew what to expect. And so, you're able to give a more accurate price, better estimate time that it's going to take, and so gaining some efficiencies there as well.
Mm-hmm.
And Bill, you mentioned it earlier about from a quality standpoint, when you go to mod yards, and you want to go in and you want to talk to them about how you view it being. But as long as you have communication with your fabricator, if they've got standards, can you live with that? If they're going to be more efficient with their standards, is that acceptable to your organization? And it's just having conversations and open dialogue about what's best for the project and how you can be most efficient. And if with the mod yard that you're using or the fab shop you're using, if they have a certain way of doing them. Oftentimes when we do work for, a larger EPC firm where we're not doing the design, you can have those conversations. And you'll find that they're very receptive. It's never a black and white, no, it absolutely has to be this way, but it's a start. This is what they'd like to see, but maybe they can't live with this. And that can help cost, schedule, quality, and help all the aspects of your project.
Yeah. I did have an opportunity to work on what we called X plants. We were going to build 10 of these plants. Serial number 1 was built in Brazil. Serial number 2 was Singapore. Pretty much the same, other than, each country wanted to put their stamp on, especially from architectural drawings. So when we got into that and the civil workforce foundations and stuff, but basically they were pretty much the same plant. Now, by the time we got to X10, which was about 10 years later, it had changed significantly, but it's safe to say that we saved, hundreds of $1 million, by trying to standardize that. And these were built all over the world. I think we built 2, 4, and 6 in Singapore. We built a couple in Brazil, some in Europe, and so everywhere you go. So from a regulatory and a government, requirements, it's going to be different. And in the U.S., you're probably going to see, maybe Doug, you can help me out, a lot of difference between states, isn't there? Yeah. So it'll never be identical. I don't think, but you have a lot of opportunity. There's a lot of savings by being able to standardize that. And I think so. So any other comments or questions? I think if not, thank you guys for your participation. And with that, we'll come to a conclusion we are finishing a little bit earlier, and I think that, some people have flights to take, but any questions, I would want to say, the committee is here to help progress the use of offsite construction modularization, not only I know a lot of our stories was with process and chemical plants, but also with commercial buildings, with even in a residential market type thing, if we can help that. I think we have a lot of people from the State Department here. You guys look at a different type buildings or process, a lot more security, I think, but any questions you have, please submit to us. We do get a lot of questions through the CURT app, or I think we can also go to CII and Michael and I work, together a lot on these things. So we like to hear the voice of the customer, and you all are the customer, and we think we have a solution for anything you can throw at us. I think that we have a lot of experience, a lot of people, maybe not a perfect solution, but we have some solution. But I've heard, and we talked earlier, you've modularized data centers, right? Yeah, you've done, and it was very good. It was, and it went on, and you actually took the first set, and I know maybe. Yeah. So I've been told by some of the big owners that you can't modularize a data center. I was in a meeting with my company, and we were looking at a ammonia urea plant, and they said, well, you can't modularize ammonia urea plant. I'm thinking, well, why can you not do that? It's maybe there's something I'm missing. I'm not hearing this. And when I finally got the answer, he said, well, no one's ever done it before. Well, that doesn't mean, that's not where we need to be. I started out talking about us going into World War II, building ships and airplanes. And, we had to catch up. We were years behind, but yet we had the people that had the knowledge and the innovation, and we did it. And we're not speaking German or Japanese right now. So obviously it was a pretty good plan, but we think we have some good ideas. And we rely on you guys for a lot of the ideas. We have a lot of good, knowledgeable members and people that have done a lot of good things. So with that, I would say, I think the message we did here today is the owners need to engage people early. That's the way to success. And there are going to be some trade-offs. The other thing that I hear a lot about is the spending curve. With modularization, you got to move and make some commitments back earlier. So your curve moves back to the left a little bit. Sometimes before you get full project approval, we got to buy equipment. We got some equipment's got 27, 30 months delivery. And when you go into a modularization, that schedule is going to compress because you're going to do your civil work and your modules all in parallel paths. And the other thing, big advantage I see is if you have to get permits, air permits, water permits, that all can be in the process as you're going forward. So, when you get that permit, we're ready to ship modules already. So that's a huge advantage. But so there's a lot of opportunities. There's still a lot that I think we can improve on and we need to get after. But I think we got the right people to do it. With that, I appreciate you guys showing up. And like I say, any questions you have, come back to the committees. We'll do what we can for you. Appreciate it and thank you.